In episode 30 of the CySec 101 training series, we're going through the web application basics, and this is a part of the web hacking module that we have just begun. And the web hacking module is a part of the Cybersecurity 101 training series, or the Cybersecurity 101 pathway of TryHackMe. And as a part of this module, we are going through web application basics, JavaScript Essentials, SQL Fundamentals, Burp Suite, and of course, OWASP Top 10. So this is going to be a strong module, and we're going to learn a lot about hacking web applications and websites, so on and so forth. So I'm really excited about going into this one with you. As always, we have our intro. This is actually a pretty long course, or this specific video I think is going to be pretty in-depth. So we do have the introduction, we have web application overview, uniform resource locator, HTTP messages, HTTP requests, which is the request line and the methods, and then we go into the headers and body, status line and status codes, and then again headers and body, but these are for the response. So we have the requests and then we have the responses, and then from there we have security headers, and then we have a practical exercise as well, and then we're going to go through the conclusion, and we are going to wrap it up and you'll be dismissed. This is a free room inside of TryHackMe, so anybody, as long as you just have a basic free subscription to TryHackMe, you can access this room. You can access the exercise for the practical task and everything else as well. So I do encourage you to try it out if you haven't done so already. If you don't have a TryHackMe subscription, I encourage you to get it. It's absolutely for free. All you need is an email and a password, and then if you want to go get the paid account as well, there's a discount link in the description below that you can use to get a discount off of your monthly purchase price. So that is it for our introduction to our web application basics video. If you'd like to support the channel, consider joining Hackaholics Anonymous, the premier YouTube community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server and early access to content, but the agent, guardian, master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And you can join by simply clicking the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the web application basics room. All right, here we go. So in this room, we're going to walk through the key elements of a web application, like the URL itself, the HTTP requests and responses. And if you're starting and you want to get a handle of the essentials, or if you're just looking to build or work with web applications, this is a great room for you, because we're looking at web applications from the context of cybersecurity, right? So by completing this room, you're going to understand what a web application is and how it runs in a web browser, breaking down the components of a URL and seeing how it actually helps access web resources, learning how HTTP requests and responses work, getting familiar with the different types of HTTP request methods, understanding what different HTTP response codes actually mean, and checking out HTTP headers and how they work and why they matter for security. And that's basically it for the breakdown of the introduction of this video. So let's jump into the overview of the web application. All right, so here's an analogy. We always start these things with a little analogy or story. So imagine there's a web application as a planet, right? So consider that the web application is a planet. Astronauts traveled to the planet to explore its surface, similar to how someone uses a web browser to explore or browse a web application. Although we only see the surface of a planet, a lot is going on under the surface. So you can imagine that the whole planet as a web server with many things going on under the surface of the web server, yet all we can usually see is the surface of the web pages or the application. We will now explore the various components that make up a web application. There's something called the front end, and it can be considered similar to the surface of the planet, the parts that an astronaut can see and interact with based on the laws of nature. A web application would have a user interact with it and use a number of technologies like HTML, CSS, and JavaScript to be able to do that interaction. HTML stands for the Hypertext Markup Language, and it's a foundational aspect of web applications. It's basically the most basic element of a web application is HTML. HTML. It's a set of instructions or code that instructs a web browser on what to display and how to display it, and it could be compared to simple organisms living on the planet. And they have DNA, which is the instructions for how simple organisms are put together. CSS, also known as the Cascading Style Sheet, in web application describes the standard appearance, such as certain colors, types of text, and layouts. Continuing the analogy with DNA, these could be compared to the parts of the DNA that describe the color, shape, size, and texture of the simple organism. And if you pay attention to the images on the left right here, you can see how the image gets a little bit more sophisticated with each layer of code, right? So HTML is literally the skeleton of the whole thing. It's the basic structure. And then CSS style sheets is where the coloring of the font comes in, and the various font styles, and the background color, and the menu shape and size, and so on and so forth. And then we have JS for JavaScript. And this is the part of the application on the front end that enables more complex activity in the web browser. So HTML can be considered a simple set of instructions on what to display. JavaScript is more advanced set of instructions that allows choices and decisions to be made on what to display. So in the planet analogy, JavaScript can be considered the brain of an advanced organism, which allows decisions to be made based on what and how something interacts with it. So JavaScript is more advanced interaction instructions and mechanisms versus HTML, which is, again, more like the skeleton, like the bare bones, the chassis of the website. JavaScript is where the interaction comes in, and you can have advanced interactions. For example, animated menus, as an example, falls under JavaScript. Then you have the back end. So the back end of the application is things that you don't see within a browser, but they're important for the web application to actually function. On a planet, these are the non-visual things, the structures that keep a building standing, the air, the gravity that keeps feet on the ground. A database is where information can be stored, modified, and retrieved. A web application may want to store and retrieve information about a visitor's preferences on what to show or not to show, and this would all be stored inside of the database. A planet may have more advanced inhabitants who store information about locations in maps, write notes in a diary, or put books in a library and files in a filing cabinet. There are many other infrastructure components underpinning the web application, like the web server, the application server, storage, various networking devices, and other software that support the web application. On a planet, these are roads that are present, the cars that run on the roads, the fuel that powers the cars, so on and so forth. And then you have the web application firewall, which is an optional component for web applications, and it helps filter out dangerous requests away from the web server and provides an element of protection. This could be considered similar to how a planet's atmosphere can protect inhabitants from harmful UV rays. That potentially could be the web application firewall. I don't know how I feel about this analogy of using a planet to kind of describe a web application, but it is what it is. I'm not the one who designed this course. So in summary, there are many components involved in delivering a web application. There's front-end components like the HTML, CSS, and JavaScript, which focuses on the experience inside the browser. And then you have the back-end components like the web server, database, and the web application firewall that are the engine under the surface that enable the web application to function. This simple introduction will be built upon in the upcoming tasks as we go further and further into this overall concept of a web application. So the first question is, which component on a computer is responsible for hosting and delivering content for web applications? So it's hosting and delivering content. That would be the web server. Which tool is used to access and interact with web applications? And that would be your web browser. And which component acts as a protective layer filtering incoming traffic? That would be the web application firewall. And do we have any more questions? We do not. Okay, great. So let's go into the Uniform Resource Locator. The Uniform Resource Locator, you know this more as the URL. I bet you didn't know that's what that actually stood for. So the Uniform Resource Locator is the URL. And it's the web address that lets you access all kinds of online content, whether it's a web page, a video, a photo, or other media. It guides your browser to the right place on the internet. Now, the anatomy of a URL is also something that's very interesting, especially when we're looking at this from the context of cybersecurity. So HTTP is known as the scheme. So it could be HTTP, HTTPS, so on and so forth. If you actually have a website that's been broken down like this, so if you have a URL that actually inside of the URL has the user and password as the parameters here, that it no longer exists where you can actually visibly see it, but maybe in the back end is something like, for example, on the URL that we see right here that I have, it just says TryHackMe room web applications. Maybe the back end URL is actually, it has my username and password inside of it. We just don't get to see it because it's protected, right? So we have the user : password that serves as the user, and then we have and then we have tryhackme.com being the host or the domain. And then we have port 80 right here, which ends up being the port number, and that's typically associated with HTTP for web servers or web applications. And then the path itself is where it starts after that port 80 / right here. So we see view room, and then this is the path, and then usually it has a query after the fact that, again, we don't see inside of our basic or inside of our URL that's up here, because it's a much more sanitized URL that doesn't view these things. But anything that starts after the question mark is essentially where the query begins. And so it says ID = 1. And then this piece right here, that's the hashtag that we see right here. This is more for, I would say, descriptor and identifier than for functionality. But it can be for functionality. So usually when you see hashtag task3 inside of the URL, and then you send this whole URL to somebody, when they press enter, it skips the page. So instead of landing at the very, very top of the page, it'll skip and it'll bring them to task 3. So that hashtag task 3 actually brings them to this fragment of the web page that is task 3. A lot of times it is a descriptor, but in a lot of cases as well, it actually has the functionality of bringing you to a specific part of the page. So this is the anatomy of a URL, especially, assuming that it actually has the user and the path and the query string and so on and so forth inside of it. So if you think of it as being made up of several paths, each playing a different role in helping you find the right resource, understanding how these parts fit together is important for browsing the web. So let's actually go into the details that they give us for everything that you just saw inside of that image. So it starts with the scheme, which is that HTTP part. It's the protocol that's used to access the website. The most common is HTTP or HTTPS, which is the secure version of the hypertext transfer protocol. HTTP is more secure because it encrypts the connection, which is why browsers and cybersecurity experts recommend it. Websites often enforce HTTPS for added protection, and usually if you visit a website that does not have HTTPS, your web browser will say, this is insecure, are you sure you want to continue? And then you actually have to manually say, click on something. It's usually like advanced options or something. There's like a link on that, and then when you click on advanced options, it says proceed to website. Then we have the user. So some URLs can include a user's login details, usually a username for sites that require authentication. This happens mostly in URLs that need credentials to access certain resources. However, it's rare nowadays because putting login details in the URL is not safe, not even very safe. It's literally not safe at all to do that. It can expose sensitive information, which is a security risk. And then we have the host or the domain, which is the most important part of the URL. So that would be the Google in google.com. And then it's basically the website that you're actually accessing. So every domain name has to be unique and is registered through domain registrars. From a security standpoint, looking for domain names that appear almost like real ones but have small differences. This is called typo squatting. These fake domains are often used in phishing attacks to trick people into giving up sensitive information. So, for example, Google could be Goog and then the number 1 and then E, and then that would be .com. Same thing for like Gmail or something like that. Or there's, the alphabet of various other languages can actually be also used to purchase a domain name. And so somebody could pick a character that looks just like the letter L, but it's actually not the letter L. It could be a different letter from a different language, but when you look at the domain, it looks like it's Google, and that's actually very, it's more of like an advanced version of domain name registration. And when I learned about that, I was like, wow, my mind didn't even stretch that far. I didn't even realize that you can actually do that. But then as soon as somebody tells you, you're like, oh, that totally makes sense. There's other languages that have characters that look like the letter L or something like that. And it's like, oh, of course that you could do that and put that inside of a domain name. So the port number helps to direct your browser to the right service on the web server. It's like telling the server which doorway to use for communication. Port numbers range from 1 to 65,535, but the most common are 80 for HTTP and 443 for HTTPS. And these are default, and if you really want to make sure that you protect your web server and you don't want people to find you by default ports, then you can always just change your web server ports, and sometimes 8080 could be used for a web server, or 8000 could be used for a web server, as long as it's not the default port 80. The path points to the specific file or page on the server that you're trying to access. It's like a roadmap that shows the browser where to go. Websites need to secure these paths to make sure that only authorized user can access sensitive resources. And then you have the query string, and it's a part of the URL that starts with a question mark. It's often used for things like search terms or form inputs. Since users can modify these query strings, it's important to handle them securely to prevent attacks like injections, where malicious code could be added to the URL and then it can do some kind of an injection directly into the web server. We also call that a server-side request forgery. And then we have the fragment, which starts with a hash symbol and helps to point to a specific section of the web page, like jumping directly to a particular heading or a table. And you can modify this too, like with query strings. It's important to check and clean up any data here to avoid issues like injection attacks. So, which protocol provides encrypted communication to ensure secure data transmission? That would be HTTPS. What term describes the practice of registering domain names that are misspelled variations of popular websites? And that would be typo squatting. And then what do we have? We have what part of a URL is used to pass additional information, such as search terms or form inputs, to the web server. And that was the query string. I believe that's it. So let's see if that's actually the answer. Query string. Very good. And that's it. So let's jump into HTTP messages. HTTP messages are the packets of data that are exchanged between a user, also known as the client, and the web server. So when you see the client error, that means that it's something on your end. When you see a server error, it means something on the web server's end, right? On the hosting provider, so on and so forth. These messages are important for understanding how web applications work because they show how users request and the server's responses are communicated. So the user makes requests and a server responds. Imagine an example of an HTTP request and an HTTP response where you can see key parts like the method URL headers and status codes. These are what make the client-server interaction possible. So the HTTP request is sent by the user or the client to trigger actions on the web application. And then we have the responses that are sent by the server in response to the user or to the client's request. And so this is what this looks like. We got to make a little bit zoom in right here. So this is what the HTTP request looks like, where we're making a post request to get the login page. And the post request is when we send data, meaning our username and password, for example, and we're sending it to the login page on TryHackMe. So it would be tryhackme.com/login, basically. And then the username would be Alexandra, and then the password would be secure password. And that's the data that's being sent via a post request to that web server. And then the web server responds with a 200 status code, which is the perfect status code if you've done everything correctly. And then as a response, it says login successful, success, and that's basically it. So this is what a response code or a response looks like from the web server, and this is what our request looks like to the web server. So each message follows a specific format that helps both user and server communicate smoothly. So the start line is like the introduction of the message. It tells you what kind of message is being sent, whether it's a request from the user or a response from the server. This line also gives important details about how the message should be handled. So that is the very, very first line that we see right here, which is the post, login, or the HTTP 101 200. Okay, that part, that's the start line. The headers are made up of key value pairs that provide extra information about the HTTP message. They give instructions to both the client and the server handling the request or the response. These headers cover all sorts of things like security, content types, and more, making sure everything goes smoothly in the communication. Then there's an empty line. And it's a literal divider that separates the header from the body. It's essential because it shows where the headers stop and where the actual content of the message begins. Without this empty line, the message might get messed up and the client or server could misinterpret it, causing errors. Then you have the body, which is where the actual data is stored. In a request, the body might include data that the user wants to send to the server, like form data, for example, Alexandra's username and the password. That was part of the body. In a response, it's where the server puts the content that the user requested, like a web page or API data, or basically just saying login successful. That all falls inside the body as well. So why understanding these things matters is these messages are the foundation of web application communication. If they're structured properly, everything works smoothly. Knowing how they work will help you diagnose issues in web communication, which means better performance and reliability. It's also really, really good for security and pen testing and hacking if you know how these things work and how to potentially manipulate them. Understanding HTTP messages helps you implement strong security measures to protect data during transmission or to manipulate web page requests. Which HTTP message is returned by the web server after processing a client's request, and that would be the response. And we have what follows the header in an HTTP message. That would be the body, right? So what follows the header is the empty line. Empty line, that's what it is. So we have an empty line, and that's basically it. So now let's look at the HTTP request, request line and methods. The request is what a user sends to a web server to interact with the web application and make something happen. Since these requests are often the first point of contact between the user and the web server, knowing how they work is very important, especially if you're into cybersecurity. And this is an example of a request. So we have the get method. So this is our HTTP method. You can have a get method, a post method, a put method, a delete method. There's a few different HTTP methods that can go inside of a request. And then this is the path that we want. So in this case, we want to get this specific page, which is the login page. And then this is the version of HTTP for this specific web application, right? And then these are the headers where the host would be TryHackMe. So it would be tryhackme.com/user/login.html. That's the page that we are getting with our request. The user agent is Mozilla, so probably Firefox or something. It accepts this. The accepting of the language would be English, US, and then we have connection to keep it alive so that you don't have to retry multiple times, and it just keeps that connection alive until you either close your web page or log out, something like that. So imagine an HTTP request showing the key parts of the key parts like the method, which is get or post, the path itself, which is the login version of the HTTP. These elements make up the basics of how a client or the user communicates with a web server. The request line or the start line, the very first line, is the first part of the HTTP request and tells the server what kind of request it's dealing with. And it has three main parts: the HTTP method, the URL path, and the HTTP version. So we have the method, which was either get or post, anything like that. You have the URL path, and then you have HTTP version. And a lot of times it could just be a / as the path because you're just trying to land on the home page. That's basically it. The HTTP methods come in a variety of shapes and sizes. They tell the server what action the user wants to perform on the resource identified by the URL path, and these are some of the most common. We have the get method that's used to fetch data from a server without making any changes. Make sure you're only exposing data that the user is allowed to see. So avoid putting sensitive information like tokens or passwords in GET requests, since they can show up as plain text, and that's very, very important. The POST method sends data to the server, usually to create or update something, and always validate and clean the input to avoid attacks like SQL injection or cross-site scripting. The PUT method replaces or updates something to the server, and again, make sure that the user is authorized to make changes to the server before accepting the request. This could be something like, updating your profile picture on your Facebook page or something like that. That could technically be an update, or updating your bio. That could technically be an update. So something that already has some kind of a value, and now you're changing or updating that value. That's all done with a PUT request. The delete is just like the name implies, it removes something from the server. So just like with PUT, make sure that only authorized users can actually do this. And besides these, there are a few other ones that are used in specific cases, and these are not as common. So we have the patch method, which updates parts of a resource and is useful for making small changes without replacing the whole thing, but always validate the data to avoid inconsistencies. We have the head method, which works like get, but only retrieves the headers, not the full content. It's handy for checking metadata without downloading the full response. And then we have options, which tells you what methods are available for a specific resource, helping clients understand what they can do with the server. And then we have trace, similar to options. It shows which methods are allowed, often debugging. Many servers disable it for security reasons, because it shows you what is actually allowed on the web server, and a lot of times that could give enough information to a hacker for them to start doing some shady stuff. The connect is used to create a secure connection like HTTPS. It's not as common, but it's critical for encrypted communication. Each of these methods has its own set of security rules. For example, patch requests should be validated to avoid inconsistencies, and options in trace should be turned off if not needed to avoid possible security risks. And then you have the URL path. So the URL path tells the server where to find the resource that the user is asking for. So in the URL here, tryhackme.com API users 123, the path is basically after.com. So it's anything after.com. That's the path that we are trying to retrieve, which is the API user 123, and it identifies a specific user on that API, right? So attackers often try to manipulate the URL path to exploit vulnerabilities, so it's crucial to validate the URL path to prevent unauthorized access, sanitize the path to avoid injection attacks, and protect sensitive data by conducting privacy and risk assessments. And this was something that happened as recently as 2024 with Microsoft Outlook, and that was the moniker link video that we did maybe like 3 or 4 episodes ago, 5 episodes ago, and it was the very first episode for the exploitation portion of the CySec 101 series that we were in, and that vulnerability was literally in 2024, and it was on Microsoft Outlook, and it was based on the modification of the URL. So the attackers learned how to, essentially what they did was they would put an exclamation mark inside of the URL, and they were able to manipulate the URL so that if somebody clicks on it, they automatically capture the credentials of that user just by the user clicking on the link, which was insane. And it wasn't just an exclamation mark, it was like an exclamation mark, and then after the exclamation, they had the actual exploit inside of the URL. But that was basically a perfect example of what we were talking about here, where they manipulate the URL to exploit vulnerabilities. So the HTTP version shows the protocol version used to communicate between the client and the server, and the rundown of HTTP versions, the most common ones. We had the 0.09 that was in 1991, which is the first version, only supported GET requests. And then you had 1.0, which is in 1996, 1.1 in 1997. The 1.0 added headers and better support for different types of content, improving caching. 1.1 brought persistent connections, chunked transfer encoding, and better caching. It's still widely used today, and that was from 1997. We have HTTP 2 from 2015, which introduced features like multiplexing, header compression, and prioritization for faster performance. And HTTP 3, which was from 2022, built on HTTP 2, but uses a new protocol, which is QUIC, for quicker and more secure connections. And so although HTTP 2 and 3 offer better speed and security, many systems still use 1.1 because it's well supported and works with most existing setups. However, upgrading to 2 or 3 can provide significant performance and security improvements as more systems adopt them. Now, which HTTP protocol version became widely adopted and remains the most commonly used version? And that was HTTP/1.1. And which HTTP request method describes the communication options for the target source, allowing clients to determine which methods are supported by the server? And I think that was options, right? Yeah, that is options. And in a request, which component specifies the specific resource or endpoint on the web server that the client is requesting, typically appearing after the domain? And that would be the URL path. And that's it. So now let's go to headers and body. Request headers allow extra information to be conveyed to the web server about the request, and these are some of the common headers. So the host specifies the name of the web server that the request is for. So for example, tryhackme.com. The user agent shares information about the web browser that the request is coming from, and Mozilla 5.0 is most likely Firefox. The referrer indicates the URL from which the request came from. So it could be coming from google.com, for example. Cookies are information the web server previously asked the web browser to store, and it's held inside of its cookies. So usually, if you have your cookies stored, it makes sure that you don't have to re-log in again, or it reloads your session from where you last left off, so you can kind of pick up where you left off, so to speak. The content type describes what type or format of data is in the request. And of course, these are just the examples that we see right here. The request body, so in requests like post and put, where the data is being sent to the web server, as opposed to requests from the web server, the data is located inside the request body. The formatting of the data can take many formats, but some common ones, are URL encoded form data, JSON, or XML. And the URL encoded, which is application X, this is essentially what you see inside of the body, is a format where the data is structured in pairs of key and value, key value pairs, basically, where you have a key equals value. This is basically what the syntax looks like. Multiple pairs are separated by an AND symbol, such as key 1, value 1, and key 2, value 2. Special characters are percent encoded, so you don't actually see the character. You do see some kind of a URL encoded version of the character. And so this would be an example right here where we see the key value pairs. So you see application URL encoded, and then we see name equals Alexandra, so that's one key value pair, and then age equals 27 and country equals US. So there's 3 key value pairs. We have form data, which is a multi-part part form or form data technically, and this is basically what we see here. Technically, this is technically form data, I believe, because it looks like it's a form that was URL encoded, right? So form data allows multiple data blocks to be sent, where each block is separated by a boundary string. The boundary string is the defined header of the request itself. This type of formatting can be used to send binary data, such as when uploading files or images to a web server. So this is what this kind of looks like. So we have a WebKit form boundary, and so the content would be form data, name, username. That's what we're sending. And then we have Alexandra, and then the content disposition is the profile pic, file name Alexandra JPG, and then we have the binary data that's also going with it. And then this is the end of the form boundary, or excuse me, this is the for the binary data. This is the other form boundary. But you can see right here, right? So for the form data username being Alexandra, let's say, we have Alexandra's username that is being submitted with this other form boundary right here that we see here. Or I think, you know what? My bad. So based on what it says over here, the boundary string is defined header of the request. So this is where the header is, and then everything inside of this, including this right here. That's all this portion. And then we have this and as another boundary. So everything inside of that right here would be for this boundary. And then that includes the profile pic and Alexandra JPG, so on and so forth. And then we have another one at the bottom, supposedly. So it's all separated by the WebKit form boundary portion, where this is all one part, and then anything between these things is basically another section. In this format, in the JSON format, the data can be sent using the JavaScript object notion structure, and data is formatted in pairs of name value where they're separated by the colon. Multiple pairs are separated by commas, all contained within curly braces or curly brackets. So this is what we see. This is the beginning bracket or brace, and then that's the closing brace. And then so we have name equals Alexandra, age equals 27, country equals US, and this is JSON encoding or JSON formatting. And then we have XML formatting, which is structured inside labels and tags, which have opening and closing, and these labels can be nested within each other. You can see in the example below opening and closing of the tags. So the opening would be this, for example, you have user, and then the closing has that /, and this is how you can tell that there is a closing tag. And for the name, there's also a closing tag. For the age, there's a closing tag. The country has a closing tag. Essentially, in XML, anything that has an opening tag has to have also a closing tag. Otherwise, the code breaks and it doesn't work. And XML is kind of like the more advanced version of HTML, but HTML looks just like this as well. HTML has an opening tag and a closing tag, and they work inside of these little greater than, less than symbols right here. And this is basically what it looks like. So essentially the same data, right? Just different formatting. So which HTTP request header specifies the domain name of the web server to which the request is being sent? And that would be the host. What is the default content type for form submissions in an HTTP request where the data is encoded as key value pairs in a query string format? So it's the one where we have key value pairs in a query string format, and that was the one up here, I want to say. Key value pairs, query string format. I don't think that's the one. It should be right here, key value pairs. So this is the application XForm encoded portion. So we're going to go do that, and then we're going to just bring this and paste that here. And which part of an HTTP request contains additional information like host, user agent, and content type, guiding how the web server should process the request? And that is also over here. So let's go, and I want to say it's form data, right? Boundary, no, this is not form data. The URL encoded, where the no, request body, right? Are posted where data is set to the web server. The formatting of the header can make forms. I think it is the request body, right? Or is it the request header? So hold on. Can allow information to be conveyed about the request. Some comments are, maybe it is the header. I feel like it's the header. It's either the header or the body. It's one of the, it's one or the other. But I think it's the header. So let's see, request header. Is that right? That is right. Okay, great. Perfect. All right, cool. It was a 50-50 chance that it was either going to work or it was going to fail, and then we would end up with request body, one of those two. But so that's the part of the request that contains additional information like the host, the user agent, and content type, guiding how the web server should okay, I see. Yes. That is indeed the request header. Okay, very good. Now let's talk about responses. So these are the responses coming from the web server. So what we see here are a couple of response codes, right? So 200 is, as the check mark implies, it's a good one. And then 500 and 404 are some kind of error response. So when you interact with a web application, the server sends back an HTTP response to let you know whether your request was successful or something went wrong. These responses include a status code and a short explanation called the reason phrase that gives insight as to how the server handled your request. So the status line, which is the first line in every HTTP response code, is called the status line. And it gives you three pieces of info: the HTTP version, which tells you which version of HTTP is being used; the status code, which is a 3-digit number showing the outcome of your request; and then the reason phrase, which is the message explaining the status code in human readable terms, if just in case you don't know, you haven't memorized the status code, right? So Since we already covered the HTTP version in task 5, let's focus on the status codes and the reason phrases. The status code is the number that tells you if the request succeeded or failed, while the reason phrase explains what happened. They fall into 5 main categories. You have informational responses that are in the 100 range. So it goes from 100 to 199. And these mean that the server had received part of the request and is waiting for the rest and its keep going signal. That's basically what it is. So anything inside the 100 range is basically a keep going signal. The success range is in the 200 range, so from 200 to 299, and it could mean everything worked as expected, and it could be, as long as it has something that starts with a 2, you can most likely get access, or you've already gotten access, and that's basically what the response code for a successful request is, right? So it could be anything that ranges that means that you're good, right? The server processed the request and sent back the requested data. And then you have the redirection message that is inside of the 300 range, 300 to 399. And they tell you that the resource that you requested has moved to a different location, usually providing the new URL of the location, because it means that it's accessible still to you at your user level. It's just the location has changed. Then there's the 400 to 499, usually a 404 error is what most of us see. And these indicate a problem with the request. So maybe the URL is wrong, or you're missing some required information like the authentication or something like that. But typically, you most likely, if you have been online for any length of time, at the very least, you've most likely ran across some kind of a 404 error where you tried to access a page that was no longer there, like the URL is broken or something like that. So you see a URL error, a 404 error. And then you have the 500 range, which is a server error. So the 400 range is a client error. So this is on your end, right? Like you did something wrong as the client. The 500 range is a server error. And this means that the server encountered an error while trying to fulfill your request, and they're usually server-side issues and not your fault, meaning the website has to fix something on their end. So the most common status codes that you'll run across would be the 100 to continue. So the server got the first part of the request and is ready for the rest of it. 200 is an okay, meaning it was successful and the server is sending back the requested resource. 301 is moved permanently. So you're requesting something that's been permanently moved to a new URL, and the new URL from now on, you got to use that. 404 is not found, so the server couldn't find the resource that was given. Double check that you've got the right address or the right URL. And 500 is an internal server error. Something went wrong on the server end and it couldn't process the request that you made. So which part of the HTTP response provides the HTTP version status code and a brief explanation of the response's outcome? And it's the first line. So it's the status code, or actually it should be the, it is the status code, right? So status line. So status line, it gives you 3 things: the code and the reason and the phrase. So that would be the status line is the information. Which category of HTTP response code indicate that the web server encountered an internal issue or is unable to fulfill? And that's the 500 series. So the internal server error is that part. And so we'll just copy and paste that right there. Whoops. Come on. Oh, really? It says that the web server encountered an internal issue or is unable to fulfill the client's request. That it is an internal server error. Or maybe 500 is specifically the internal server error. So it could be server error responses. That's probably what the answer is that we're supposed to do. There we go. Which HTTP status code indicates that the requested resource could not be found on the web server? And that would be 404. And boom. All right, so we're good. So now we can move to HTTP response headers and body. When a server responds to a request, it includes the HTTP response headers, which are basically key value pairs. And these headers provide important information about the response and then tell the client, which is the browser, the web browser, your browser, how to handle the response. So picture an example of an HTTP response with the headers highlighted. This is the picture right here. Key headers like content type, content length, and date give us important details about the response of these servers. So we have This is the first line, the status line, right? So HTTP 1.1 status is 200, okay, so we got a good response here. We have the content type, which is the application JSON, content length, the date and time of this thing, the message, login successful, and status, which was success. And then you can see that this is JSON format because of those little squigglies. And then the way that it's been outlined, we have the key value pair separated by colons and a comma right here. So that is a response example. So required response headers. These are crucial for making sure that the HTTP response actually works properly, and they provide essential info that both the client and server need to process everything correctly. So we have a couple of important ones right here. So you have the date, for example. This header shows the exact date and time where the response was generated by the server. You have the content type, text HTML, for example. It tells the client what kind of content it's getting, whether it's HTML, JSON, or something else. It also includes the character set like UTF-8 to help the browser display it properly. And then we have the server, which is Nginx in this example, and it shows what kind of server software is handling the request. It's good for debugging, but it can also reveal server information that might be useful for attackers. So many people remove or obscure this specific value, which is a very good idea, because if it is Nginx, especially if it gives you the version of Nginx server that's running, that's also really, really good information that you can use to kind of manipulate your requests and responses. So the other common request headers that we have are the set cookie. So setting your cookie for your session ID. This sends cookie from the server to the client, which the client then stores and sends back with future requests. And to keep things secure, make sure that cookies are set with HTTP only flag so they can't be accessed by JavaScript, and the secure flag, which is only for HTTPS. You have the cache control. This tells the client how long it can cache the response before checking with the server again, and it can also prevent sensitive info from being cached if needed using the no cache. And then you have the location, so index.html, for example, being the home page. That's typically what the home page's path is. If it's not just a /, it's index.html that is reserved for the home page. And it's used in redirection, which is the 300 response codes. It tells the client where to go next if the resource has moved. If users can modify this header during requests, be careful to validate and sanitize it. Otherwise, you could end up with open redirect vulnerabilities where attackers can redirect users to harmful sites. Then you have the body of the response. And this is where the actual data lives, things like HTML, JSON images that the server sends back to the client to prevent injection attacks like cross-site scripting. It's always good to sanitize and escape any data, especially user-generated content, before including it in the response. And the question we have here is, which HTTP response header can reveal information about the web server's software and version, potentially exposing it to security risks if not removed? And that is actually our server right here, this thing right here. So we can do just a basic server, and that would be our answer. Which flag should be added to cookies in the set cookie HTTP response header to ensure that they're only transmitted over HTTPS, protecting them from being exposed during encryption, which is not no cache, it is HTTP only. It's this one right here. And there we go. Oh, really? I see. So protecting them from being exposed during unencrypted transmissions. I thought that was it. So it says response to ensure that they are only transmitted over HTTPS. And I thought that was it. So, oh, secure flag, secure flag, secure. That's the answer. There we go. Which flag should be added to cookies in the set cookie HTTP response header to prevent them from being accessed via JavaScript, thereby enhancing security against, I'm going to say is it no cache? No, let's see. The set cookie is to prevent them from being accessed via JavaScript. So prevent them from being accessed via JavaScript. Let's see. That one is the HTTP only. That is the code. Sweet. All right, so let's talk about security headers. Security headers help improve the overall security of the web application by providing mitigations against attacks like XSS, cross-site scripting, clickjacking, and others, and we'll now dig deeper into these specific headers. So you have the content security policy, you have the strict transport security, X content type options, and referrer policy. You can use a site like securityheaders.io to analyze the security headers of any website. After the discussion of this task, you will hopefully have a better understanding of what it is actually reporting on. And let's just visit that site real quick just so we can see what it does. So we have, security headers. So let's do tryhackme.com and let's see what the analysis of that is. And, what do we got? So we got strict transport security, content security policy, X-frame options, X-content, referrer policy, permission policy. These are all the headers that actually do exist. You should work on your security posture immediately, is what it says. Maybe they're trying to sell us something. These are the missing headers, it seems, where it says strict transport. All these things seem to be missing from TryHackMe. And then we have our raw headers that are available here. That's so funny that that's like what's missing. Although I feel like it's not missing. I feel like maybe just as the base domain, maybe that's what's it doesn't have it because it's just a basic domain without people logging in or something like that. That would be so funny. I mean, if anybody from TryHackMe is watching this, then you have a good review from securityheaders.io. So CSP, Content Security Policy, is an additional security layer that can help mitigate against common attacks like cross-site scripting. Malicious code could be hosted on a separate website or domain and then injected into the vulnerable website. A CSP provides a way for administrators to say what domains or sources are considered safe and provides a layer of mitigation to such attacks. Within the header itself, you may see properties like the default source or script source, defined, and many more. Each of these give an option to the administrator to define at various levels of granularity what domains are allowed for what type of content. The use of self is a special word or special keyword that reflects the same domain on which the website is hosted. So the use of self is very interesting. So looking at an example CSP, we have content security policy, default source, self. I see script source, self. And an HTTPS TryHackMe, style source, self. So this is a special keyword that reflects the same domain on which the website is hosted. Interesting. We can see default source, which specifies the default policy of self, which means only the current website. Script source, which defines the policy where the script can be loaded from, which itself is along with the scripts hosted on TryHackMe. And then we have style source, which specifies the policy for which the CSS style sheets can be loaded from the current website itself. Strict transport security, also known as HSTS, ensures that the web browsers will always connect over HTTPS. So if we look at this, we have strict transport security. Max age is 600. I think this is in seconds right here. It includes subdomains and preloaded. So max age is the expiry time in seconds for this setting. Include subdomain, an optional setting that instructs the browser to also apply settings to all the subdomains. And preload is an optional setting that allows the website to be included in preload lists. Browsers can preload lists to enforce HSTS before even having their first visit to a website. X content type options can be used to instruct browsers not to guess the MIME type of a resource, but only to content type header. This is an example where you say no sniff. So no sniff is the directive that instructs the browser not to sniff or guess the MIME type. And the MIME type, just to kind of get the breakdown here, it's the multi-purpose internet mail extension, which is an internet standard that extends the format of email messages to support text in character sets other than ASCII, as well as attachments of audio, video, images, and application programs. So you don't want it to guess the MIME type, which is the standard that extends the format of email messages. So the referrer policy controls the amount of information sent to the destination web server when a user is redirected from the source web server, such as when they click a hyperlink. So the header is available to allow a web administrator to control what information is shared. And there are some examples of the refer policy. So when you land on somebody's blog and you click on a link and you leave their blog, this is the policy that determines how much of your information from the first blog is being sent to that website that you just clicked on through the hyperlink. So refer policy, no refer, same origin, strict origin when cross origin. So no refer completely disables any information being sent about the referrer. Same origin, this policy will only send refer information when the destination is part of the same origin. This is helpful when you want to refer information past when hyperlinks are clicked within the same website but not outside for external websites. Strict origin only sends the refer as the origin when the protocol stays the same. So a refer is sent when an HTTPS connection goes to another HTTPS connection. And then strict origin when cross origin is similar to strict origin except for same origin request where it sends the full URL path in the origin's header. So this is all about the referrer policy. Now, in a content security policy configuration, which property can be set to define where scripts can be loaded from? So we're going to go to our content referrer policy, and it says where scripts can be loaded from. And this will be specifies the type of self, which means the only current website. So default source, I would say. So default source, script source is where the script can be loaded from. So I would say script source is probably the one. So let's try that. Very good. When configuring the strict transport security header to ensure that all subdomains of a site also use HTTPS, which directive should be included to apply the security policy to both the main domain and its subdomains? And this one is going to, where is it? Include subdomains right here. That's the one that we want to use. And then we got which HTTP header directive is used to prevent browsers from interpreting files as a different MIME than what is specified to the web server, thereby mitigating the content. And that was the one that we had right here, which is no sniff. We don't want you to try to sniff or try to guess what we're doing. We want it to be discovered. Okay, very cool. Now, the practical task, here we go. I got to zoom out on this so that we can actually view this website. All right, for this practical exercise, we're going to use an emulator for making demo HTTP requests, and using what we've learned, we're going to answer the questions that we have below. So let's visit this site here, and we have it right here. So it says, would you like to take a guided tour to learn more about how to get started? I'm going to skip that. And then hopefully that doesn't come and bite me in the butt later. Okay, so it says make a GET request to API users. What is the flag? So we are going to change this right here. And then we're going to just change. Let me see if I can actually modify this here. Maybe I should have GET request. TryHackMe. Let me see. Update the parameter. Enter the value. I feel like I should have actually paid attention. No, you know what? So we're going to, I think I just need, yeah, there you go. That's what I need to do. Boom. I know what I'm doing. Let's go. And then go. And here we go. And so we got that. And where's my flag, which is right here. So THM, you have just found the user list. Boom, boom, and boom. So all I had to do was just change the domain right here. The path, which is API users, that's where we're trying to go. And we now have access to the user list. Look at that. Alice, Bob, Charlie, and what else do we have? Their countries and their ages. And that's all we got. All right, so make a post request to HPI user 2 and update the country of Bob from UK to US. So we're going to change this up here to post, and then we're going to update the country of Bob to HPA users 2. So there's that. And then let's see if I can make a post request. So right here, it's going to be country, I believe. And then the value is going to be US. And I'm going to save that and proceed. And then we're going to go. It says cannot find page. So what's the hint? It says Watch out for case sensitivity. I see. So let's try this one more time. So I am making a post request, and it's going to API user 2, and we're updating the country of Bob. So maybe I just need to change the country from a uppercase to a lowercase. So let's delete this one more time, and then we'll do country lowercase, and the value is going to be US, and then save that, proceed, go. Okay, that is one important thing that I did not do. I was doing users 2, and it should be user 2. And then here we can go ahead and make this modification real quick one more time. I think that was a really big key right here. So we'll close that one more time, and then we'll do country, and we'll do US. And let's save that, proceed, and then run that. There we go. User 2 successfully updated. And okay, so now what? So it says make the request and update the country of Bob from UK to US. What is the flag? I mean, I made the request, so where's my flag? Got it. Okay, so the country actually had to be a lowercase c instead of an uppercase c. And that's our flag. So just to show you what the value was, it is a lowercase c in country, and then US was the same. And that is our response right there. So we're going to submit that. That's what they meant when they said case sensitivity. And now make a delete request to API user 1 to delete the user. So that should be fine. We're going to do delete user, and then we're going to do user 1. Let's see. We're going to delete this right here as well, and make sure that that's all good. Okay, good. So we're deleting user 1. Go ahead, and that's it. So that one was easy money. And there we go. We were able to finish all of those responses. So not hard to do, really. This was fairly simple. So we just sent a delete request on the last one. We sent a post request on this one, and it was user 2. And we just changed the parameters right here. And we added a lowercase country, and then US was the capital case value. And then the very first one was just a get request to our users list that we were able to do, and we were able to retrieve all the users, and that is the way cookie crumbles. So we are officially done. So let's see what the conclusion says here. The conclusion basically says that we completed all the tasks. Hope you enjoy learning about the elements of an HTTP web application. So I hope you enjoyed learning about it as well. And I hope you learned a lot. I hope it was one of those things that it was kind of eye-opening. I know that it was like more of a lecture, and there wasn't as much practical stuff that we did, with the exception of those like few little exercises at the end over there, compared to what we did in the last 2 or 3 videos when we were using Metasploit to do an exploit and then hacking to a Windows machine. Like, compared to all of that, this seemed like a walk in the park. So hopefully you still had fun with it, though. Hopefully you still learned something, and you were able to walk away with a new introduction to a very important concept, because pretty much everything is now being hosted either on a web application or a web server or something like that. So if you understand the basics of HTTP methods and requests and responses and all of that stuff, then you have the exact foundation to go into some of the more advanced stuff as we go into Junior Pentester and Pentest Plus and so on and so forth. So I hope you got a lot of value out of it. And yeah, let's wrap it up. If you did get any value from this video, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out, especially in the CySec 101 series, as we it seems like we've gotten to the second half of it, and we're approaching kind of like the end of the CySec 101 series. And there is a massive playlist that's already on CySec 101, and that is actually in our playlists that are available over here. So definitely check it out if you have not checked it out already. And drop a comment if you have any questions as we go through this. If you just want to say hi, so on and so forth. I am very responsive in the comment section, so I do respond to everybody's comments as they come in. And if you have really good questions, I'll respond to them them in a video format, or very similar to what we're doing here, in a playlist format, so that you can get all of your questions answered. So make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out, especially in the CySec 101 training series, and of course in everything else that's available on the channel as well. And then drop a comment, make sure you say hi or ask your questions, even if you just want to say thanks. And a great way to say thanks would be to support this channel by joining Hackaholics Anonymous, the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content, but the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord servers. If not, I hope I see you in the comment section, and that's it. This is your boy Hank Hackerson at Hank Hacks Hackers. If you have a network and system attacker/protector, if no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video. Later. In episode 31 of the CySec 101 series, we're going to go through the essentials of JavaScript, which is a very important language in web development. And of course, we are inside of the web hacking module of the Cybersecurity 101 pathway of TryHackMe. And we're just going along the web hacking module today. We did the web application basics in the last video. We are going through JavaScript Essentials today. We're going to go through Essentials or Fundamentals for SQL in the next episode. And then we got a couple of tools that we're going to cover by the end of this module. So it's going to be a really, really good one. And this is what we have as the outline for this. So we have the introduction, essential concept, JavaScript overview, integrating JavaScript in HTML, abusing dialog functions, bypassing control flow statements, exploring minified files, best practices, and of course, the conclusion. And we do have a virtual machine that is kind of getting up and running as we wait for it. And that's pretty much it. If you'd like to support this channel, consider joining Hackaholics Anonymous, the premier YouTube community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server and early access to content. And the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the JavaScript Essentials room. JavaScript is a popular scripting language that allows web developers to add interactive features to websites that contain HTML and CSS. And we discovered in the last video that CSS is for styling. And once the HTML elements are created, you can add interactiveness like validation or on-click actions or animations. And all of these things can be done through JavaScript. Learning the language is equally important as that of HTML and CSS. And the scripts that are used in JavaScript are used primarily with HTML. This room and this video is designed as an introductory overview of JavaScript, specifically tailored for beginners with limited JavaScript experience, which is us. The primary focus is on teaching the fundamentals of JavaScript from a cyber perspective and how hackers utilize legitimate functionalities to achieve malicious results. The Linux fundamentals room is important for this. The web application basics and how websites work are all important for this, and we have gone through all of those. And the Linux fundamentals was way early in the CySec 101 playlist. Web application basics and how websites work were all a part of this specific module that we are going through. So the learning objectives that we have is understanding the basics of JavaScript, integrating JavaScript in HTML, abusing dialog function, bypassing control flow statements, and exploring minified files. I've already started the machine. It is up and running, and it seems like it's going to be a Linux machine. I think it's maybe Ubuntu or something like that. And we see that on the right here, and we do have our exercise files right over here. So, all right, here we go. Let's get it running. All right, we need a few essential concepts in order to make this work. The first one is a variable or variables. And if you watched any of the videos that we did on Python or the Linux Plus playlist, and at the end of that, there was the scripting videos. So if you've seen any of that stuff, you should be familiar with the concept of a variable. And a variable is a container that allows you to store data values inside of it. And like any other language, variables in JavaScript are similar to containers that store data. When you store something in a bucket, you also need to label it so that it can be referenced later easily. Similarly, in JavaScript, each variable has a name. When we store a certain value in a variable, we assign a name to it so that we can reference that later. And these are three ways to declare variables in JavaScript. We have the var, let, and const. While var is a function scoped, both let and const are block scoped, offering better control over variable visibility with specific code blocks. So var has to do with the various functionalities of the script, and then we have let and const that are block scoped, meaning that you have specific code blocks that would essentially be associated with those specific variables. In JavaScript, we have data types that define the type of value a variable can hold. So examples would be a string, which is basic text, a number, Boolean, which is true or false, and null, which means nothing, undefined, which means it doesn't have an actual definition or it doesn't have an designation, a value, and then the object, which is for more complex data like arrays or objects. And then we have functions that represent a block of code that's designed to perform a specific task. Inside a function, you group code that needs to perform a specific task. So for example, you're developing a web application that needs to print students' results on the web page. The ideal case would be to create a function called the print result and then roll number that would accept the roll number of the user as an argument. And then this is kind of what it would look like. So we have very similar to XML, right? Or HTML in general. It has the starting block and then the ending block. So everything would start and end so that you can say that this is just one block of text, right? So you have the starting, not block, I want to say the starting, I forget the technical term that we use for this thing. But essentially, if it starts with script, it has to end with that / and then script inside of those greater than, less than symbols. Then we have the function itself, which is the print result, and then we have these squiggly braces, and then inside of it is an alert that essentially pops onto the screen where it says username with roll number, and then feeding it the roll number variable has passed the exam, and then any other logic to display the result. And then we have a for loop here that says for let, so remember variable, right? So let is a variable. So for let I equals 0, I less than 100, I plus plus, print result the roll number. And I in this particular case would probably be the variable itself. And so if it equals 0, if it's less than 100, and then the plus plus, I don't know. So because I don't know JavaScript function, I'm pretty sure they'll explain it to us in a little bit. But this is basically the function, right? For this, essentially, it'll just print onto the screen that the username with whatever has passed the exam. So instead of writing the same print code for all the students, we'll use a simple function to print the result. And then we have loops that allow you to run a code block multiple times as long as the condition is true. Common loops in JavaScript are the for loop, the while loop, and do while, which are used to repeat tasks like going through a list of items. For example, if we want to print the result of 100 students, we can call the print result roll number function 100 times by writing it 100 times, or we can create a loop that'll be iterated through 100, so 1 to 100, and we'll call the print result function as shown below. So this is, I guess, what this portion is right here. So it goes from 1 to 100. As long as it's less than 100, it's just going to loop through it over and over and over and over again, and it's going to print the result of this function that we have right here. So for as long as we are less than 100 on our iteration, it's going to print that result, which is this piece right here, along with the roll number, which would be the specific variable for the user. And this I++, now I kind of understand what this means. It's essentially for every iteration, it's going to go up by 1. So I is going to be added 1 increment, and then 1 increment, and then 1 increment until it gets to 100. So it's going to start at 0, and then that'll be the first iteration. Then we're going to add 1 to it until we reach 100, or essentially 99, because we're not saying less than or equal to, we're just saying less than. So from 0 to 99 would be 100 iterations of this script. So there we go. So the request response cycle in web development, the request response cycle is when a user's browser, like the client, which is our browser, sends a request to a web server, and the server responds with the requested information. This could be a web page, data, or other resources, and you can learn more about it here. So let's see what this link is. And this is how websites work. So this is the how websites work room that we have available, and very, very basic, talking about HTML, JavaScript, sensitive data exposure, HTML injection, these various attacks that are available. And it's super, super, super basic. And it just talks about how a website works, and hopefully you know how a website works. And we did the very last episode, the episode right before this one, where we actually went to the request response cycle in much greater detail, and we looked at the various lines of a request, the various lines of a response, so that you can understand exactly how the code looks behind the scenes when you're making web requests and getting responses from a web server. So what term allows you to run a code block multiple times as long as it is a condition? And that should be called a loop. So let's see if that's right. And that is indeed right. So let's go to the JavaScript overview now. So now we get to actually create our first JavaScript program. JavaScript is an interpreted language, meaning that the code is executed directly in the browser without prior compilation. And sometimes you need to compile code so that it can run. This will just run directly in the browser without needing compilation. Below is a sample JavaScript code demonstrating key concepts such as defining a variable, understanding data types, using control flow statements, and writing simple functions. These essential building blocks help create more dynamic and interactive web applications. If it looks a bit new, don't worry about it. We'll discuss each step later on. So we have the hello world program. So these are comments, these forward slashes, the double forward slashes here that we see are comments. So this has nothing to do with the functionality of the code. And so we have console log hello world, which will probably print hello world onto the screen. The let age equals 25, which is the number type. This is a variable that we have right here. So let the age equal 25. And then if age is greater than or equal to 18, print that you're an adult. Otherwise, print that you are a minor. And then we have another function at the bottom right here where it's a greeting where it says hello. And then as long as we feed the name into it as the variable, it'll say hello Hank, hello John, hello Dave, hello Janine, whatever, right? So, and finally, at the very end, we have the calling of this function, which is these two essentially go together. The rest of these are operating independently as individual blocks of code. So JavaScript is primarily executed on the client side, which makes it easy to inspect and interact with the HTML directly within the browser. We use the Google Chrome console feature to run our first program, allowing us to write and execute JavaScript code easily without additional tools. So we are going to open Google Chrome by clicking the Google Chrome button. Once it's open, click the Control-Shift-I to open the console, or right-click anywhere on the page and select Inspect, and then it'll actually open up the console. And once you have that, you can actually go into the console tab. That'll allow you to run JavaScript code directly in the browser without installing additional software, which is very freaking cool. And so we're going to create a JavaScript program that adds 2 numbers and displays the results. And this is the code. So we're saying x is going to equal 5, y is going to equal 10, and the result equals x plus y. And then console is going to log onto the screen. The result is, and then it's just going to print the result of this variable that we have over here. And then that's essentially what that explains. And copy the code, paste it into the console. Once pasted, press enter, and you should see the result displayed, which is the result is 15. That's actually really cool that we can do that. So successfully created our first program. This is just the beginning, and there's so much more to explore as we dive deeper into this. So what is the code output of the value of x if x is changed to 10? And then in JavaScript compiled or interpreted language, it is an interpreted language. So let's actually go ahead and create our little output. I'm excited about that. That's actually very cool that we can do that. Okay, so this is a pretty slow virtual machine because that took a minute to actually load. And so we're going to right click on the screen. We're going to click inspect. It'll open this up. We're going to go to console. And now we have the code right here. I don't need you to reinstall Chrome. So I'm basically just going to type out the code because I really like typing code. And I wanted to get into my cells, right? I don't want to copy paste something. I want to start really practicing how to do this, excuse me. So we are going to do let x equals 5, and then we're going to do a semicolon at the end of that. Then we're going to do, oh, you know what? I see. So we do have to actually, so let me see, let x equals 5, and then I'll do colon shift enter. I see. So if you press enter just by itself, it's actually going to run the code entirely. So let x equals 5, and then the value, if the value of x is changed to 10, I guess it would give us a different result. So I'm just going to press enter one more time, and now I'm going to do let x equals 10. So there we go. And then we're going to do shift enter so we can write the next block of code or next line of code. Let y equals 10, and then shift enter, and then let result equals x plus y, and then semicolon, and then shift enter, and then console.log, and then we're going to say the result is, and then we're going to plus that with the result variable, and there we go. So this is what the actual block of code is going to look like. So let x equals 10. I'm kind of zoomed in and it's a little bit blurry, so this might be a little bit tough to read for you because the letters are so small. So we have let x equals 10, let y equals 10, let the result equals x plus y, and then console.log the result is, and then we're going to print the result. Now I'm going to press enter, and now it says the result is 20. So let me see if I can actually copy this right here. So let's see. I do have copy as a function, so let's do that. The result is 20. Boom, we got that result. That was really cool. I did not know that you could do that. You could write JavaScript code inside of the console of just Google Chrome or something like that. That's actually very cool that we can do that. All right, so let's go to integrating JavaScript in HTML. So in this task, it is assumed that we have a basic understanding of HTML and the structure. This section will explore how JavaScript can be integrated into HTML. Usually, JavaScript is not used to render content. It works with HTML and CSS to create dynamic and interactive web pages. If you're unfamiliar with HTML, reviewing it through the provided link is recommended. So I am familiar with HTML, and I'm going to try to explain this as best as I possibly can. So that you can also kind of get a crash course on it as we go along. There are two main ways to integrate JavaScript into HTML, internally and externally. So internal JavaScript refers to embedding the JavaScript code directly within the HTML document. This method is preferable for beginners because it allows them to see how the script interacts with the HTML. The script is inserted between the script tags, and these tags can be placed inside the head section, typically used for scripts that need to be loaded before the page content is rendered, or inside the body section when the script can be utilized to interact with elements as they are loaded on the web page. So as an example, we're going to create an HTML document with internal JS, right click on the desktop and select create document, empty file, and name the file internal.html. And then right click on the internal.html file and choose open with Pluma to open it in a text editor. And then once the editor is open, we're going to write this piece of code inside of it. And so the doc type, this piece at the top, this tag, is basically saying that this is going to be an HTML document. It's very similar to the shebang line that is available when we're creating scripting inside of Bash or any kind of terminal type emulator where you have to just give it the shebang line at the very top. So the shebang line could say that you're actually creating a Bash script or you're creating a Python script, so on and so forth. So this is similar to that, where it's saying that this specific document type is an HTML document type so that the web browser can actually read it as such. And then the language is going to be English, and then we're going to have So notice that every piece of this, with the exception of this doc type portion, every piece of this has a closing tag. So there's the HTML tag at the very, very top, and then there's an HTML tag at the bottom that has that / that is a piece of the way that we can notice what a closing tag is. And then we have the head tag right here that has the head closing tag. And then we have the body tag, and then the body tag has a closing tag right here. And then we have the script tag, and then the script tag has a closing tag right here. And then you have the H1 tag, which is for the header, that has its closing tag. And then you have the paragraph tag that also has its own closing tag. So everything in HTML or XML has to have a closing tag that essentially matches the opening tag. And the difference would be what is inside of these tags. So for the header of the page, you would literally have the internal JS, which is the title of the page, and then there's the body of the page, and inside the body we have this content, and then we also have the script that is sitting inside of the body of the page as well. So this is our basic JavaScript. It's HTML that has JavaScript embedded in it. So after we paste the code, click File and select Save, which will save in the internal.html. Double click the file to open it in a Chrome browser, where you will see the following output, and the result is 15, the addition of 2 numbers. So notice addition of 2 numbers was our header right here, right? Header 1. So if we change this to H2, the text would be a little bit smaller because it's no longer a header 1 formatting. And then notice that the internal JS is actually what is inside of our head tag, which is the title of the web page. So it doesn't get displayed onto the screen, but it's actually the title of the tab that opens it. And then inside of the body is where we have the result is 15, which is being the output of our script that's inside of our body, basically. So in this document, we are using internal JS, meaning the code is placed directly inside the HTML file within the script tag. The script performs a simple task, adds 2 numbers, and then displays the result on the page. JavaScript interacts with HTML by selecting the element, which is P, with the ID result, and updating its content using the document get element by ID result inner HTML. This internal JavaScript is executed when the browser loads the HTML file. So this is not inside of our actual script or inside of our HTML page. This is what's being done within the browser itself. So the browser is actually executing this internally when the browser loads the HTML file. And then we have external JavaScript, which involves creating and storing JavaScript code in a separate file ending with a .js file extension. This helps developers keep the HTML document clean and organized. The external JS file can be stored or hosted on the same web server as the HTML document, or stored on an external web server such as the cloud. And we'll use the same example for external JS but separate the JavaScript code into a different file. So first we're going to create a script.js file, save it on the desktop, and this is going to be the script's content. So this is going to be the content of this .js file. And then we're going to create a new file named external HTML and paste the following code. Notice that the HTML code is the same as the previous example. The only thing that has really changed is that we now have a meta name, which is the viewport content width, and then the initial scale, and then we have the character encoding over here. And then inside of the body, we are just referring to the script.js as the source of our script. Now, this specific thing, if it was inside of a web server, most likely it would be placed in a different path. So it's whatever the path of the JavaScript file is that needs to go over here, so that we can make sure that that's literally where the script is pulling its contents from. And then when you run it, again, the result is going to be the same, and we're going to have the external JSBR title so that we know that we're actually dealing with internal or external, so that we're viewing those different results. So what we did was we used the source attribute in the script tag to load the JavaScript from an external file. When the browser loads the page, it looks for the JavaScript script.js file and loads it from the content from the HTML document. This approach allows us to create the JavaScript code separate from HTML, making the code more organized and easier to maintain, especially when working on large projects. Verifying internal or external. When pen testing a web application, it's important to check whether the website uses internal or external JS. This can be easily verified by viewing the page's source code. To do this, open the external.test located in the exercise folder in Chrome. Right-click anywhere on the page and select the view source code, which will be done like this. And then this will display the HTML code of the rendered page. Inside the source code, any JS written directly into the page will appear between the script tags without the source attribute. If you see script tag with a source attribute, it indicates that the page is loading external JS from a separate file. So in this particular case, we actually have this, and it's been blocked out so that we can go ahead and probably use it for one of the answers. For practical example, we're going to visit tryhackme.com in the browser and inspect the source code to identify how the website loads the JavaScript internally and from external sources. So we do have script source right here that shows the assets TryHackMe, and that's where the JavaScript code is pulling from. And then we also have there's several lines of script sources that are pulling from it, and then it seems like in this particular text we don't have anything else that is just pulling from internal source code. It looks like everything is actually pulling from an external source code, and that is, that's for the most part, as far as I can tell, there's nothing from this that is pulling from internally. There's no internal JavaScript. This is all source and source right here, and then source. So these are all external source JavaScript code. So which type of JavaScript integration places the code directly within the document itself? That would be internal. Which method is better for reusing the JavaScript across multiple web pages? That would be external. What is the name of the external JavaScript file that is being called by external test.html? And what attribute links an external JavaScript with the script tag? And that would be the source attribute. So what is the name of the external JavaScript file that is being called by external test.html? So we are actually going to, let me see, I'm just going to minimize this, and then I'm going to pull up the exercise file, and then we're looking for the external test.html, which is going to be this right here, external test right here. We have that, and then so it says attribute, so we're going to inspect this so we can look at the code, and it says what is the name of the external JS file that is pulling it. So now we're going to look at the code right here, so you can see the code, and then we have the head, and inside of the head would most likely would not be the source link for the JavaScript file. It would probably be inside the body, and inside the body we have script source and then thm_external.js. That is the name of the file. So thm_external.js would be the name of that JavaScript file. And just like that, we have our answers for all of these things. And I'm not going to create this because this is fairly straightforward. If you want to, because literally it would just give us the results that we see right here, the addition of two numbers. And then we just know that this one is being pulling from an external source code or an external JavaScript script, and then the very first one that we had was internally embedded into the actual code itself, where we have the script inside of these script tags right here. So for the most part, we're just going to leave that as is, because number one, it didn't require us to answer anything, but number two, I mean, it would literally, they're telling us to just copy paste this so that we can run it. And I feel like I don't need to do that, because you just saw what it does, and then we know what their output and the results are going to be. And we were able to just look at another HTML file that they created that we can go ahead and run and kind of mess with. So that is basically how this works. Feel free to rewind this particular section and go through it as many times as you need to really grab a good understanding of what the HTML code looks like, whether the script is internally being embedded into the actual HTML or it's external, where you're pulling from some kind of an external source, very much like what we have over here, which is the thm external.js. And then if we actually go and look at files right here, we can see that the thm.external or thmexternal.js is actually inside of this folder that has the script inside of it, and there's the hello.js and script.js. All of these things are actually in here as they created them for us. So this would not be difficult to do. So if I did internal.html, the addition of the two numbers is actually here, and then we can just look at the source code of this, and it would be exactly what we saw in the documentation as it was breaking it down for us. And then inside of it, we have the script inside right here that displays the contents for us. So all of that has already been created for us, and it's in here. We don't need to recreate any of these things. We just need to know how to read them and how to analyze them. So anyways, all of that being said, we can now move on to abusing dialog functions. One of the main functions of JavaScript is to provide dialog boxes for interaction with users and dynamically update content on the web page. It provides built-in functions like the alert, prompt, and confirm to facilitate that interaction. These functions allow developers to display messages, gather input, and obtain user information. However, if not implemented securely, attackers may exploit these features to execute attacks like cross-site scripting, which you will cover later in this specific module. We will be using the Google Chrome console in the upcoming exercises. So the alert function displays a message in a dialog box with an OK button, typically used to convey information or warnings to users. For example, if we want to display hello THM to the user, we would just do alert and then do hello THM. And then we can essentially just type this out and try it out. So let's actually go ahead and do that inside of the Google Chrome console here. So we actually have it over here, and I'm literally just going to write alert, and then we'll do hello THM, and then close the parentheses and press enter. And then we see that we got the hello THM. Google Chrome new tab page says hello THM. So that's very, very basic, and this is the script right there. I mean, script, quote unquote, right? But this is it. Alert, hello THM. That's basically it. And we can do this with a variety of different ways, I guess. A dialog box will be the message, and it'll appear onto the screen, as we see right here. The prompt function displays a dialog box that asks for the user for input. It returns the entered value when the user clicks OK, or null if the user clicks cancel. For example, to ask the user for their name, we would use prompt what is your name, and then to test this, open the console, paste the following, and ask for the user and then greet him. So it says name, prompt, what's your name, and then alert, hello, plus name. So let's try that. And so we're going to start this whole thing. We're going to say name equals prompt. And oh, that's literally already there. That's so crazy that it's like it just fills it in for you. So I'll just press tab and it fills it. That's so crazy that that was there. I wonder if like it's just remembering what somebody else did, and so it's filling it in or something. I don't know. But that's basically the script right there. So hello name, prompt, what is your name, and then hello name. So I'll press enter. Let's see if that actually works. Oh, there we go. I had to close the other one. So what is your name? Hank. And then we're going to say okay. Okay, hello Hank. That's pretty cool that we can do this inside the browser. I'm still like nerding out over the fact that we can do this just directly inside the browser. Once you paste the code and hit enter, a dialog box will appear and the value entered, We just saw this right here. The confirmation, so to confirm, the confirm function displays a dialog box with a message and two buttons, OK and cancel. It returns true if the user clicks OK and false if the user clicks cancel. For example, to ask the user for confirmation, we would use confirm, are you sure? And then we can just go ahead and do that ourselves here again. So we're going to do this. And I promise if I do it, it's literally right there. Confirm, are you sure? That's so crazy that it's literally doing that. And, oh, whoops, I was supposed to put the quotations. That is pretty insane that this does that. Confirm, are you sure? And I'm going to say yes. And then returned true. And then if I do confirm one more time, are you sure? And then do that, press enter. And then if I say cancel, it's going to return false. So we see that right here. So confirm, are you sure? The first time I clicked OK and it said true. And then if I say cancel, it will return false. So very, very interesting. I am absolutely nerding out right now. and it's super fun. So, all right. So how hackers exploit the functionality. So imagine receiving an email from a stranger with an attached HTML file. The file looks harmless, but when you open it, it contains JavaScript that disrupts your browsing experience. For example, the following code will show an alert box with the message hacked 3 times. So we see a document, right? So this is an HTML language English. The header is just going to say hacked as the title. And the body is just a basic for loop that is inside of the script. And inside the script, it says for, and then let I equal 0. So it starts with the first iteration being at the value 0. And as long as I is less than 3, we're going to add 1 increment to it. And then we're going to print hacked onto the screen. And then so that's just going to print hacked, hacked, hacked. And that's basically it. On the desktop, create a file called invoice.html, paste the above code, double click the file to open it, and the alert message will pop up 3 times, causing an undesired experience. So let's actually do that. Why not? I think it's already inside of my documents here. No, I don't have it here. Okay. All right. So we'll just create one. All good. So we're going to go here. We're going to right click here. We're going to create a document, empty file, and it's going to be called hacked.html, or the one that they have over here is the invoice.html. So it's actually here. So if I open up invoice.html, it's going to say hacked, 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 hacked. So that one was 5 times. So if we actually open this up and inspect it, we will see that inside of this there is this script right here, and it says hacked, and then as long as it iterates and it's less than 5, right? So it's going to click hacked, or it's going to display hacked 5 times. And honestly, imagine like not knowing what just happened, and then you're clicking OK every single time, and it just keeps popping up hacked, hacked, hacked. That would be very disconcerting. It would be like unnerving to go through that. So imagine if a bad actor sent you a similar file, but instead of displaying the alert 3 times, the number is set to 500. You would be forced to keep closing the alert boxes one after another. This is a simple example of how malicious JavaScript can be used to create an inconvenience or worse, therefore ensuring you to only execute JavaScripts from trusted sources. It is crucial to avoid such an undesired experience. Very true. Honestly, I would freak out. All right, so our question here, it says in the invoice HTML, how many times does the show hacked? That was 5. We just went through that. Which of the JavaScript interactive elements should be used to display a dialog box and ask for the user's input? That would be the prompt. And if the user enters Tesla, what value is stored in the car name prompt? What is your car name? In the car name variable? What? If the user enters Tesla, what value is stored in the car name prompt in the car name variable? Oh, Tesla. That was like, what? That was a trick question. I was like, what? What are you saying? What are you asking me? All right, cool. Let us look at bypassing control flow statements. Control flow in JavaScript refers to the order in which statements and code blocks are executed based on certain conditions. JavaScript provides several control flow structures like if-else statements, switch statements to make decisions, and loops like for while and do while to repeat actions. Proper use of control flow ensures that a program can handle various conditions effectively. Conditional statements in action. So one of the most used conditional statements is the if-else statement, which allows you to execute different blocks of code depending on whether a condition evaluates to true or false. So we have the age HTML on the desktop of the attached machine, and or we're going to create it, I guess. And so again, document HTML, language is English, the header would be the age verification, and then inside the body is where the magic is happening. And so we have age verification as the title. The ID of the message is just going to be the first part of the paragraph, and then the or inside of the paragraph, I guess, but this is literally just the ID of message inside of it, and then the script is what's going to be running. And it says age would be a prompt that's going to ask us what is our age. And then if the age is less than or equal to, or excuse me, greater than or equal to 18, then the document is going to get element by ID, which is my message right here. And it's going to say inner HTML, you are an adult. So this is going to print onto the screen by my message as my message ID. Otherwise, so if I am not greater than or equal to 18, the document is going to say I am a minor, basically. And that's the full script. And then we're going to double click it to open it and actually mess around with it a little bit. So I'll just go ahead and modify this thing. I have one right here. It's already in here. So age HTML, what is your age? My age, let's say 35, and it says you're an adult. And then if I refresh the screen, what is your age? My age is 15. It says you are a minor. So let's try that zoomed in so you can actually see what's going on. So what's your age? We'll do 85. We're an adult. What's your age? I am 10 and I'm a minor. And so if I look at the source code, right? So if we inspect it and then we look at the source code, it's going to be exactly the variable or the script that we just saw in our documentation, right? So it says, ID is the message, you are a minor. That's what's actually printed onto the screen right now that I have. And so this is the bulk of our script. So it says let age equals prompt what is your age. So let the age variable equal whatever the response is to this prompt. Now, if the age variable is greater than or equal to 18, it's going to tell me that I'm an adult. Otherwise, it's going to tell me that I'm a minor. And that's basically the script that we have right here. So very functional, and it's a nice way to see how you can really easily create interactions with a website. That's actually very, very cool and very easy to do. So we see that the prompt will ask for the age, and you're an adult if you're over 18. Otherwise, it's going to show that you're a minor. Bypassing login forms. Suppose a developer has implemented authentication functionality where only users with the username admin and passwords matching a different value are allowed to log in. To see this in action, we're going to open the login HTML file. And then when you double click on it and open it in your browser, it's going to prompt you for a username and password. If the correct credentials are entered, it will display confirming that you're logged in as shown below. So what is the message displayed if the age is less than 18? And that is going to be you are a minor. So we already had that. And what is the password for the user admin? So let's go ahead and open that whole thing up real quick. So we have the login HTML right here. So enter username. I'll do admin. Enter password. No idea, because it doesn't tell me what the successful authentication is. So I'll just do password, and that's going to be login authentication failed. Let's see if we can look at the inspection of this, if it'll actually show me what the correct username and password would be. So complex password. So we see it right here. It's hard coded inside the code or inside the page, which is a big security issue. So we are looking at the actual script for the page, and it says enter username and password. So these are the two prompts. And then if the username equals admin, so 3 equal signs is a comparative instead of an assignment. So when you do 1 equal sign, you're saying that we're going to let the password equal this. So we're assigning a value to the password variable. Over here, when we do 3 equal signs, we are comparing the value. So we want to see if that username is actually equal to admin. And so the double ampersands means that both of these conditions have to be true. And the password is equal to complex password. If that's indeed the case, we are successfully authenticated. Otherwise, it's going to say authentication failed, which is what I did because I used the word password. So the actual password itself is supposed to be complex password, and that would be the value. Look at that. Nice. It's almost like we're learning. Isn't that cool? I hope you're also having fun doing this, because this is very, very fun to do. And even if you don't have an account with TryHackMe, you could literally just open up your Google browser and just go into the console and start typing these things out, or just create a basic HTML file that has these contents inside of it, and you'll be able to go ahead and run the same exact exercise that we just ran. So this is literally the entirety of the script. There's nothing missing here. So you could actually create this and test it yourself, or you can go and create what we just saw right here and test this yourself. So this is the full script right here. And then the header part is irrelevant because it's just going to show what the login page, the tab itself is going to look like. But the big piece right here is the body. So if the body says all of this and most importantly, if the body has this script inside of it, then you will get exactly the same functionality that I just got as I went through this exercise. So very, very cool. Now let's look at exploring minified files. So far we know how JavaScript works and how we can read it. And what if the file is not human readable, which means it has been minified? Minification in JavaScript is the process of compressing JavaScript files by removing all unnecessary characters like spaces, line breaks, comments, and even shortening variable names. And this helps reduce the file size and improve the loading time of web pages, especially in production environments. Minified files can make the code more compact and harder to read for humans, but they still function exactly the same. So similarly, obfuscation is often used to make JavaScript harder to understand by adding undesired code, renaming variables and functions to meaningless names, and even inserting dummy code. So as a practical example, this would be a very basic script or a basic file right here, where we have the header. This one's fine. The document, HTML, all this part it's basic and we understand it. This is the piece right here where it's obfuscated JavaScript code and it has the source hello.js, and that's, I guess, a very basic location where we actually have the hello JavaScript file that we're referring to. Then we're going to create another file with hello.js and add the code where it says hi, which is the name of the function, welcome to THM. That's it, right? So now when we double click this, it's going to print onto the page, welcome to THM. That's going to be our alert that's going to pop up onto the screen, right? So once the file is open, you'll see the alert, and clicking OK to close the dialog box, right click anywhere and inspect to open the developer tools. In developer tools, navigate to the sources tab and click on the hello.js file to view the source code. You will see that the JS code is easily accessible and viewable as seen below. So this is what it looks like when you actually pull up a page. So we don't have one right here because there is no source code that we're pulling. The code is internal to the actual script. So if we go ahead and close these out so we can pull from our documents here, we should have one, I think, that is what is it? It's the hello.html, and the hello.html just says hello and hello and hello and hello. So 5 times it freaking said hello. If we go to inspect here, inside of our body, we will have the obfuscated JavaScript code, and then the source code is hello.js. And if we go to sources, we can see that there's a hello.js file. And then we look at the hello.js file, and we have this whole function right here that is a part of that entire script. So you can see that all of this is actually, it's a much deeper version of the JavaScript code that we were just looking at. So it's actually very, very crazy. The very last function right here is the hi function that has been called, and this is OXLED or whatever that is. We have hi. This is the actual function right here that let me see if I can kind of arrange it to view here. So we have function, hi, variable, etc., and this is all has been I guess obfuscated so that we can't see what the actual value of the function is right here, which is actually kind of crazy to think about. This is what obfuscation, I guess, looks like in a real environment, because I can't really break any of this down. It's not human readable in any way. And there's multiple functions that say hi that are, I guess this would be considered to be the dummy code, right? So you're looking at this, or maybe they've just repeated the same function over and over and over again, which is why it said hi 5 times and I kept clicking OK and it kept saying hi, right? So there's different ways that you can run it. You could technically have a for loop that will just repeat the same thing over and over and over again, or you could just have the same function being repeated 5 times, and then for each time that it repeats, it just gives you that output onto the screen. So this output that we see right here, this code that we see right here, is very, very different from this piece, this little function that we see right here. And then if we went and looked at the source code, we would see the source code, which is literally 4 lines of code right here versus however many lines this thing was right here. It's pretty fucking insane. Sorry about my French. So obfuscation in action. Now we will try to minify the obfuscate JavaScript code in an online tool. Visit the website and copy the contents of hello.js and paste them into the dialog box on the website. This tool will minify the and obfuscate the code, turning it into a string of gibberish characters shown below, which is what this looks like right here. So it'll take this very simple output or input, I guess. It'll take this simple input and turn it into this insane output right here, which seems to be exactly what is showing up right here. That this is way similar to what is showing up inside of the obfuscated version of the code that we have right here on this side right here. This very much, all of this jargon right here seems to be that, especially this piece right here, the 0x114713, that seems to be exactly what this is right here at the very top, 0x114713. So that is very much the obfuscated code that we see right here that has been turned into that by this website. So what is this website? We have the JavaScript obfuscator. Okay, very original name. So the JavaScript obfuscator just turns it into that kind of code for us, which is this. This is what we see right here, this massive amount of BS that we see right here. But that's the power of obfuscation. So that's what we should be doing so that people can't see what's going on behind the scenes, right? So if we click copy to clipboard highlighted as 2 in the above image button as shown on the website, then remove the current content of hello.js on the attached VM and paste the obfuscated content into the file. Reload the hello HTML file in Google Chrome and inspect the code again. You will notice that the code is now obfuscated but still functions exactly the same as before, which is literally what we just ran. And it was running the obfuscated version of the code, right? It wasn't running that super clean version of the code. It was running the full thing. So we can also de-obfuscate an obfuscated code using an online tool. And then I'm guessing it's going to say de-obfuscate or obfuscated to, yeah, exactly. So then paste the obfuscated code into the provided dialog box. The website will generate the equivalent human readable JavaScript code for you, making it easier to understand and analyze the original script, which is basically reversing the process that we just saw previously. So you have seen how easily we can de-obfuscate and retrieve the original code. What is the alert message shown after running the file hello.html? So this is what we had, and I think it's obfuscated. No, what is the message? Oh, welcome to THM. That's the message. So welcome to THM. And what is the value of the age variable in the following obfuscated code snippet? So I'm going to just take this whole thing and copy that, and then we're going to go here and we're going to paste it here, and then we're going to de-obfuscate this, and age is 21. So just like that, we were able to de-obfuscate code. It just sounds like a completely different language. It doesn't even sound like English. If you say it like 4 or 5 times, it just loses its meaning. All right, so now let's just talk about some best practices. So if you're evaluating a website or writing code for a website, these are some good practices to keep in mind. So avoid relying on client-side validation only. So one of the primary functions of JS is performing client-side validation. Developers sometimes use it for validating forms and rely entirely on the client side, which is not a good practice, since a user can disable or manipulate JavaScript on the client side, as you just saw we could do inside of Google console fairly easily. Performing validation on the server side is also essential. Refrain from adding untrusted libraries. As discussed in earlier task, we can include any other JavaScript in the source attribute and actually pull from an external link, right? But have you considered whether the library that we include is from a trusted source? Bad actors have uploaded a bundle of libraries on the internet with names that resemble legitimate ones. So if you blindly include a malicious library, you will expose your application to threats. Avoid hard-coded secrets. So what we just saw with that authentication page where the password was literally inside of the code. So never hard-code sensitive data like API keys, access tokens, or credentials into the code, as the user can easily check the source code and get the password. For example, const private API key being this, right? Minify and obfuscate your JavaScript code, where we just saw. Using this reduces the size, it improves load time, and makes it harder for attackers to understand the logic of the code. Therefore, always minify and obfuscate the code when using code in production. The attacker can eventually reverse engineer it, but getting the original code will take at least some effort. Is it a good practice to blindly include JavaScript in your code from any source? We're going to say nay, because it's probably not a good practice. So let's wrap this thing up, and I'll give you a couple of notes and we'll be done. All right, congratulations. Thanks for hanging in there. I feel like we did some good stuff today. I was definitely nerding out because I didn't know you could do all that stuff inside the web browser. So that was cool for me. It was a nice first experience. We have covered important topics like the basics of JavaScript, creating our first JavaScript code, and integrating JavaScript in HTML. Moving forward, we discuss other interactive elements of JavaScript like prompts and how attackers can abuse them. Then the room highlighted the usage of control flow statements and how they can be bypassed. We then explored how to use minify and obfuscate and obfuscate a JavaScript file, and learned the other way around, meaning de-obfuscating. And we touched upon some of the best practices that you can follow. So this was really cool. I really enjoyed it. I hope you actually got a lot of value out of it as well. And there's more stuff that's available if you wanted to communicate with the Discord channel for TryHackMe, or talk to them on X. You can definitely do that. And I mean, I think you should. We also have a Discord channel for this YouTube account. It's all under the guise of Hackaholics Anonymous, which I'll tell you in about 30 seconds. But first, if you have not already done so, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, especially in the CySec 101 playlist as we get further along and we're getting towards the second half of CySec 101. So I'm very, very excited that we actually are going to probably end up wrapping it up, hopefully within the next week or two. And drop a comment if you have any questions or anything that is on your mind. If you just want to say hi, or if you actually have some serious questions, I am very responsive in the comment section, and I do reply to everybody. And if it's a really good question, then I'll create a video in response to your question, or even a playlist like what you see over here. So make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And of course, drop a comment, say hi, say thanks, whatever. You can also say thanks by supporting this channel and joining Hackaholics Anonymous, the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master, and each tier gets their own Discord server and early access to content. And the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Discord and Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that's it. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next episode later. In episode 32 of the CySec 101 series, we're going to go through the fundamentals of the SQL, the structured query language, and this is all a part of the web hacking module of the CySec 101 pathway of TryHackMe, the cybersecurity 101 pathway. And we have covered web application basics, JavaScript Essentials. We are in SQL right now, and then in the next couple of videos, we're going to go through Burp Suite and, of course, OWASP top 10. And so in today's video, we're going to be going through some really interesting portions of this. Obviously, it's an introduction to SQL, so we're going to cover the very basics, the fundamentals, and then we're going to go through the concept of databases in general, what SQL actually is and how we can query databases and table statements, CRUD operations. I think it could be pronounced crude operations, but I want to say it's CRUD operations. We have clauses, operators, functions, and then of course the conclusion, and then you will be dismissed for today. If you'd like to support this channel, consider joining Hackaholics Anonymous, the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master, and each tier gets their own Discord server and early access to content. And the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automation, sessions, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the SQL Fundamentals room. We cover a lot of stuff in cybersecurity, but few things are as ubiquitous as databases. That's a very powerful word right there. Whether you're working on securing an application, working in a SOC setting, or using a SIM, configuring user authentication and access control, using malware analysis, threat detection tools, and so many other things, you will most likely be relying on databases in pretty much all of those capacities. And on the offensive side of security, it can help to better understand SQL vulnerabilities like SQL injections and create queries that help us tamper or retrieve data with a compromised service. On the defensive side, it can help us navigate through databases and find suspicious activity or relevant information, and it can help us better protect a service by implementing restrictions when needed. Because databases are ubiquitous, it's important to understand them. And this room will be the very first step in that direction. So we'll go through the basics of databases, covering key terms, concepts, and different types before getting to grips with SQL. The prerequisites would be the Linux fundamentals, and there have been so many videos on Linux, including an entire Linux Plus playlist. So there's a lot of stuff that's available on this channel. If you have not learned anything about Linux, there's Linux fundamentals videos inside of the CySec 101 playlist. I did an entire Linux SysAdmin video that is the most popular video on this channel, and then of course there's a Linux Plus playlist on this channel. So there's a lot for you. You're definitely not lacking as far as Linux content is concerned. So the objectives here are to understand what databases are, as well as key terms and concepts, understanding the different types of databases, understanding what SQL is, and being able to use SQL CRUD operations, SQL clauses operations, SQL operations in general, and be able to use SQL operators, and then of course SQL functions. So that is going to be the gist of what we're going to be talking about in this particular video. So let's jump into Databases 101. Databases are an organized collection of structured information or data that's easily accessible and can be manipulated or analyzed. The data can take many forms, like user authentication data, like usernames and passwords, which are stored and checked against when authenticating into an application or a site, like TryHackMe, for example. There's user-generated data on social media, like Instagram and Facebook, where the data is user posts, comments, or anything like that. And then they're collected and stored, as well as information such as watch history, which is stored by streaming services such as Netflix and used to generate recommendations. So there's a lot of different ways that you can use databases, and you can contain many different things inside of those databases. It's not just massive scale businesses that use them. Smaller scale businesses, when setting up, will almost certainly have a database as well to store their data. So the different kinds of databases is essentially our segue that we're going into. So knowing what they are would be great to understand that there's a lot of different implementations of them. We can build a lot of these different types of databases. And for this room, we're just basically going to focus on two types, which is the relational database, which is SQL, or non-relational databases, which is no SQL, right? So relational databases are table-based. They relate to each other. The various values of the database are relating to each other. Non-relational databases will be things like databases that have key value pairs, or are graphs, or just a wide column or a document. So a relational database is storing structured data, meaning the data is inserted into databases follows a structure. So the data collected on a user consists of the first name, last name, email address, username, and password. When a user joins, an entry is made in the database following that specific structure right here. And then we have the structured data is stored in rows and columns in a table, all of which will be covered in a few minutes. And then we have relationships that can be made between two or more tables, for example, user and order history. And then the term relational comes in. So you can have the user table that stores all of this information. And then you have the order history that also stores information about various orders and how it connects to each individual user's activity, right? Then we have non-relational databases that instead of storing data like we discussed, they store in non-tabular formats. For example, documents are being scanned, which can contain varying steps or varying types and quantities of data, and they're stored in a database that calls for a non-tabular format. And this is potentially what that could be. This looks like JSON format. So we have key value pairs. So we have the ID, and then this is the value for it, and it's separated by a comma, and then we have the next key, and the value for that is going to be here, separated by a comma, and so on and so forth. And so usually when you see these squiggly braces right here, you can, for the most part, deduce that this is a JSON type of a format. And in terms of what databases should be chosen, it always comes down to the context in which the database is actually going to be used. So relational databases are often used when the data being stored is reliably going to be received in a consistent format where accuracy is important, like when processing e-commerce transactions. Non-relational databases are better used when the data being received can vary greatly in the format, but needs to be collected and organized in the same place, like a social media platform collecting user-generated content. Inside of a relational database, we have the tables, rows, and columns, right? So we'll focus on relational stuff for the most part, because that's where SQL really shines. And by understanding what tables, rows, and columns are, you'll be able to get everything else as well. So all the data stored in a relational database is going to be inside of a table. For example, a collection of books in stock at a bookstore might be stored in a table called books. And then you have these columns. So you have the ID column, the name column, the published date, and then each row represents a separate entity: Android Security Internals, Bug Bounty Bootcamp, Car Hackers Handbook, so on and so forth, right? So when creating this table, you need to define what pieces of information are needed to define a book record. For example, the ID name and published date. These would be your columns. When these columns are being defined, you would also define what type of data this column would actually contain. If an attempt is made to insert a record into a database where the data type does not match, it is rejected. The data types that can be defined can vary depending on what databases you are using, but the core data types used by all include strings, a collection of words and characters, integers, floats, decimals, and times and dates. Once a table has been created within a column defined, the first record would be inserted into the database. For example, a book named Android Security Internals with the ID of 1 and a published date. Once inserted, this record would be represented as the first row. We have primary and foreign keys. So once a table has been defined and populated, more data may need to be stored. For example, we want to create a table named authors that stores the authors of books sold in the store. And this is a very clear example of a relationship. A book that is stored in the books table is written by an author that's stored in the authors table. If we wanted to query for a book in our story, or our store, I think, but also have the author of that book returned, our data would then need to be related somehow. We do this with keys, and there are two different types of keys. So the ID in this case would be a primary key, and the author could be a foreign key, right? So author ID here could be a foreign key, but then the ID on the authors table could also be a foreign key. So in this table, the primary key would be the ID column, and then the author key would be a foreign key. And then in the authors table, the ID would be a foreign key as well. So primary keys is used to ensure that the data collected in a certain column is unique. That is, there needs to be a way to identify each record stored in a table. A value is unique so that the record is not repeated by any record in that table. So think about matriculation numbers in a university. These are numbers assigned to a student so they can be uniquely identified in records, because unique students sometimes have the same name. So a column has to be chosen in each table as a primary key. In our example, ID would make the most sense, as an ID can be uniquely created for each book, whereas books have the same publication date, or in rare cases they have the same title. Note that there can only be one primary key column in a table. Foreign key is a column or columns in a table that also exists in another table within the database, and therefore provides a link between the two tables. In our example, thinking about the author ID field to our book table, this would be then act as a foreign key, because the author ID in the book table corresponds to the ID column in the author table. So foreign keys are what allow the relationship between different tables in relational databases, and there can be more than one foreign key column in a table. So what type of database should you consider using if the data you're going to be storing will vary greatly in its format? And if it's going to vary, that would be a non-relational database. Hopefully I spelled that right. And then there's probably a hyphen that needs to go here. What type of database should you consider using if the data you're going to be storing is reliably the same? And that would be the relational database. And in our example, once a record of a book is inserted into the books table, it would be represented as a in that table. It would be represented as a row in that table. Which type of key provides a link from one table to another? And that would be our foreign key. That's definitely not how you spell foreign. Foreign, right? Like that. Very good. And which type of key ensures a record is unique within a table? And that would be the primary key. So very good. We got the basics of databases. Now let's talk about SQL. So understanding what a database is great, but we need to understand how the rubber meets the road, so to speak. So how would you make your first table and populate it with data? What would you use? Databases are usually controlled using a database management system, serving as an interface between the end user and the database. The DBMS is a software program that allows users to retrieve, update, and manage the data that's being stored. Some examples include MySQL, MongoDB, Oracle Database, and MariaDB, and they all, for the most part, operate with SQL. So SQL, the benefits of it, and the concept of the relational database. So SQL stands for the Structured Query Language, and it's a programming language that can be used to query, define, and manipulate the data that's stored inside of a relational database. It's almost as ubiquitous as databases themselves, and for good reason. And these are just some key benefits. So it's fast. Relational databases, aka those that require SQL, can return massive batches of data almost instantaneously due to how little storage space is used in high processing speeds. They're easy to learn. So unlike SQL, it's written in plain English. So unlike other languages, unlike other programming languages, SQL is written in plain English, which makes it very easy to pick up. The syntax is very easy, basically. It's reliable, so they can guarantee a level of accuracy when it comes to data by defining a strict structure into which the data sets must fall in order to be inserted. And then it's flexible because it provides all kind of capabilities when it comes to querying a database, which allows you to perform vast data analysis very efficiently and quickly. So now that we have this, it's time to actually kind of start working with it. And I've already started our virtual machine here. So it's going to be in our split screen, and then we're just going to start essentially running these various commands that we have over here. So I'm going to open up my terminal here, and the first command is mysql u root p. So once prompted for the password, enter TryHackMe as the password. And that's pretty much what is going to start, and then it's actually going to start the MySQL command line so that we can actually start working around and messing with it. So we're going to do MySQL. The U for the user is going to be root, and the password, we're going to press enter, and it's going to say enter the password, and it's going to be TryHackMe, all lowercase. And now I have the MySQL command line, which means it worked. So the question here is, what serves as an interface between a database and an end user? And that is the DBMS, I want to say, the Database Management System. What query language can be used to interact with a relational database? And of course, that is SQL. So let's actually start running some commands here. All right, so for the most part, for all of these statements and everything that we're going to be running, instead of just reading through them and then running through them, I'm going to just start running through them, and then we're just going to look at our command line and use that as an example of what we're going to be running with, right? So we'll go through the create database stuff, and then we're going to show the databases, and then use databases and drop databases, so on and so forth. So this is going to be nice and easy to run. So I will open this up in a new window. It's going to be in full screen mode. And then from here, we're just going to zoom in on our terminal, and then we're just going to run everything in our primary window, which is going to be this window. I'm just going to drag this out to to my second monitor so I can go ahead and kind of run these things or read them as I as I run them, so that you can just basically see what I am currently running. So it should be fairly fun and easy to operate this thing. So the very first thing that we want to do is we want to create a database, right? So that's the very first thing. If you don't have one, obviously you need to create one. So MySQL ends up being the specific I guess software that we're gonna end up using, the database manager, DBMS. This is the database manager that we're gonna end up using to create our database. So the very first command is to create a database, and I think you can run it without actually doing these things in caps lock, but for the most part, I'll just do it in this particular case. So we'll do test db, and then we're gonna do a semicolon, and then we're gonna press enter, and it says one row affected. And so let's see, we'll do create another one. So I'll do it in lowercase. Let me see if it actually works if I do it in lowercase. So test database, and then we'll do that. And okay, so it also worked in lowercase. I think it'll work whether it's in lowercase or uppercase, but in the in SQL, the syntax usually is that whatever the command is, they do it in uppercase to be able to differentiate from the value. So for example, in this case, the database name would be the value, and then these are the commands, right? So you're creating a database called test_db, and that when you look at this as a full command, you're like, okay, the ones that are in caps lock are the actual commands, and then the lowercase stuff are the values that we're playing around with. So so now we have these things, right? So if we have that, then I can do show databases, and then semicolon, press enter, and it'll show me the various databases that I have. And then I have test DB right here, and I have test database right here. These are the two that I made. There's THM books, books2, tools DB. There's the sys, task 4, performance schema, MySQL information schema. And of course, there's a flag already here that will probably be one of the answers to the questions that we need to run. So, all right, so now that we have this, what we need to do is we need to kind of use a database. So let me see if clear works here. Clear does not work. Clear lowercase doesn't work either. So when you are in the MySQL command line, the basic syntax of Linux does not seem to work. So what we're going to do is we're going to use our first database, which is the THM book market _db. I don't have this here. I wonder if this is one of the ones that they made. Yeah, that's actually the second one that they made inside the example. So since I don't have that, I'm just going to use the one that I made, which is going to be the test database. So I'll use test database, and that's going to be the database that we're going to use. So the database has now been changed to our test database. So what we can do is we can also drop a database. So once you no longer need it, or maybe it was created for test purposes and it's no longer required, we can actually remove it by doing the drop statement. And to remove it, we would just use drop database and then give it the database name, and then you'd be able to drop that database. So as an example, I could do drop and then do database. And maybe I need to kind of like bring this lower a little bit so you can actually see what's going on. So we'll do drop database, and we'll do test_db and press enter. And I got to do that semicolon is very important. And then we press enter, and now it says, okay, those are done. So the show databases, let's see. And now we have that the test DB database is no longer here, right? So that's been removed. So we can now create a table inside of the database. So the one that we're working with right now is our test database. That's the one that we switched ourselves into. So we can actually start creating various elements of that. So the first one would be to create a table, and then it would be test. I'll do test table, and then I can do an open parentheses, and then I can do enter, and now I have a new line. So it could be example column 1, and then data type, comma, enter, example column 2, and then data type, and then example column 3, and then data type, like that, and then no comma required for the last one. We'll close out the parentheses, do a semicolon, press enter, and now it says you have an error in the syntax. Check the manual that corresponds with this. Da 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 da. Example column 1 data type. Oh, you know what? I'm literally just typing what they put over here, and I think I'm supposed to be doing like example column 1. The data type should be something other than the actual phrase data type. Yeah, so I think obviously I did this incorrectly. I was literally just reading through it and I just started typing it out. This was just kind of a template of what we're supposed to be doing. And I feel like I've already created an example column data type because 2 and 3 didn't work. So I'm just going to start fresh, and we're going to drop the database, and then we're going to drop the test database that we have here. And that's now going to be done. So if I do show databases, just to confirm here, we have dropped it. So we're going to create a database, and then we're going to call it, we'll do THM books as they did. And oh, it already literally has one called THM books. So we'll do another one, and then we'll just call it THM books 3. So that'll be the one that I created. So THM books 3 is good, and then we're going to do use database, and then THM books 3, and there you go, unknown database. So we're going to do use THM books 3. I think that's the command. There we go. So database has changed, and now we are inside of THM books 3. So now we can actually create a table, and we will call it the books inventory, or book inventory. And then with this one, we can actually start adding some key value pairs here. So okay, that was a little bit challenging for whatever reason. I couldn't get caps lock going. So hopefully this actually works. If I press enter, this is supposed to create a table called book inventory, and it has 3 columns: the book ID, the book name, and the publication date. And book ID is going to be an integer. So these are the various things that we need to add to it. So it's going to be an integer, and it should only ever be a number, which is going to automatically increment for us, meaning the first book inserted would be assigned a book ID of 1, and the second book would be book ID 2, and so on and so forth. And then book ID itself is set as the primary key. Okay, so that's what all of this is right here, and these are the various values that would go with that. And then we have book name, and of course book name is the data type varchar 255, meaning that it can have variable characters. So varchar, or varchar, I guess, it would be variable characters, which means text, number, punctuation, and a limit of 255 characters is set. And not null right here means that it cannot be empty. So if someone tries to insert a record into this, but the book name was empty, it would be rejected. And then the publication type is just set as the date. So these are the various elements of this. And now we can press enter, and everything is all good. We didn't get any error messages, so we are good in this regard. Now inside of this particular table that we're in, we can actually do show tables, and it should show us the table. So tables in THM books 3, and then there's the book inventory, right? So that is our table that is available. So we can now show the contents of that table, and we would use something which is called the describe command. So if I do describe, and then we would do describe book inventory, press enter, and we see that we have these various fields, right? So we have the book ID, which is an integer. It's not null, meaning it can't be empty. It's the primary key. The default right now is null, and it automatically increments. And then we have the book name, which is a variable characters. It's also not null. It's not the primary key, and the default is null, but it can't be empty. That's what this piece right here says, the null part right here. And the publication date, it can be empty, I guess, because we didn't really specify that. And that's basically it. So these are the descriptions of the various columns inside of our book inventory table. Okay, so we can now alter the book inventory table. So once you've created it, there may come a time where you need to, when you need for the data sets to actually change, and you can alter it using the alter statement. And we can do something like, add a page count column to it, right? So the alter statement can be used to make changes such as renaming columns, changing the data type in a column, or removing a column. So now I can do this. I can do alter and do the table itself, which is going to be the book inventory table. And then now we're going to add page count, and then it's going to be an integer, and then we're going to close that. So that should be all good. And now we can try the describe one more time. So describe book inventory, and there should be a page count. There we go. So now we have a page count as well, and that is also another integer because page counts are only integers, right? So that was really it. So we created a table, we created we did. We created a table inside of that, or we created a database, my bad. We created a database, then we created a table inside of the database. Inside of that table, we added these various fields or these columns. And for each column, we were able to add specific elements to it. For example, making sure that it's only an integer and it's the primary table or the primary key, it automatically increments. And then this one has variable characters, maximum 255 characters, so on and so forth. So, and then we were also able to alter the book inventory table by adding a page count, which is another integer. And from there, now we have this full description right here that has 4 columns, and that's our first official table. So now what we can do is we can just go ahead and drop the table, which is going to be book inventory, and now we've gotten rid of our book inventory. So we'll do show databases, and then we have no longer a the table was inside of the THM books, so that's what that was. So the database is fine, but the table that we just dropped was the book inventory table. So if I actually go and do show tables inside of book inventory, I no longer have that table because I just deleted the table, and it's done again with the same command. So you could do drop database and then drop the database name, or you could do drop table and then drop the table name. Now, using the statement that we've learned to list all the databases, there should be a flag, which is this. So there's going to be our first question right here. So we're going to copy this, and we're going to go right here, and we're going to paste that as our first answer. And it says, in the list of table of available databases, you should also see a task for database. Set this as the active database and list all of the tables in it. What is the flag that is present here? So we're going to go back here, and we're going to set, or we're going to use task for. So use task for DB, and that's been changed. Okay, very good. Then we can also do show tables, right? So there we go. And that is the flag for task for database. And copy that. And we're going to go here and we're going to paste that. And that would be that flag. Very cool. So let's talk about CRUD operations. So CRUD stands for create, read, update, and delete, which are considered the basic operations in any system that manages data. And we can explore all these things when working with MySQL. So in the next couple of tasks, we're going to be using the books table that is part of the database THM books. And we can access it with the statement THM or use THM books. So that's going to be the table that is going to be the primary table that we will be using for the following few exercises. So if we do show databases one more time, we see that we have THM books. So we're going to use THM underscore books, and that will be our new database that we are going to be using for the CRUD operations that we got. Okay, so the first part that we want to go through is to to go through the create operation, which is insert, right? So the create part of CRUD, that's C, is done with the insert command, and it'll create new records in a table. In MySQL, it can be done using the insert into. So we can do insert into books, for example, and that will allow us to hopefully insert all of this stuff inside of our books. So if we actually go to the THM books that we have, if I do first, let's do describe, right? THM books, and let's see what describe the table. The THM book does not exist. Oh, excuse me. So describe, or what is it? How do we do it? I think it was show tables. Man, I already forgot. Hold on one second. Yeah, it was show tables. My bad. Okay, so here we go. Show tables, and we'll do that. And so we have books inside of the THM books database. There we go. So inside of that, we can do describe books, and then that'll give us these things right here. So we have an ID column, we have the name, publish date, and the description. And these are the various columns that we have inside of our books table. Okay, very good. So now we can insert into the books table the ID, name, publish date, and description, which is already been done for us. So I don't need to go ahead and change. Actually, no, I think this is how we add data to it. So if we do this, right? So if we do insert into books, and then we do ID, name, published date, and then description. So these are the fields that, or the columns that we want to be filling in piece by piece, right? So that would be the columns. And then now we want to add these values into those columns. So that's how this is going to work. And then the first value is going to be 1, so it's going to be ID 1. The next one is going to be Android Security Internals, and so that'll be the title of the book, the name of the book. And then the publish date is going to be 2014 10/14, and then an in-depth guide to Android's security architecture, I guess, is the description of this thing. And then I think that's pretty much it, right? Yeah, so we can just close out the parentheses now, and then close it out by doing a semicolon, and now we press enter, and it says arrow published data in field list, and it's not supposed to be published data, it's supposed to be published date. And by just missing that one little letter, I cannot insert, so I have to redo this whole thing. So forgive me and give me one quick second as I retype this whole thing out. There we go. And what's going on? So duplicate entry 1 for keybooks primary. So I guess the previous one, I guess, did work. What the heck, bro? What do you mean? Now oh my gosh. Okay, so I guess the previous one did work. So, all right, let's see if it actually did work here. So let's see, we need to read the contents, right? So the first, it's going to be selecting. Select is the keyword that you're going to use to be able to select an entry. And when you do select asterisk, it's going to pick everything. It's going to select everything from, and then from the books table. And we press enter. And I have Android Security Internals as Title 1, Bug Bounty Bootcamp, Car Hacker's Handbook, Designing Secure Software, Ethical Hacking, and Ethical Hacking. There are 2 elements of that. So we can technically get all of them, right? So you can select a given name, or you can select a given column. Instead of selecting everything from books, you can select a specific column from the book. And this can also be lowercase as well. So the uppercase thing is just for human friendliness, I think. So if I do select, and then from here we can do name and description instead of selecting everything. And then we will select it from books table, press enter, and it only now shows us the name and the description instead of showing us the ID as well, and the published date, and so on and so forth. So you can select everything by doing select the asterisk and then do from books, right? And it'll show you all of them. So it shows you the ID, the name, published date, or you can just do a selective portion of it where you say, I just want to see the name and the description from books, right? So that could be a way that you can display the content. And then we can update information that's available. So now we are in the U part of CRUD. So we've done C for create using insert, and then we've done R with read by using the select command. And then now we're onto the U for updating. And this one actually is using the keyword update. So in this particular case, where we can say, let's change the description of ID number 1, for example, right? So we want to change the description of ID number 1, which is the Android security internals right there. So we can go and say update books, right? And then you want to set the description, and that's going to equal to a guide to Android security, right? We'll just keep it short. We'll make it short. And then we're going to make that update and then we're going to set that description where the ID equals 1, meaning for ID number 1, I want you to set the description to this and update it. And now that'll be updated. So now again, we'll do select everything from books and then type that out. And then now we can see that a guide to Android security is the description for this first book right here. So the very first one where we wanted to create the Android security internals for ID number 1 and all that stuff, the reason why we got that error message that it already exists was not because the first time that I ran it, it actually went through. It was because these things are already pre-populated. So if I wanted to create another one, I could technically do an ID number 7 and then fill it in with a variety of different data. So we could actually go ahead and do that. So let's just create another quick entry into our books. So we'll do insert into books, and then we'll go ID, name, published date, right? And then description. And there we go. That'll be our new insert, and that's been all good. So now we can do select, select everything from books, and it'll display that we also have a ID number 7 random book, and this is the random book for demonstration purposes. And now we got that as well. So we were able to actually create an entry, and we were able to read by using the select command, and we can even update it again, right? So we can go ahead and let's say update this specific book's description. We'll update the book's description. So we'll do update books and then set description, and it'll be not so random, whatever. And then where do we want to make this update? We want to update it on ID number 7. There we go. And then we are now going to press enter, and that's been updated. So select everything from books, and we can see that it's not so random. So we learned how to create by using insert into, we learned how to read by doing select, and then we learned how to update by using update. And now finally, we are at the D for delete. And of course, that is also a very simple command where we actually use the term delete from books where ID equals 7, because that's the one that I just created, and I'm going to press enter. And so now our last entry that we just created should be gone, and we no longer have an entry number 7. We have entry number 6. So we need to also delete that, because that is it's like a duplicate, it seems, where ID equals 6, and delete that. So there we go. Now we see that we only have one ethical hacking book that actually has the description, whereas the other one was just, it seemed like it was a duplicate entry. So create is done using the insert statement. Reading is done by doing the select statement. So select everything from books, for example. And then updating is done using the update statement, and deleting is done using the delete statement. So now we have a couple of questions where it says using the tools database. So the tools DB database. So if we do show databases one more time, we have tools DB. So we're going to use tools DB. And let me see. So we've already, okay, very good. So now we're inside of tools DB. What is the name of the tool in hacking tools table that can be used to perform man-in-the-middle attacks on wireless networks? So we are using the tools database. I do want to see the tables. So show tables, and it's hacking tools. So I want to select everything from hacking tools. And I have all of these entries inside of hacking tools. And we want the one that can be done, it can be used to perform man-in-the-middle attacks on wireless networks. So portable Wi-Fi for pen testing, malicious, multifunction for reading, writing, man-in-the-middle attacks. Let's see. There we go. So here it is. So number 3, a device used to perform man-in-the-middle attacks on wireless networks, and it's called the Wi-Fi Pineapple. Ooh, that's actually very interesting. I wonder if these are real things. I feel like they are. USB Rubber Ducky, Land Turtle, Bash Bunny. I feel like these actually are real tools that we have. So that's actually kind of cool. So Wi-Fi Pineapple is the answer for this one. So let's go over here and answer this question. So why, right? This is that's the right question. So Wi-Fi Pineapple is the one. Oh, I'm missing a dash in the middle. And then using that database, what is the shared category for both USB Rubber Ducky and Bash Bunny? So what is the shared category for Rubber Ducky, which is USB attacks, and Bash Bunny, which is also USB attacks? So we are going to say USB attacks are these shared categories. Okay, cool. Now let's talk about clauses. A clause is a part of a statement that specifies the criteria of the data that's being manipulated, usually by an initial statement. Clauses can help us define the type of data and how it should be retrieved or sorted. In the previous task, we already used some clauses like from, that is used to specify the table that we're accessing with our statement, and where, which specifies which records should be used. So we're going to focus on other clauses like distinct, group by, order by, and having. So the distinct clause is used to avoid duplicate records and so on and so forth. So now we're going to actually go back into our command line here, and we're going to use the clauses for various commands. So let's zoom in a little bit more here. And all right, so here we go. So the clause, the very first clause, I love saying clause. It reminds me of like the New York accent if you say it with that, like that Brooklyn clause. So the first clause is the distinct clause, and it's used to avoid duplicate records when doing a query. Now, unfortunately, so what I did was I got ahead of myself, and for the THM books, I deleted that duplicate entry, and that duplicate entry was for the purpose of, so let me see, it was actually select everything from books. That's what we had. So that duplicate entry that we had at the bottom, which was the ethical hacking book, that was actually meant for the purpose of this exercise where we're supposed to pull the distinct records, meaning if you have duplicate entries, you only want to see the unique entries. So what I'm going to do real quick is I'm going to insert into books the new book, or that same book that we had previously, which was the ethical hacking book that we had. So let's do that real quick. Okay, so there we go. Now we can do show everything from books again, and we show select everything from books, And there we go. So now we have ethical hacking. So we can see this is what it looks like if we just use a distinct command, or if we don't use the distinct command, excuse me. If we just say show me everything, then it'll show us everything. So if we use the distinct clause now, then the way that it looks, instead of saying select everything from books, we're going to say select distinct from books, or distinct, let's say, name. So we're going to do distinct name from books, and then press enter here, and we'll see that it only shows us the names that are actually unique. So it doesn't show 2 entries for ethical hacking. That's the whole purpose of using the distinct command. So if we went to group by, so this is clausing that aggregates data from multiple records and groups the query results in columns. So it can be helpful for aggregating functions, for example. I don't think we have a count that is available over here, but what we can do is we can actually aggregate, meaning we can count them. So this is what it would look like in that regard. So we would say select the name and then count it, right? Count every, and then just fill in the count for me. And then from books, and then I want you to group by the name and press enter. So now we can see that since we had 2 ethical hacking books, we actually have 2 ethical hacking as far as the count is concerned, and then the names are still there, and we have individual counts for each one of the books as well. But for the one entry that has 2 ethical hacking books technically, so the records of the books table are regrouped by the result of the count function, and we already know that ethical hacking was listed twice because we literally saw it. So the count for that would be 2, and then it's based at the end of this by the count, grouped by count portion, right? So we have now counted them, and count would, I think, is like an internal function that is inside of MySQL that actually does count for you based on whatever the title is, or whatever the specific identifier is that you've chosen. If we want to order them, so let's say we grouped by right now, we pulled first distinct using distinct, and then we grouped them by their title, by their name. So now we want to order them, right? So if we do select everything, and then from books, and then order by published date, for example, and ASC is the command that they've given us. So it says, and I keep saying published data, my goodness. So select everything from books, order by published date. Oh my goodness. Okay, very good. So there you go. And it has been ordered by published date, right? So you can see that over here. The order of these things has actually changed, so ethical hacking is no longer at the bottom, and then you can also just see by their ID number that they have actually been reorganized based on the published date. The ASC part, oh, I see, the ASC is for ascending, and then you can also order them by descending. So we can do the same thing basically. Select everything from books, and then order by published. Let me make sure I spell published date correctly. And if we do DESC, it would be descending. And then it will reverse the order, obviously, and give it to us by the most recent published, and then the oldest published at the bottom. So you can group them, you can order them by ascending order or descending order, and you would do it by either their name or their published date. Probably, I think published date, like, it actually makes more sense in this particular example. Doing it by ID could be another thing. So if we could actually do select everything, because it will literally show everything in ascending order by ID. So if you wanted to do select everything from books and then order by ID, and then do DESC for descending, and then do that, it would do the IDs in reverse order, right? So it would be 6, 5, 4, 3, 2, 1, right? So you can actually organize them by their IDs in descending order as well. And very good. Okay, so that's that. So we can now move on to the next clause, which is the having clause, and it's used with other clauses to filter groups or results of records based on a condition. So in the case of grouping them by something, it evaluates the condition to true or false, unlike where clause unlike the where clause, where having filters the results after the aggregation is performed. So if trying to kind of just explain it a little, it's easier to just demonstrate it. So if we do select a name, right, and then count them, and in this particular case, we would do the same thing where we would do the count in that regard, and then we're selecting the name from books, okay, and then we are grouping them by their name, and then what we want is to show something that having name like, and then this is where the piece comes in where, okay, I want you to show me anything that has a name that kind of resembles this, right? So as long as it has the word hack in it somewhere, I want you to bring me the result. So then it's going to bring us the Car Hacker's Handbook, and it's going to give us a count, and then it's going to bring us the Ethical Hacking Handbooks, and then it's going to give us a count. So it's very similar to what we did previously where it was giving us the count of everything, but now in this case we're saying having a name like hack, so having a name that has this word in it basically. So if you're looking for anything inside of your records that you don't know exactly what the name is, but you know that the word is in there somewhere, there's like at least one word that's in there somewhere, then you can go ahead and order them. You can group them by their name and then display them as long as you know what word is in there somewhere. So having clause helps you do that. So that's basically it for all of the clauses that we had. So we had the having clause, we had the order by clause, we had the group by clause, and then we had the distinct clause that would show us the unique entries. So now what we can do is we can go back to the tools database so that we can actually answer the rest of these questions that we have here. So the first question is asking us, using the tools database, what is the total number of distinct categories in the hacking tools table? So we want the distinct categories in hacking tools. So what we're going to do is use the distinct clause, right? So we are going to say select distinct category from what was it? I think it was called Hacking Tools was the name of it. Yeah, Hacking Tools is the name of the table. So select distinct category from Hacking Tools, and then it says what is the total number of distinct categories. So we have 1, 2, 3, 4, 5, and 6. We have a total of 6. Oh, it also says 6 right here, so I didn't even need to count. So 6, there we go. That would be the answer for that. Sorry, I'm actually inputting it on this on my secondary window, but that's the answer right here for the first question. The answer was 6. So let's go down here just to show it to you so you know I'm not messing with you. So there we go. The answer for this was 6. Now it says using the tools database, what is the first tool by name in ascending order from the hacking tools table? Now we could obviously just do that. We can just look at it and kind of break them down accordingly, or it's probably best for us to actually run the exercise, right? So order them by ascending order so that we can see what the name is for that. So they want to see the first tool by name in ascending order from hacking tools. So what we're going to do is we're going to order them, right? So we're going to select everything, and then we're going to from books, or not books, sorry, from hacking tools, because I'm essentially just looking at the command that they used previously. So we're going to select everything from hacking tools, and we're going to order by name, and it's going to be in ascending order, and that's basically it. And it's going to be Bash Bunny is going to be the first tool that's going to be on our list. So Bash Bunny, there we go. And now using the tools database, what is the first tool by name in descending order from the hacking tools table? So it's a very similar command to the previous one, except we're just changing it now to descending instead of ascending. So from, I keep saying from books, from hacking tools, and then order by name, and then it's going to be in descending order, and that's it. So it's Wi-Fi Pineapple is the name of that tool, and we got to make sure that we put that dash in there, and there we go. So Wi-Fi Pineapple was that answer. Very good. So let's talk about operators now. So we already have used one of the operators, that was the like operator, where we were like, where the name is like hack. That was an operator that we used. So when working with SQL and dealing with logic and comparisons, operators are our way to filter and manipulate data effectively. Understanding these operators will help us to create more precise and powerful queries. And this is what we're going to be using the books table, and it's a part of the THM books 2, and we can access it with the statement use THM books 2. So the logical operators would be they test the truth of a condition and return a Boolean value of true or false. So let's explore some of these things. So the like operator is commonly used in conjunction with a clause like where in order to filter for specific patterns within a column. So we are now going to essentially just start running some of these commands here. So first we need to go to, it was THM books 2. So that's what we're gonna switch to as our database, so we can get some of these precise answers here. So it's gonna be THM books 2. And then from here, we want to show tables. So we have the books table inside of THM books 2. Okay, very good. So now here we go. So we have select everything from books where description, okay, description, there we go, is like, and then here we're going to do guide, and let's see what comes up for that. So we have 4 entries that actually showed up. So it says an in-depth guide to Android security architecture, the guide to finding and reporting web vulnerabilities, a guide for penetration testers, and a guide for developers, right? So we had 4 entries that showed up where there, at least the word guide was inside of the description, okay? And that's how we do the where description is like something, right? So this is the like operator. And then we have the and operator. So this is where you want to kind of fine tune and hone in, right? So you want to find a very specific response. So in this case, we could do select everything again from books, right? Where the category, so let's say the category equals offensive security, because we actually have multiple in offensive security. And so I'll do that in caps lock so we can actually notice the difference. The name equals bug bounty bootcamp. Okay. And that's it, right? So now you have 2 specific identifiers, right? You have 2 parameters for your search, where you have the category needs to be in offensive security and the name needs to be bug bounty bootcamp. And that's the only thing that you want to see. So obviously there should only be one thing that shows up, because there was only one entry that is also named bug bounty and it's an offensive security. So I feel like the name would just by itself would probably narrow that down a lot. But it is indeed bug bounty bootcamp, which is ID number 2 and so on and so forth. So that worked exactly how we wanted it to. Now, we can use the other operator that also falls in that same line, which is the OR operator. So in this particular case, we used AND because we wanted to double down on our selectors, on our parameters. But now we can say OR, and when you do OR, it gives you either or, right? So we're selecting everything from books again, where the name is like, and then we'll do Android, right? Or the name is like, of course, the friendly of Android, the competition of Android would be iOS. So I want to see everything that either has Android in the name or it has iOS in the name, right? So show me either or. You press enter and it only gives you one entry because there's nothing inside of our list of books that had anything to do with iOS, right? But if we want to see anything that has to do with mobile devices. Essentially, that's what this search parameter kind of shows us, is that search query is saying, I want to see any book that you have that has anything to do with mobile devices. And so it could be either Android or iOS. And in this particular case, we only had one book that was just about Android in our catalog of books. So now you can also narrow down the opposite direction, where you say, I want to see anything that is not this, right? So the not operator reverses the value of the Boolean operator, which basically makes you exclude something, right? So we can start the same way. And of course, it's coming from books. And then we were saying where not description. So meaning show me anything that the description is not like. And of course, we're going to say guide in this case, right? So show me anything that the word guide is not in the description is what I want to see. And so we can see a hands-on introduction to breaking in offensive security. And that's the only book out of the lineup of the books that we had that does not have the word guide inside of the description, right? So you can do this with essentially anything else, right? So it's like, show me everything where the name is not, or where not name. So right, where not name is like hacking or something, and then we'll see anything that has. So let's actually try it. So we'll do select everything from books where not name like, and then we'll do the word hack in it, and then we'll close that out. And so it'll show us 3 books, because the rest of the books apparently have some kind of reference to the word hack inside of them, right? So it basically shows you everything that does not have that word in it. So our next operator is going to be the between operator. And the between operator allows us to test if a value is within a certain range, right? So to make it easy, you could technically do with dates as well, but it would be a little bit more complicated to try to write it for the dates. So we're going to do it with the ID. So we're going to select everything from books where the ID is between 2 and 4, and then just press enter, and now it's going to show you 2, 3, and 4. Very, very simple. But you can also do it with date ranges as well. You could do it with page counts, assuming that we actually had a page count column that showed us how many pages these books were, and then we can say, yeah, I want to see all of the books that have between 100 and 150 pages, right? So that would be another way that you can narrow it down using the between operator. So those were all of our logical operators. Now there's something also considered the comparison operator. So where you say, I want you to show me something where this equals to this, right? Or where this does not equal to this, or where this is less than this, or where it's greater than this, less than or equal to, greater than or equal to, right? So on and so forth. So we are going to start with the very basic one, the very first one, which is going to be the equal to operator. So select everything from books where name equals to designing secure software. Okay, there we go. Press enter, and it gives you that one entry where the name is equal to designing secure software. So you could do select everything from books where name is equal to Car Hackers Handbook, right? Boom. And then you see Car Hackers Handbook. So very, very simple, very basic. And we could do the same thing, right? Select everything from books. So meaning select all of the columns from books. That's what that means, not all of the entries. So select all of the columns from books where the ID is equal to 5. Oh, whoops. There we go. And I forgot to close that out. So I wonder if this is actually going to work. Okay, yeah, that was an error for sure. That was a bad query. From books where the ID is equal to, we'll do 5 like that. Or let's do a space just to give it a good round off right there. And there we go. Now we have the 5th book. So you get it. You get the idea here. So that was equal to. So just like we have equal to, we can also do not equal to. So we can do select everything from books where the category And the way that we do not is by doing an exclamation. And this is pretty consistent across most languages as well. If you do exclamation equal sign, that means it's not equal to whatever it is that we want. So I want you to show me something that is not in the offensive security category. And then now it only shows me 2 items that are inside of defensive security, right? So show me all the books where the category is not offensive security. So that is the not equal to comparative operator that we have, which is the exclamation and then the equal sign, and that would be not equal to. We have another one, which is select everything from books, where the published date, so this is where we can go into less than. So the published date is before 2001, so 2020. So show me anything that is before 2020. So you press enter on that and it'll show you 2014 and 2016, right? So you can do the same thing with greater than. So we can say, now I want you to select everything from the books and then show me where the published date, let me make sure I do that right. So published date is greater than the 2020, right? So I want you to show me that came after January 1st of 2020. And of course, it shows us all of the books that came after January 1st, 2020. We can also do less than or equal to, right? So if you actually have a specific value that you know is either, again, we could be the page count, we can do the published date, because that seems to be the only thing that we could really measure like that. So we can do select everything from books, where the published date is less than or equal to, and then we can do 2021 11/15, and that will show us anything that's equal to 20 or less than or equal to 2021 11/15. So November 15th of 2021, as long as it showed up on or before that date, right? So if it shows up on or before that date, I want you to give me those results. And of course, we have the 11/02, which is before 11/15, right? So 11/02 2021. So it's technically before 2021 11/15, and then of course 2016 and 2014 are also before 2021. And then we can just reverse it the other way, where we just do greater than or equal to. So select everything from books, where published date is greater than or equal to, and then it would be 2021 11/02, and then close that off, and now it will show us everything that is on or after 11/02, right? So 11/02 right here, this is actually on that date, and then these are all after 2021 11/02, right? So you have equal to, not equal to, greater than, less than, and then greater than or equal to, or less than or equal to, which all are our comparative operators, okay? So now we can actually start doing some hunting for the tools database one more time. So here we go. And so inside of tools database, we had the table was hacking tools. Okay, very good. So now it says inside of the tools database, which tool falls under the multi-tool category and is used for pen testers and geeks. So for the multi-tool category and is used for pen testers and geeks. So let's see. let's see what I can see here. So first, I just want to see what the various columns are. So selecting everything, we have ID, name, category, and description. I see. So okay, so for pen testers and geeks, we can search by the name, we can look for category, and we can look for description. So most likely we're going through the category as well as the description, it seems like, because there is nothing here that says, because for the, let me see, the way that the question is outlined, oh, it's the multi-tool category, so my bad. So it's under the multi-tool category, and it's for pen testers and geeks. But I mean, what's interesting is that there's literally one thing that's inside of the multi-tool category. So I know for a fact that Flipper 0 is the answer. I just know that. But what we want to do is we want to actually write a query that will bring that up for us. So we're going to use the where, we're going to use and we're going to try to craft something that's pretty solid here. So it's going to be select everything from hacking tools, where category equals to multi-tool, and description equals, or description is like, I think that's what we could do probably. And we can go in here and do pen testers and geeks, and then close that off. And let's see if that works. That worked. Excellent. Okay, so because we know that pen testers and geeks should be in the description, but we don't know where the full thing would be. So we want a description that is like that. So we want this to be inside of the description at some point. And we also want the category to actually be multi-tool. And of course, that was Flipper 0. I'm very, very happy that that worked. Super excited about it. So let's come down here. And then we're going to do Flipper 0. And now the question here is, using the tools database, what is the category of tools with an amount greater than or equal to 300? So what's the category of tools with an amount greater than or equal to 300? Okay, let's see. Got it. Okay, so we actually have an amount column here as well. This is kind of like crashed in together, so we can't really see it, but these numbers right here, that's the number of the tools, the quantity, I would say. So these are the tools that we have. And so inside of the amount section, or the amount column, what we're looking for is the category of the tool that is greater than or equal to 300. So greater than or equal to is that. So first we're going to do select everything from hacking tools, and it's going to be where amount is greater than, there we go, greater than or equal to, and we were going to say 300 and press enter. And so we have iCopy XS, and then we have Proxmark 3 RVD4. So using this, what is the category of tools with an amount greater than or equal to? And that is RFID cloning. That is our category, RFID cloning, not clothing, cloning. Very good. And so using the tools database, which tool falls under the network intelligence category with an amount less than 100? So we are going to combine a few things. The first one, as always, is going to be select everything from hacking tools. And now we want where amount is less than 100, right? That's what it was. So where the amount is less than, let's do less than, there we go, 100. And I'm going to put the 100 in quotes just in case. And what was the other thing? The category equals to network intelligence. And, or I think the I in intelligence is supposed to be, I don't know if it's case sensitive like that. Well, let's see. Okay, so we have it. So land turtle is in the network intelligence category, and it has less than 100 in there, and that would be our answer. Very good. So land turtle. Excellent. Cool. We got all the answers, and we can now move on to functions. When working with data, functions can help us streamline queries and operations and manipulate data so we can see what these things can actually do. This is a little bit different from everything that we've gone through so far. So we have the concatenate function, which is used to add 2 or more strings together. We have the group concatenate function that helps us concatenate data from multiple rows into one field. And then we have the substring function that will retrieve a substring from within a query. We have the length function that will retrieve the number of characters in a string. And then we have aggregate functions, which is the count that we already did once, or we actually did it a few times, that returns the number of records within an expression. We have the sum function, the sum of all values not null of a determined column. So there's no need to execute this. This is just for example purposes as they tell us. And then we have the max function that calculates the maximum value within a provided column, and the minimum function, which does the opposite of that. And then we're going to run these things inside of the tools database. So for the purposes of this specific thing, it's not giving us any of these things to exercise within like the books database, for example. So what we're going to do is I'm just going to go through the descriptions of this, and then we're actually going to run them to get the answers that is at the end of this task. So the string functions perform operations on a string, returning a value that's associated with that string. So concatenate is used to add two or more strings together, and it's useful to combine text from different columns. So let's say that select concatenate name. So you're going to concatenate the name and say is a type of category book, and as book info would be the from books. So we could technically do this with the tools database that we have right now. So let's just do it inside of where we are right here. So instead of doing it with the book, obviously, I will just do it with the tools that we have. So we're going to say select and then concatenate, so C-O-N-C-A-T, and then we're going to say name, and then comma, space, and then so this part is literal. So everything that's inside the quotation is literal. So you need to do quotation, space, and then we're going to say is a type of, right? And then space again, and then quotation. So that would be a literal string right there. And then we're going to do category. So this tool is a type of category tool, like that. And then we'll close that off. And then this is going to be as tool info from hacking tools. And there we go. So it says Flipper 0 is a type of multi-tool tool. OMG cables is a type of cable-based attack tool. Wi-Fi Pineapple is a type of Wi-Fi hacking tool. So it's nice. It's like it's functional the way that this actually works, right? And we can do this not with just individual fields, because technically this is individual fields that we're putting the name along with the category, right? So we can do this as a group concatenation, where we say, what is it? The group concatenation is a function that helps you concatenate data from multiple rows into one field. So an example would be what they did was select category, and then group concatenate name separator as books from books, and then group them by the category. So that's basically what they did. So what we can do here is we can do a similar version where it's like select category and then group concatenate, and then we will do the I'll just do the same thing that they did. We're just going to pull it from this group in particular. So we're going to group them by their name, and then separator is going to be the comma with a space behind it, and then it's going to be as tools, and then we're going to pull it from the hacking tools and group by category, like that. Press enter. So what do we have? We have their names are here, so this is all good. And then cable-based attacks, multi-tool network intelligence, RFID cloning, USB attacks, and Wi-Fi. And then so I see. So this is what it looks like, right? So for RFID cloning, we have iCopy and we have Proxmark. And then for USB attacks, we have USB Rubber Ducky and Bash Bunny. And so they have been categorized, they've been concatenated by their group, right? So we can see where they fall into as their category itself is concerned, and then which books fall into those categories alongside them. So cable-based attacks only has this tool inside of it. Multi-tool has this inside of it. Network intelligence has this. and then RFID has these two, and then USB attacks has these two, and then Wi-Fi hacking has Wi-Fi pineapple. So this is a group concatenation. This is actually very useful as well. It's just a different way of organization, which I think is very handy, especially if you get into much larger databases and you're looking at tables that have a lot of data and you want to see how these things actually kind of break down. This is something that we would have to practice a lot more though, so that we can kind of internalize and memorize it. So another thing that we can do is the substring function, which will retrieve a substring from a string within a query and starting at a determined position. So the length of this can also be specified. So for example, let's say we are trying to pull the, in this particular case, it's for the published year. So we're dealing with tools here. So there's no published year or anything like this that we have here. We just have the name, the category, description, and the amount. So that unfortunately is not going to work for the hacking tools. So I'll just show you what it looks like on the actual example that they gave us here for the books. So the selecting of the substring from the published date, and then you have 1 and 4 as the published year from books. So it's going from the first position to the fourth position, meaning 1, 2, 3, 4, like that. So it's going to take those 4 characters from the published date, and then it's going to give it to you as your published year from books. And this is what it's going to look like. So we can observe how it extracts the first 4 characters from the published date column and stores them inside the published year. We have the length. So selecting the length of the name, for example, as the name length from books in this case. So we could actually run this, and it basically just counts the number of characters of the name. I'm actually not going to do this because this one's really basic. So you're basically getting the length, and in this particular case, it's also going to calculate the space, I would assume, because that actually counts as a character. When you're doing a character counter, the space also counts as a character. So the query calculates the length of the string within the name column and stores it in a column named name length. And this is what we see over here. And then we have the aggregate functions, which have to do with the value of multiple rows within a specified criteria in the query, and it can combine multiple values into one result. So we have the count function that we've done multiple times. So select the count as total books from books, and it's giving us the total number of books, which is 5 books in this particular case from our, I think it's like THM books 2. I think it's from that database. So it counts the total number of rows in the books table, and the result is 5, as there are 5 books in the books table, and it's stored in the total books column. Then we have the sum function. So we're not going to execute this because it's for example, and it says select the sum of the price as total price from books. So it's essentially calculating the price of all of the books combined. So if you sold all of your books, this is what you stand to make essentially. So it calculates the total sum of the price column. The result provides the aggregate price of all books in the total price, in the column total price. And then we have the max function that calculates the maximum value within a provided column in an expression. And then you have the minimum function that would calculate the minimum value within an expression. So we could technically go for the count, right? And we can take the maximum count, or we can go and get the minimum count. So I'll try to do that right now and see what we can do in this particular case. So let's see, we're going to go get the maximum count of these guys right here, and it's going to be in the amount column. So it'll be select max, and then it's going to be from the amount column as we'll do most amount, and then we'll do from hacking books or from hacking tools. And there we go. And now we have the one that has the most amount is going to be the 375. I don't know what item it is that actually has 375. It would probably be good if we actually were able to pull the name as well. And I'm sure we can. It's just that in this particular case, we did the maximum, and we're getting the amount from hacking tools. And I can probably just combine this with like and select name, right, from hacking tools. So we could actually do it like that. So I'll try it. So I'm going to do select max amount as most amount and name from hacking tools. Let's see if this actually works. It says you have an error in your syntax. Check the manual that corresponds to your server for the right syntax and name from hacking tools. So I guess that was not the correct syntax. So yeah, I'm not gonna go down this rabbit hole just to save us some time and energy. But the max one worked, and then of course the minimum will also work as well. So if I did select min amount as least amount from hacking tools, then we'll be able to pull the one with the least amount, which is 80 pieces. So all right, there we go. So our final set of questions here is using the tools database, what is the tool with the longest name based on character length? So we're going to go pull the character length, and right here, so we're going to select name as name length from books. The thing is though, like I want to be able to pull them from the longest name. So let me see how we could actually do this. So we were so close with this. I was so close with this. So I think it's select name, comma, and then max amount as most amount, and then we'll do from hacking tools. Let me see if this works. I hope this works. It still didn't work. There's something that I'm missing. I feel like I'm so close though. So I think for this, it could probably be like select name, comma, length of name, and then as name length from books. Let's try that and see if it actually works, because that would be if I figure this out, I would be super excited. So if we do select name, comma, and then length of name as name length from hacking tools. That worked. So I wonder why the max amount thing doesn't work. Maybe it's because it's like it's an integer calculation kind of a thing. Maybe that's why it's not working. But the name and then lame length actually did work. So the longest name is the USB rubber ducky, based on the count right here that we have over here. So let's go over here and we'll do USB rubber ducky. Oh, maybe the freaking hint could have helped me too. So let's see, it says use the length function and sort the tool name in descending order. Oh, I mean, I could have sorted that too. I didn't even sort it. I just counted it. How would we do the sort? Now I wanna sort it too. It would be by not the group by, it was the order by. So it would be by the order by. And then we can also order, so we can basically do this same thing right here, except what we would do is we will do select name, and then we will do the length of the name as name length from hacking tools, and then order by name length, and then descending order. Wait, is it order by? Hold on. Am I misspelling order by? Yes. I am definitely misspelling order by. Can I press up and take that? Oh, very good. Okay, so we can do that. It's order by is not separated by a underscore. There we go. Hey, there we go. That worked. Okay, great. So, all right, we're getting some complicated, complex queries here. So select the name and the length of the name as name length from hacking tools, and order them by the name length descending order. And then so that's what we got right here, and we were able to actually do what the hint told us here, which was to sort the tool in descending order. So very good. Okay, cool. So the next question here is use the tools database. What is the total sum of all tools? Which is for our amount right there, and we're gonna be able to just to select sum price as total price from books. So we are going to, I'm just going to type it right here. So it's going to be select sum, and it's not come, select sum of the amount as total count, and then from hacking tools. And there we go, 1,444 is our total count. So let's do that. Very good. And then using the tools database, what are the tool names where the amount does not end in 0, and group the tool names concatenated by and. Oh my gosh. Okay. All right. So where the amount does not end in 0 and group them concatenated by and. That's unbelievable. All right, so I know that we are going to be needing the substring portion of this, and we're also going to be using the group concatenate, which is right here, and then we are separating with the ampersand as they requested. So we're kind of combining, or not kind of, we're actually combining two of these things to make this work, okay? This is what I think is going to be our yielding query. I think this is what the final query is going to look like. So first we are going to select from the group concatenation. So we're going to concatenate the name of the group, and the separator is going to be the ampersand. So I need to put that inside of the, my God. Okay, here we go. So there we go. So it's going to be, we're first going to group concatenate the name, and the separator is going to be the ampersand. And then we'll just put it as the names, whatever. And then we're pulling this from the hacking tools. So that's fine. That part is easy. This is where the part that is kind of the tricky part that I didn't know really what to pull from. And it kind of makes sense because it's similar in Python as well. So the substring is what we're using, and we're looking for the amount. So we're looking at the amount value, and we want the last thing. So when you go from 1 to 4, so if we look at this right here, you see right here, is looking at the first character and it's going to the fourth character. But there's a way that you can come from the end of the value and come from this last one and come backwards instead of going forward. And the way that we do that is by using a -1. So if you do a -1, then you're looking at, okay, let me just make sure that I can do, okay, there we go. So a -1. So when you do a -1, you're coming from the last character, and then we're coming in 1. So we were literally just looking at that very last item on the amount, and we don't want that to be a 0. That's basically it. And this is the string right here. So this is the part that it was kind of a little bit tricky for me to figure out. And it's trying to find out how to designate the last character of the amount. And so if we start at a -1, we're looking at the very end of the value and coming to the left, right? So if we're looking at this as the end of the value, coming 1 character to the left, that means you're coming from the -1 position, coming 1 to the left, and now you're looking at this very last item. And we just don't want that to equal to 0. So fingers crossed. Let's see if this actually works. And it did. Look at that. So the flipper 0 and ICopyS were the ones that were not ending in 0, and then we combined their names together by separating them with the ampersand. So the group concatenate part of it is kind of, it's like the simpler part of this specific query. It's this piece right here that, for me anyways, it was a little bit confusing. So this is how we do it. So we have the -1 that implies that very last character coming in by 1 space, so that ends up looking at the very last item. And then as long as that's not 0, then we would be all good. So that would be the flipper 0 and the ICopyXS. So now we can copy this, and let's hope that that's actually the answer here. And it is. That is very satisfying. I very much enjoy when things like this actually work. So that was it for our SQL room. I was actually very happy with that because I learned a few extra things that I did not know before. So I hope you also learned from this particular video and this particular room that we were in. It is not a free room, so you do need to have MySQL on your computer. If you don't have TryHackMe, you do need to have MySQL to be able to run the exercises that we ran. But I mean, for the most part, it was fairly easy to wrap your head around as long as you just follow the instructions. So you know, feel free to replay each segment and go through the whole thing just to really wrap your head around it, because this is very powerful. SQL in general is a very powerful tool, and it's a very language to learn, a good language to learn, because you end up using it in so many different environments. So I hope you actually found a lot of value out of this particular room, because for me it was very useful. And of course, if you did find value from it, make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, especially in the CySec 101 training series as we continue to go through it. And drop a comment if you have any questions. I know this one was a little bit complicated for me, it was at least, so I don't know what your strength level is when it comes down to SQL. But for me, I was going through a little bit of a learning curve as I was trying to explain all of it for you. And I'm glad we just achieved success by the end of it. So if you have any questions, drop the comment in the comment section. I will definitely respond to your comments. And of course, just make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And drop a comment if you just want to say hi or if you want to say thanks. And of course, you can always support this channel by joining the Hackaholics Anonymous community, the premier community for security professionals and hackers. We have 4 tiers: the Cyber Supporter, Agent, Guardian, and Master. And each tier gets their own Discord server and early access to content. And the Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there. Or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that's it. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. I hope you found this video useful. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video. Later. In episode 33 of the CySec 101 training series, we're going to go through the Burp Suite basics, and this is one of the most powerful tools that is available in web hacking and pen testing, and this is a part of the web hacking module that is a part of the Cybersecurity 101 pathway of TryHackMe. And this is actually, I think, our second to last. Yeah, so this is right after this one. We do have the OWASP top 10. And then after that, we will be done with the web hacking module officially. And then we can move on to OffSec and all the tools and the variety of tactics that we can use there. So super excited about this one. I think we're going to learn a lot about this one, or inside of this particular episode. We have the intro to Burp Suite, what is Burp Suite, features of Burp community, installation, dashboard, navigation, options, introduction to the Burp proxy, connecting to the Burp proxy, the sitemap, issue definitions, Burp Suite browser, scoping, targeting, proxying the HTTPS, and then example attacks. And it's a pretty big one. This it's going to be like a good video that we're going to take as an introduction to Burp Suite. So it's going to be a nice little exercise that we're going to do today. If you'd like to support this channel, consider joining Hackaholics Anonymous, the premier community for security professionals and hackers. We have 4 tiers available: the Supporter, Agent, Guardian, and Master. And each tier gets their own Discord server and early access to content. And the Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Burp Suite basics room. In this episode, we're going to be going through the basics of Burp Suite, and that's the real aim, because honestly, it's a very massive tool. There are so many things that you can do with it, and then it has the various versions of it as well. So we are going to be scratching the surface. So we're going to go through the introduction, a thorough introduction to Burp Suite, comprehensive overview of the various tools that are available within the Burp Suite framework, and then detailed guidance of the process of installing Burp Suite on your system, and then navigating and configuring Burp Suite according to your particular needs. One of the big things we're going to be talking about is the Burp proxy, which is a really powerful tool, a very powerful part of Burp Suite. I feel like it's like one of the main pieces, if not the main piece of Burp Suite. And this room will serve as a foundational resource for acquiring knowledge about Burp Suite. There are other videos that I have done on Burp Suite that are already existing on this channel, but we're looking at Burp Suite from the perspective of Cybersecurity 101. So just keep that in mind. If you've gone through Burp Suite already and you're very familiar with it, this room will probably be more of a refresher than anything else for you. There's going to be an emphasis on theoretical content. If you haven't already utilized it, then it's recommended that you understand everything that we do today and you actually review everything in detail. If you've never used Burp Suite before, this is probably the perfect video for you. If you have used it before, you're going to get a review. That's essentially the gist of everything that we're going to be talking about today in this particular episode. All right, so what is Burp Suite? And this is a Java-based framework that's designed to serve as a comprehensive solution for conducting web application pen testing. It's the industry standard, literally. Everybody knows about it. And you can test web applications, you can test mobile applications, and even those that actually have APIs, which is the application programming interface. Simply put, it captures and enables the manipulation of all of the HTTP, HTTPS requests between a browser and a web server, and then it's the backbone of that framework, that capturing, which is the proxy. By intercepting these requests, we have the flexibility to route them to various components, which we'll explore in a little bit, and then by ability to intercept, view, and modify the web requests before they reach the target server, or even manipulate the response of the server before it is received by our browser. This is one of the key things that you can do, or some of the key things that you can do with Burp Suite. So as we can see, the image is like very perfect right here. This is the client, the web browser. This is the web server, and then we have Burp Suite acting as our middle person that will capture those requests and those responses, and then allow us to manipulate those requests and those responses. So very powerful tool. There are several versions of Burp Suite. So there's the professional version, which is the unrestricted version of it, and it has all of these features. I'm not going to go into great detail. You can definitely read through them if you want, or you can just go through the Portswigger website and actually read more about Burp Suite. In short, the professional version is the highly potent tool, making it a preferred choice for professionals in the field. And then there's the enterprise version, and then the one that we're going to be using today is the community version. So the enterprise version, in contrast to the community and professional editions, is primarily used for continuous scanning, and it features the automated scanner that periodically scans web applications for vulnerabilities, like tools like Nessus. And then, unlike other editions which allow manual attacks from a local machine, Enterprise resides on a server that is constantly scans the target web application for potential vulnerabilities. So there are licenses that are required for professional and enterprise versions, which means we are going to be using the community version, and that's the version that I'm going to walk you through installation so that you can at least access it, so that we can go through the rest of the exercises together. The first question we have here is, which edition of Burp Suite runs on a server and provides constant scanning for target web apps? And that would be the enterprise version that runs on a server. And then Burp Suite is frequently used when attacking web applications and mobile applications. And that's it for this particular section. So let's talk about the features of Burp Suite. So the version of what we're going to be using is the Burp community, and it is more limited compared to the professional and enterprise versions, obviously, but it still has a lot of great tools that you can actually use for web application testing, obviously legally, and you don't want to do this without permission, yada, yada, yada. There is the proxy, the repeater, the intruder, encoder. or decoder, excuse me, the comparer, and the sequencer. And the proxy is the most renowned aspect of it. Is everything else pretty much relies on the proxy. It enables the interception and modification of requests and responses while interacting with the web application. The repeater is another feature that allows for capturing, modifying, and resending the same request multiple times. And it's particularly useful when crafting payloads through trial and error, for example, for SQL injection or testing the functionality of an endpoint for vulnerabilities. Then there's the intruder, which despite the rate limitations will actually allow you to spray endpoints with requests, and it's used for brute force attacks specifically, or fuzzing endpoints. Then we have the decoder, which is a valuable service. There are other decoder services that you can use, but this captures information and can decode it or encode the payloads before sending them to your target. And there are alternative services, but doing this inside of the actual Burp Suite applications can be very efficient, and it saves time. Same thing with the comparer. It enables the comparison of two pieces of data, either the word or byte level. And while not exclusive to Burp Suite, to be able to do this inside of Burp Suite will, again, significantly accelerate your process and make things faster. And then we have the sequencer, which is typically employed when assessing the randomness of tokens like session cookies, values, or other supposedly randomly generated data. And if the algorithm used for generating these values lacks the secure randomness, it can expose the avenues for devastating attacks, which is, again, something that's available with Burp Suite Community. So it's a very powerful tool. So beyond the built-in features, there's the code database of Burp Suite that facilitates development of extensions to enhance your functionality, and it can be written in Java or Python using the Java Python interpreter, or Ruby using the Java Ruby interpreter. Burp Suite Extender module allows to quickly and easily add extensions into the framework from the marketplace known as the BAP store, enabling the downloading of third-party modules. And then certain extensions require professional license, so just keep that in mind. But there are free versions available of certain extensions, for example, the Logger++ that can extend built-in logging functionality of Burp Suite. So which Burp Suite feature allows us to interpret requests between ourselves and the target? That would be the proxy. Which Burp Suite tool would be used to brute force a login form? And that would be the intruder. All right, let's talk about installation. For the case of this video and pretty much every other video that I've done with TryHackMe, I always use the attack box inside of TryHackMe that has a version of Ubuntu Kali Linux installed on it that has a lot of these pen testing tools already pre-installed on it. So Burp Suite is actually already installed on the virtual machine that I'm going to be using. And then if you install Kali Linux directly from the Kali website, you will also get Burp Suite pre-installed with Kali Linux, because Kali Linux is literally designed for pen testing, and Burp Suite is one of the most powerful tools for pen testing. So it would be silly if they didn't have Burp Suite pre-installed on Kali Linux. In case you don't have that, so in case you don't have the attack box from TryHackMe or you don't have Kali Linux, what you can do is you can just go directly to the Portswigger website and just download it from Portswigger directly. I'm already running a Mac OS, so it will detect your system or detect my system. But you can do it for Linux, Mac OS, Windows, and the Burp Suite professional version, community version, so on and so forth. So 2025.1 would be the most recent version of this, which is not the version that I'm going to be using for this particular video. I think it's one of the older versions that's available on the TryHackMe attack boxes. But these are the various releases that are available. Obviously, you want the most recent one, and you want the one that is available for your specific operating system. And you can get to this link by either just going to portswigger.net, and then you have Burp releases, that is the actual domain right here. Or you can just Google download Burp Suite and just make sure you're downloading it from portswigger.net and you're not downloading it from some other third-party website. So once you have your installation file, you basically just go through the installation wizard and make sure that you download and install the version that is most applicable to you. So as we're reading this, literally they're looking at the most recent version being 2023.7. So I feel like the version that I'm going to be using is the 2023.7 based on what's going on from that screenshot. But for the most part, what you will have will show exactly what I'm seeing plus some extra options. And then I'll give you a couple couple of other resources so you can learn about those options. There's a quick note here that if you choose not to use sudo during installation on Linux, Burp Suite will be installed in the home directory at Burp Suite community like here, and then it won't be added to your environment path. So that's completely up to you if you don't want it to be installed on your environment path, or if you're using a machine that you don't think should have it permanently installed on the environment path. That's completely up to you. I do think that if it is being installed on your actual personal computer and you're going to be using it regularly, it's probably beneficial and convenient for you to also have it added to your path. Apart from that, if you just follow the installation wizard, everything is going to be pretty straightforward for you, and you should get Burp Suite available for the rest of this video. So this would be the moment in the video where I would recommend that you pause the video, go get the install file, install it on your computer, make sure you're good, and then we will run it together, and then we'll go through all of the initial screens as well as the dashboard and the rest of the options together. All right, so let's look at the dashboard. I have this in my full screen mode right here. This is the Linux machine right here. We just get it started. It'll usually take about maybe a minute or something because this machine doesn't have the fastest RAM because it is one of the virtual machines, so on and so forth. But while this loads, that was pretty quick. It was quicker than the last time that I ran it. So usually when you start it, the first thing that you will see will be the menu where you actually get to choose a project to work with, and then we'll talk about global settings and user settings in a minute as well. And then from there, you get to choose configurations. So that would be the first two options. And then from there, you should see the Learn menu. So if you are accessing Burp Suite for the very first time, it will show you the Learn menu, which has all of the tutorials, and it's highly recommended. If you've never been through Burp Suite before, if you've never used it before, it's probably a good idea to go through all of those Learn modules, all of the training modules that it has, so that you get like a really strong education on the tool, and you know what the various options that are available. I don't think it's going to show you everything that's available on Burp Suite inside of those training modules, but it'll definitely be a really good start for you to learn about the tool and the various elements of the tool. I'm just going to let this finish loading real quick. Oh, actually, there we go. Perfect. So it finished loading. So this is what it looks like, right? So on the community version, you can't do a saving of the project. So every time that you restart the tool, or every time that you turn it off, you exit out of Burp Suite, whatever project you were working on is pretty much gone, and then it'll restart from scratch. That's one of the key pieces of the professional and the enterprise versions. So we are just going to be using a temporary project that's going to be stored in memory. And then the next menu is using the Burp defaults, which is what I'm going to end up doing. But you can also load from a configuration file, and then you can actually go ahead and configure the Burp JSON file or modify it so that you can actually have your personal, that's beyond the scope of what we're going to be talking about. We're literally talking about the basics of Burp Suite. So we're not going to talk about the configuration file of Burp, but it is an option that is available for you. So I will click the start button, and then it will take us initially to the dashboard. Now, I don't think it's going to take me to the actual training menu, because I think on my virtual machine and a variety of different virtual machines with TryHackMe, Burp Suite has been used so frequently that, yeah, it's not going to show us the training menu, which is perfectly fine. So if you look at the top tab right here, this is our modules tab. And if we click on Learn right here, this is the Learn menu. This is like the training modules that you have. And this is just what's available through Burp Suite. There are, again, like I said, there are videos that I've created on this channel where we actually do a much deeper dive into the tool, and we run various exercises with Burp Suite. And then there's a bunch of other videos on YouTube as well. So if you are really interested in it, I would recommend you watch all the other videos on this channel. And then if you want, go watch even more videos and read all the documentation and just get really good at using this tool. I don't think you will be disappointed by learning more about our Burp Suite. So in our dashboard right here, we have a tasks menu. In the screenshot that we would see in the training documents here, we have the tasks menu, we have the issue activity, we have the event log, and we have the advisory. So starting from the task, this allows you to define the background task that Burp Suite will actually run while you are using the application to do other things. So you can actually basically designate background tasks to run while you're using Burp Suite. In Burp Suite community, the default would be the live passive crawl task, which automatically logs the pages that are visited, and it's sufficient for our purposes for everything that we're going to do in CySec 101. We have the event log, which provides the information about the actions that are performed by Burp Suite, like starting the proxy and the details about connections that are made. And then we have the issue activity, which is specific to Burp Professional, and it displays the vulnerabilities identified by the automated scanner, ranked by severity and filterable based on certainty of the vulnerability. And then we have the advisory, which provides more detailed information about the vulnerabilities, like references and suggested remediations. This is also available to give you a report, and this is also not available, or at least the showing of the vulnerabilities will not be available in Burp community. So issue activity is very specific to the professional version, and then there are certain things about the advisory that are not available to the community. But for the most part, this would be like the dashboard if you have like I guess a more recent version of Burp installed, or if the configuration has been designed for you so that you can actually see these menus in your version of Burp Suite. And then, of course, as we mentioned earlier, there are different ways that you get help menus or more information. And one of them is the question mark. As you look at a variety of tasks. So we have the question mark right here in the actual tasks menu. We have the question. There's going to be where you can get more information about whatever that segment is. And I mean, if you don't know what it is, it would probably be recommended for you to read through all the help that is available on the question mark as well. So what menu provides information about the actions performed by Burp Suite, like starting the proxy, so on and so forth, and that would be our event log. So now let's talk about navigation. All right, so what better way to look at navigation by actually going through the navigation menu? So at the very top that we see right here, this tab, or this, I guess this section that you see right here, that is known as the module selection menu. So each one of these are technically our modules. So the target module, the proxy module, the intruder, collaborator, decoder, so on and so forth, right? So if we go to certain these, so like target, for example, or proxy, you'll see that there's another set of items that shows up at the bottom right here. And these are our sub tabs. This is just like technical jargon, the terminology. So this is the actual module menu. And then some of the modules have their own sub tabs, and they can be accessed through the second menu bar that appears directly right below the modules themselves, and they are specific to the module. So for example, the HTTP history is specific to the proxy, for example, and the intercept is specific to the proxy, right? And then there's an option that they talk about in the documentation here, which is the window detachment option, which is not available for me. So it usually should be right next to the help button at the top right here, where there would be a window button. And then you do that and it drops down and it allows you to like detach the dashboard or detach the proxy, so on and so forth. So that unfortunately is not available for me, and it's a little bit it's like disheartening, right? It's a little bit tough to deal with for me personally, because I would love to be able to do that, but I can't do that in the version that I'm running on this virtual machine as a test for TryHackMe, whatever. And then we have these shortcuts, and these can also be modified. You can create your own shortcuts through the hotkeys, and we'll be talking about that in a little bit. And so that's basically it. So it's like Control-Shift-D will take you to the dashboard, Control-Shift-T will take you to the target, P will take you to proxy, I will take you to intruder, and R will take you to the repeater. So if I go here, so let me make sure I'm just actually clicked onto the screen here. So if we do Control-Shift-D, we should go to the dashboard. There we go. Control-Shift-P will take us to the proxy. Control-Shift-I will take me to the intruder. So it's pretty useful if you know what you're trying to do and where you're trying to go. It's very, very convenient to be able to do that. And then there's also shortcuts for actually sending data to the intruder. So for example, Control I, so no shift, right? Control I by itself will take you to the intruder. Control R will take it to the repeater. It'll send the data to the repeater. My bad. So it'll send data to the intruder if you just do Control I. If you do Control R, it'll send the data to the repeater, and then you'll be able to further manipulate the data that way. So which tab does Control Shift P switch us to? And that would be the proxy tab, P for proxy. All right, so let's look at options now. Okay, so there are two different types of settings, two different sets of settings. We have the global settings and the project settings. And the global settings affect the entire installation of Burp Suite, and they're applied every single time that you start the application. And it's basically the baseline configuration that you want for your version of Burp Suite, right? So this is it's specific to whoever the user is and what they want to start every single time that they start Burp Suite. And then there's the project settings that are specific to the current project, and they apply only during the session. And then the community edition, as we already saw when we started it, it doesn't support saving projects. So basically anytime that you close it and restart it, it resets all of the settings for the project. So we can't really just use it because of the version of community that we're going to be using. But even though you have certain global settings set up, you can actually change your project settings to be different from the global settings. So it doesn't mean that if you have global settings, you can't still turn certain things off or on based on your project, okay? Then you have the settings menu. So the settings menu can be accessible from a bunch of different locations. So first of all, we have it on the far right here. This is always going to be available. And you just click on that and it'll open up the settings menu, okay? And then there's the individual portion. So like if we go to the proxy module, there's the proxy settings button right here. You click that and it'll bring up the settings menu again, but it'll take you directly to the proxy settings. And then we have the actual button right here, which is pretty much like every other application where you just go to one of these sections right here and it'll take you to settings. So for us, it's Burp, and then we go to settings, and again, it just opens up these settings. And then you can have different types of settings, right? So you can have the user specific settings, you can have the project specific settings, and then you can have all of the settings. You can expand everything, you can collapse everything. And then of course you can search for things here. So we can do, let's say, hotkeys, right? I can search for hotkeys and it'll bring me to the shortcuts that are available for me over here. And even if I don't do that, if I actually do just key, right? So whoops, I don't know what I just did. Let me see if I can still type here. It seems like I have messed up something. All right, okay, that's better. I think I double clicked the control button and it started recording audio. That was awkward. So if we can actually even just type keys, right, it'll give us keys. Or if I do keyboard shortcut, for example, I guess keyboard shortcut won't bring it up. I think, but it was like maybe shortcut or something. Sorry about that, like that little sound. It happens when I erase everything. And then if I go one more erase, it'll do that. So sorry about that. Sometimes it gets annoying. So I do realize that it does get annoying. But yeah, so basically you can search for settings and you can search for certain things if you know what you're looking for. Or you could just browse through whatever the options are to see if you can find whatever you actually need. So that is it for our settings menu. Now we do have a couple of questions here. So let's go through the questions for the options. And I'm pretty sure I covered everything with you. So we do have, what do we have? So in which category can you find a reference to the cookie jar, right? So the best way to do that would be to just go to settings and then go over here and just type in cookie jar, right? And then it'll show you the cookie jar, and then it'll say that we are inside of sessions. So that's where you would get that answer. It's inside of the sessions tab or category. The Burp proxy is literally a fundamental and crucial tool within Burp Suite. Everything pretty much relies on the proxy. It captures requests and responses between the user and the target web server, and this traffic can be manipulated, sent to other tools, or explicitly allowed to continue to the destination. So you essentially capture the request and then it freezes inside of the web browser, and then you can manipulate it before forwarding it, or you can just explicitly allow it to continue as is. The intercepting of requests is done when you actually turn on the intercept button. So if we go over here and we actually go to the Burp proxy, we'll be able to see that intercept is already turned on. While the intercept is turned on, whatever request we send to our browser, as long as we also have Foxy proxy that's turned on inside of the browser, whatever request that we send will actually be captured inside of Burp Suite. So right now, I don't have it turned on. So I can click on Foxy proxy and I can just click on this thing right here because it's been pre-configured for me. And that's pretty much it. That means I've already turned on Foxy proxy. So now it's connected to Burp Suite. And then if I go over here and do whatever kind of search, so let's say we'll do gmail.com, let's say. We will do gmail.com. And then that request, you can kind of see that it's like frozen here. We can go over here and check to see if it's actually been captured. Oh, it's restarting Burp Suite. My bad. I should not have done that. Now it's going to take up even more RAM. So let me make sure I close that out. Okay, here we go. So this is the one that I already had open, and then we can see that it's actually capturing the requests that we have. So HTTP GET request, and it's the google.com. And it's trying to capture Gmail for me, right? And then there's the detection portal, or these are actually all of the intercept stuff that's actually happening currently live while this is running in the background, while I actually have this running in the background. Now, what I can do is I can submit any of these or manipulate any of these, and then we can go over here, and then we can see the request at the bottom right here. And then any of this data, so this is basically just a GET request to gmail.com. I can forward this data to, let's say, the intruder by just doing Control-I, and then it'll send it to the intruder, and then we can see that the intruder it's highlighting now. And if we go over here, we can see that we actually have the Gmail request that we forwarded to the intruder, and then now I can manipulate this request in a variety of different ways if I wanted to, right? And then if I just go back over here and I can essentially do this, right? So if I go here, I can click on forward or drop, which means it'll either forward this request and actually make it run in the browser, or I can just drop the request, meaning cancel the request. So if I click on forward and then I go back to the browser, it should actually try to load Gmail for me. So let's see if that'll work. So I stand corrected. Forward is actually trying to forward it to I think a different tool inside of Burp Suite. If we turn off intercept, it should allow it to load in the background, which it does. So there you go. So the intercept has been turned off, and then it actually allows us to end up at Gmail. And then if we wanted to, now let's say I go over here and I do Hank hacks hackers, right? And I try to log into my Gmail account. I just have to make sure that I go back over here and I turn on intercept one more time, because I want to make sure that it actually captures what I'm doing here. And then I go over here, and then when I click next, now this is going to be captured, and then I got a little notification on Burp Suite right here. So this is going to freeze inside the browser, and then the request is going to be captured over here. And now we can see that we have a new set of requests that are playing up over here, and then they're for accounts.google. And if we go down here, we can see the data that is being requested to be sent. And then there's a form that is URL encoded, which means that we're actually trying to send data through the form on the web page, but Gmail is very strong with this. So obviously the form data that I'm sending is super encrypted, and you're not able to see what it is that I'm trying to do. If somebody's trying to analyze this request, they'll be like, okay, well, it's a post request, so that means they're trying to send data, and then it's to accounts.google, so most likely they're trying to log into some kind of Google service because they're going through the accounts.google host, right? And then this is the actual path that we're trying to log into right here. So it is v3 sign in, account sign in data, And nowhere in this do we actually get any kind of idea, unless we decode this information here. We don't get any kind of idea of what it is that I'm trying to log into, or this person is trying to log into, right? So that is the overall approach of just intercepting and then looking at what the data is, and then from there you can forward it to the repeater or the collaborator or something like that, and then mess around and kind of manipulate the data. If I turn off intercept, it'll actually take me to the next page and it'll say, hey, Hank, enter your password, right? So that is the basic gist of using the proxy. So let's go look at the rest of our notes over here. This is different from what we just saw in our example, right? Because we actually had a list of links that were showing up as the intercept was on, and everything that was potentially going to be intercepted from that request that I made inside my web browser was actually showing as a line item. And then in the bottom section, we actually saw the raw code. So you can have the ability to intercept requests, empowering you to gain complete control over web traffic, making it invaluable for testing web applications. You can capture and log. So the requests that are made through the proxy by default could be captured and logged even when the interception is off. This logging functionality can be helpful for later analysis and review of prior requests. The WebSocket support, so Burp Suite also captures and logs WebSocket communication, providing additional assistance when analyzing web applications. This is the menu that we were just kind of looking at. And then we have the logs and the history. So the captured request can be reviewed in HTTP history and WebSockets history subtabs, allowing the retrospective analysis and sending the request to other Burp modules as needed. So proxy specific options can be accessed by clicking proxy settings, and these will provide extensive control over the proxy's behavior and functionality. So getting familiar with this will be very, very powerful for you as somebody who wants to use Burp Suite. Notable features in proxy settings would be the response interception. By default, the proxy does not intercept server responses unless explicitly requested on a per request basis. The intercept responses based on the following rules checkbox, along with the defined rules, allows for a more flexible response interception. So you can actually intercept responses from the web server, and it would be under the response interception rules section of the proxy settings. And then you first have to turn on the intercept response based on the rules, and then over here you actually come and create, modify, or remove the rules that you want, right? Then you have the match and replace section in the proxy settings that enables the uses of regular expressions, also known as regex, which is very powerful for patterns, so that you can modify incoming and outgoing requests. This feature allows for dynamic changes, like as modifying the user agent or manipulating cookies. So we can look around with this a little bit as well. There are no answers that are required for this, so let's just go look at proxy settings a little bit just to kind of play around with it as well. So we have the proxy listeners at the very top, and this is essentially the first configuration that you have to make in order for you to be able to use the proxy. So proxy, that's essentially the proxy listener that we are using, and then you just set that up, and it's for the loopback address on port 8080. It's very typical, and it's usually what the setup of that is like. Then we have the requesting of the interception rules, which is literally what we just talked about. So intercept rules or intercept requests based on the following rules. And then we actually have that over here. So based on any of these responses, so if the file extension does not match these things, then it'll actually intercept all of the responses for that. And then what do we have? Response interception rules, some more. So what do we have? So let's see what the top section was, because it sounds similar to the previous one. So if I scroll up a little bit more, let me see if I could do this. Oh no, that was it. So this was the response interception rules. I don't know what I just saw. I feel like I scrolled too much. We have two of them. So we have a response interception rule, or request, excuse me, my bad. I'm jumping ahead of myself. So request interception rules is what we see over here. And then below this is what we have for response interception rule. I did think that it was kind of weird that it was already checked on. So this is not checked on, right? So intercept responses is not checked on. And then this would be the option. If it was checked on, this would be the rule that it would be captured. And then we have the WebSocket interception rules available. We have intercept client to server messages and server to client messages. And it keeps rolling to the top. I don't know why it keeps doing that. And then we have modification rules for the responses. And then we have HTTP match and replace rules that we can see over here as well. And then the WebSocket match and replace, and then TLS pass through, and default proxy, and then proxy history logging, default proxy interception, and a bunch of miscellaneous rules. So there's a lot of rules just for the proxy, right? So just imagine what all of these different things are, that, and all of the different options that you can set up for the various modules that are available inside of Burp Suite. So it is a really powerful tool. Like I said, there's a lot of stuff that you can do with it. So now let's actually talk about the connection through Foxy Proxy. Setting up Foxy Proxy is very easy to do as long as you have it installed on your browser. And from what I understand, because, hence the name Foxy Proxy, I believe it is just proprietary to Firefox, right? I think it's specific to Firefox. We need to configure the local web browser to redirect the traffic through Burp Suite. That's basically what we're doing. In order to be able to use Burp Suite's proxy, we have to be able to do that. The instructions provided are specific to Firefox. If you're using a different browser, you may need to find an alternative method or use the TryHackMe hackbox or attack box, excuse me. So I'm not saying that there are no proxies, web browser proxies for Google Chrome. I just know that for Foxy Proxy, I believe it is specific to Google Chrome, and everything that I've done so far has been on Mozilla Firefox when it comes down to Burp Suite. So just kind of giving you a little heads up over there. So first you would install Foxy Proxy, and you would do that through the basic installation, which is available through the add-ons for Mozilla.com, and that's the website right here. So addonsmozilla.org, excuse me, and then under extensions you can see Foxy Proxy, and then you just download the extension and you install it. And then the next thing would be to actually go to the options, right? So when we go to the browser right here, over here you can actually click on the little icon, and then you can go to the options that's available right here, and you click on options and it'll open up the options for you. And then it's fairly intuitive, right? The rest of it should be fairly simple. So over here, this is the options menu, and then you can go to proxies, and then we can now add a proxy, and then you just fill in the basic information. So the title, which in this example, it was the Burp title, country or whatever, all of that stuff is all good. The host name is what's important. So the host name in this particular case is the 127.0.0.1, and that is the loopback address, and then the port number would be port 8080, and that was what was the installation was for the Burp Suite. So you can see it right here. So you have Burp, that's the basic name of it, 127.0.0.1, and then port 8080, and then this needs to also be configured in the let me just close this out. This needs to be configured inside of Burp Suite in order for this to actually work, right? So if we go over here and then we go to proxy settings, and we can see that we have this very basic first one that we have here. And if I just click edit, you'll see that this is it, right? So this is the binding. It's binded to port 8080 because that was the port that was selected through Foxy Proxy. And then loopback address only is the address for 127.0.0.1. You can loop back to all of your interfaces to be able to capture all of the traffic from every interface on your machine, which will be a lot of traffic, and it'll be a lot of stuff to sift and sort through. Or you can loop back or capture a specific address. 127.0.0.1 is also under the specific address list, but again, it's the loopback address. So if you just do the loopback only, it'll automatically just select the 127.0.0.1 as the address, and then this is what it's going to look like as the interface that's selected for it. And now you can actually use Foxy Proxy. So if we go back over here, we can basically just kind of reaffirm those instructions, right? So the menu that we saw was a little bit different from this, but essentially as long as you're under the proxy section, you can click on add and you'll be able to add one. The title for it could be anything. In this case, it's Burp because we're using the Burp Suite application. So we just want to know that this is for Burp. The proxy IP address is 127.0.0.1. The port port is 8080, and then this is what the options look like. And then you click save, and then once you want to use it, you can see that that was basically what I did, right? I just went over here and I clicked on the burp button, and then you can either disable it or you can choose one of the interfaces that you had. So for me it was burp. If I click disable, it'll just be turned off, and I can just click out of it and it will be turned off. It should be turned off. Let me make sure that it is turned off. Okay, there you go. It's turned off, and I can click on it again and then click on burp, and it'll say that burp has been turned on, and now we are good to go. Then when you actually go to the Burp suite, you want to be on proxy, and you want to make sure that intercept is turned on, as you already saw, and that should be it. So, and then you can just test the proxy, open Firefox, try to access the website, which is what we just did, and then the home page for this particular page, your browser will hang, meaning it'll just freeze, and the proxy will populate with the HTTP request. Congratulations, you've successfully intercepted your first request. And when the configuration is active, the intercept switch is on, your browser will hang when you make a request. That's what that means. It'll just freeze. It'll kind of stay stuck. Be cautious not to leave the intercept switch on unintentionally, as it can prevent the browser from making any requests. And right-clicking on a request in Burp Suite allows you to perform various actions like forwarding, dropping, sending to other tools, or selecting the options from the right-click menu. So let's actually go to this particular address that they have for us over here. I feel like it's going to show us something different than what I tried to do with Gmail. So let me just make sure that I have this open, and let's go and close this tab and turn on intercept, and then go back to this here, and then we're just going to paste the IP address that we had over there, and then we're going to go to that. So let me see if I can paste it. I feel like I should be able to paste it by Control V. Okay, there we go. So we have that, and now we can see that it is hanging, or it's frozen, as they say. And then we will go over here, and then now we can see that we actually have the request right here. Excellent. So I click on this one, and this is going to be the request that we see at the bottom right here. And then I can right click on it, and it'll give me a bunch of different things. I can add it to my scope of tracking. I can highlight it. I can do intercept or don't intercept the request for that. I can send it to intruder, repeater, sequencer, organizer, comparer, or in browser. And in browser, it'll actually try to open up its own browser, because Burp Suite actually does have a browser, which I forget what which browser it uses, but I definitely do know that it does have a browser, and it tries to open up its own browser. It won't try to open up the browser that we have in the background there. And that's basically it, right? So this is how we intercept a request, and congratulations, we just saw it. So if we look at the raw HTML, it looks pretty consistent to the other HTML. You can also look at the hexadecimal format of the HTML, and that's basically it. So if I turn off intercept, the actual request in the background will end up going to the test website that we have, which is the Bastion hosting website, and we have our products, about us, in-house experts. I feel like this is what we're going to end up doing later on in our exercise, so I'm not going to jump ahead, and I won't take the steam out of the rest of the exercise. So let's go and look at the sitemap and issue definitions. Under the Target tab in Burp Suite, we get more than just control over the scope of the testing. We have 3 sub-tabs. We have the sitemap, and it allows us to map out the web application we're targeting in a tree structure. Every page that we visit while the proxy is active will be displayed on the sitemap. This feature enables us to automatically generate a sitemap by simply browsing the web application. And in the professional version of Burp, we can also use the sitemap to perform automated crawling of the target, exploring links between pages and mapping out as much of the site as possible. Even with community, we can still utilize the sitemap to accumulate data during the initial enumeration steps. It is particularly useful for mapping out APIs, as any API endpoint accessed by the web application will be captured in the sitemap. Issue definitions. So Burp community does not include the full vulnerability scanning functionality. We still have access to a list of vulnerabilities that the scanner looks for. Issue definition section provides an extensive list of web vulnerabilities, complete with descriptions and references. And this resource can be valuable for referencing vulnerabilities in reports or assisting in describing a particular vulnerability. Then we have the scope settings that allows us to control the target scope in Burp Suite, and it enables us to include or exclude specific domains or IPs to define the scope of the testing. By managing the scope, we can focus on the web applications we are specifically targeting and avoid capturing unnecessary traffic. Overall, the Target tab offers features beyond scoping, allows us to map out the application, fine-tune or target a scope, and access a comprehensive list of vulnerabilities for references. So now we're going to look around the site, meaning we're just going to click around and we're just going to make sure that the proxy is turned on. Not intercept, right? Because if we intercept, we can't do anything. It'll just hang in the background. So as long as the proxy itself is turned on, which is what is going on over here, right? We have Foxy proxy turned on. So now we can just click on these various things, right? I'm technically on the home page, so that's fine. I can click on the about page and it'll bring this for me. And then we have these guys. These are people. Can I click on any of these people? Oh, I can click on Olivia. Okay, cool. And then let's go and click on Jameson Wolf. Interesting. We can't scroll down. I guess you can, but it just has that bottom menu. And then what else? Let's click on all these people. I'm just going to click around this website real quick. Okay, so that's basically it. I feel like I've clicked on everything that is available to click on, and then all of these buttons basically take us to the same series of pages. And the most interesting one that popped out from the beginning was either the submitting of the ticket, which is under support, or the contact page, which is available here. And both of these are forms that we can submit data through. So now if I go over here and go under the target tab, we can see that we have a bunch of stuff under here, and especially for this IP address that we just clicked on. So if I open it, we can see that we have the about page, and under the about page we have these various people who were the individual team members. We have the assets page that pops up, and then we have the contact page that has this get contact information, right? So this is the contact information over here. And then we have the ticket page that also allows us to submit a ticket. So these are all interesting tabs for us, I think. So products, privacy, contact, assets, about, and then under assets, we have the JavaScript bootstrap bundle, email filter, and script, so on and so forth. And then there's the CSS, which has an error message for us. And then we have images under executives. These are basically all of the stuff that we have under our sitemap. And if we go to scope, we haven't added anything to scope. And under issue definitions, there's a bunch of stuff that's available, but I don't think any of these things have actually been detected. These are things that can be detected for what we have. So these are the various pages that we have noticed for our sitemap on this specific domain. So now let's go and see what the question is over here. So it says, what is the flag that you receive after visiting the unusual endpoint? So if we look at the list of the endpoints that we have over here, we have this first page, we have this random series of stuff. And then, I mean, I feel like this is like the most unusual looking one from what I remember. I think that's the only one. So what we want to do is we want to basically go to this /, which is the path right here. So I can just highlight this and I can copy it. And then we go to the browser and we can paste it at the end of our domain right here. And that'll be the path that we're going to visit. And we'll see what shows up. So press enter. There's a flag. There's an actual flag on this page, the THM yada yada yada. We highlight that, copy that, and then go over here, and that'll be the answer that we have over here under the flag that we received under that unusual endpoint. And that was it. So very, very easy to essentially create a sitemap for a website by just clicking around, visiting a site, and see what you can find. The Burp Suite browser is the next thing. It's a Chromium browser. That's what it was. That was the name I was trying to remember. It comes as a part of the Burp Suite software. So if you click on Open Browser in the Proxy tab, a Chromium window will pop up, and any requests made in this browser will go through the proxy. There are many settings related to the Burp browser in the project options and user option settings. Make sure that you explore and customize them as needed. If you're running on Burp Suite on Linux as the root user, as we are with the attack box, we may encounter an error preventing the burp from starting due to the inability to create a sandbox environment. So there are two simple solutions. We can either create a user and run Burp Suite on a low privileged account on the Burp browser, or we can go to Settings, Tools, Burp's browser, and check the Allow browser to run without a sandbox. Enabling this will allow you the browser to start without a sandbox. However, please be aware that this option is disabled by default for security reasons. If you choose to enable it, exercise caution, as compromising the browser would grant an attacker access to your entire machine. In the training environment of the attack box, this is unlikely, but it is, use it responsibly. I mean, I don't need to use it. So I mean, I'll just kind of show you what it would look like if I clicked on it. But we don't really need to use it because we basically have our browser connected to our proxy. So if we go to, I believe it is under proxy, and then we have the open browser button. So we click on the open browser button, it'll try to open it, but it says it doesn't support browser running with sandbox enabled. So we're going to go to settings, and then we're going to go to the browser, and then we're going to turn that off, or turn it on, I guess. So it was settings, tools, and Burp's browser. So tools and then Burp's browser. And then we have the button. Where's the button? So there we go. Allow Burp to run without a sandbox. Turn that on, and then close this off, and then open browser. And let's see if it'll actually open. There you go. That is the browser. And I mean, it's a browser. And everything that we do here will just be logged in our proxy under the targets. So we go over here, and this opens it up. Uninteresting headers, yada yada yada. And I can go back over here, and I can close this thing out, and then we can go back to Burp Suite. And if we go under target, we should see that we have a new thing that I think it's this one that just showed up. Maybe detect portal Firefox, potentially. Anyways, I don't want to get stuck on this thing and go down the rabbit hole. But we do know that it has a browser. If you don't want to configure your own Chrome browser, for example, or if you don't want to download Firefox, then what you can do is you can just allow Burp's browser to run without a sandbox, and just use the Burp Suite Chromium browser that comes pre-installed with Burp Suite. All right, let's talk about scoping and targeting. So as you saw, there was a lot of stuff that showed up under the list of these things right here. So this can get overwhelming very, very quickly. So this is where the scope and the target come in, and scoping as a concept just comes in. By setting a scope for the project, we can define what gets proxied and locked in Burp Suite, and we can restrict Burp Suite to target only the specific web application that we want to test. The easiest way to do this is by switching to the target tab, right-clicking on the target, and then selecting Add to Scope. And Burp will then prompt us to choose whether we want to stop logging anything that is not in scope. And in most cases, you want to say yes, because you just want to target that one IP address, right? So to check our scope, we can then switch to the scope settings within the target tab, and this will allow you to control the target by scope, including or excluding domain IPs. This section is powerful and worth spending time getting familiar with. Even if we disable logging for out-of-scope traffic, the proxy will still intercept everything. To prevent this, you need to go to the proxy settings subtab and select and URL is in the target scope from the intercept client request. So as one of the rules, we need to say and the URL should be in target scope so that it stops capturing everything that has to do with that. And then same thing for the response, and URL is in target scope so that it stops capturing any of the responses other than the URL that's actually in the target scope. So in this example, the target scope that they're talking about is the TryHackMe. So if they went to scope settings, you can see that their target scope is TryHackMe. So it would only show requests and responses that have to do with the TryHackMe domain name. And that's basically it. So enabling this option ensures that the proxy completely ignores any traffic that is not within that target scope, resulting in a cleaner traffic view in Burp Suite. So we're going to add this to the scope and change the proxy settings to only intercept traffic to in scope, and then see the difference between the amount of traffic getting caught by the proxy before and after limiting the scope. So we're going to go over here. We're going to take this guy. Let me just zoom in for you a little bit. We're going to right click on this one. We're going to add it to scope. And then it's going to say, hey, you've added this to scope. Answering yes will avoid accumulating data for out of scope items. And I say, yes, I do want to avoid everything else. And then now we're going to go to the scope itself. And then this is our target scope. So very good. We have that. So we're going to go to proxy now, go to proxy settings. And then under our listeners, we're going to go under the request option. And then we're going to say, and we want the URL to be in the target scope. And for the response, we also want the URL to be in target scope. And that's basically it. That's how you set that up. And now you only have the target that is only available for that specific thing. Now, we still have a good amount of resources that are available over here. So these things are still going to be over here unless I manually remove Gmail from here, right? So I can delete the host from here, and then it should no longer show up. But essentially, for the most part, unless you really need to, you don't need to do any of that stuff. And then everything that happens from now on is only going to be related to this specific target in the scope. And that's basically what we wanted anyways. So that's how you do it. That's how you create a target in your scope. You just right click on it, and then you say add to scope. And it'll say, are you sure? You say, yes, I don't want anything else to be added to my scope. And then you go into your proxy settings and you just make sure that the rules for your request and the rules for the response say that the URL is in the target scope. So you want whatever the rule was previously, and you want the URL to be in target scope, and you want the URL to be in target scope. And that's basically it. So now let's proxy HTTPS. Now in my particular case, because I'm using the attack box, it's already configured to solve this problem if that the problem that's been posed in this particular task. If you're not using the attack box, then it's probably a good idea to go through this. So I'm just going to keep going through go through it with you. When you intercept HTTP traffic, you may encounter an issue when navigating to sites that have TLS enabled. For example, when accessing a site like google.com, you may receive an error indicating that Port Swigger Certificate Authority is not authorized to secure the connection. And this happens because the browser does not trust the certificate presented by Burp Suite. So this is what you would usually see. And then you can click on Advanced and you can say Proceed anyways. And you would be able to do that for the most part. But this is kind of what happens when you have a certificate authority that is not trusted by Google because it's not on their list of trusted certificate authorities. So to overcome this, we can manually add Port Swigger to the browser's list of trusted certificate authorities. And then you would download the CA certificate. So with the Burp proxy activated, you would navigate to burp/cert. And then you will download a file called cacert.der. And then you would save this anywhere on your machine so that you can upload it later. And then you go to access Firefox certificate settings by going to About Preferences inside of Firefox. And then you press enter and it'll take you to the Firefox settings page. You can also just go from the menu that's in the top right of Firefox. But you could basically just go to About:preferences. And then search for certificates and click on the View Certificates button. This is what you would see over here. And then you would import that file that you just downloaded from the Port Swigger website, this file that you downloaded from the burp/cert, okay? Then once you've selected it, once you've imported it, you click set this button, trust this CA to identify websites. And then you click OK. And then by completing this, you've added the Port Swigger Certificate Authority certificate to your list of trusted certificate authorities. And now you should be able to actually access Google or anything that is requiring that specific certificate authority, like an HTTPS website. So any HTTPS website typically has that as an issue, that if they don't recognize your certificate authority, you need to actually add that certificate authority so you can go access that HTTPS website. Now, again, all of this has been done for me on the attack box that I'm using. So in the event that you're using your own computer and you want to do this, you would just go through these instructions. So you could just essentially just rewind this video and go back through those instructions, and you'd be able to do it. And that's pretty much it. That's how you access HTTPS websites. So let's go through our example attack here. All right, so as our example attack, here's what we're gonna do, okay? So we go to the example or this website that we have over here, and let me just make sure that intercept is turned off real quick, and it is turned off. Okay, excellent. So basically this is what we're trying to do, right? So there's something that can be done on a client, so which is our web browser, right? So we have the support ticket page right here. And then if I try to do anything inside of the support ticket that is XSS, so for example, an XSS script starts with the this little squiggly button. So you see, as soon as I put it, I forget what they're called. I just call it the less than symbol, but that's basically how things start. And then even if I try to do it over here, I think it'll also block it off over here. No, this actually will allow it. So this is basically what that looks like, right? So a script will start with this, and then you would put whatever your script is, and then it will be closed out with that script tag, right? So usually this is what a script looks like. It starts with a script tag and then it ends with a script tag. But if I try to do it inside the contact email, it automatically just deletes it because it's part of the filtering that they have on the client side. So I literally can't even type that if I wanted to, right? So what we're going to do is we're going to capture this request, and then from here we're going to modify it, and then we're going to include the script that we want to include, and then submit it, and then we'll be able to get to see that script run, okay? So first thing, what I'm gonna do is I'm gonna go ahead to my proxy here. I'm gonna turn intercept on, and it's gonna be great because we only have this website added to our scope. And now I'm just gonna do a, pentester at thm.com, and then we'll say this is the script, blah, blah, even though that's really not the script. And then we just submit the query. And now this is going to hang, right? It's not going to actually submit anything. It's not going to do anything. So now I can go to my Burp suite right here. And my lovely Burp suite has captured my request. Excellent. And it is on the ticket portion of the domain, and it's down here. And then I can go ahead and look at the email. You see, so email is pentester at thm.com, and this is Unicode. I think it's like base 64, something like that. So the %40 is the equivalent of the @ symbol. And then this is the message. So this is the script, blah, blah. So that's it, right? So what we're going to do is now we're going to add this script. So this piece right here, this is what we're going to add to our request that we captured. So we'll, the same way that we just did it right here, we will just go and in the email section, we're just going to paste the script, and then that's basically it. And then from here, you will, I think we're just going to forward the request, right? So let me just make sure that we've done it. If I submit the query, let me see what the next thing would be. Yeah, press the forward button to send the request, and you should find an alert box on the page showing that the alert has been done. So I'm going to go over here, and I'm just going to paste that little piece that we copied from the other page. And let me find the paste button. Where's the paste? There we go, paste. So there we go. So the script is now here, right? So now I have this full script that's available over here. And now I'm just going to go and click the forward button to be able to submit my request. And then so if we go over here, let's see if this actually works here. Boom, there we go. I had to click forward twice. And there it is. Successful XSS was actually submitted because we modified the request in the background, and now it actually printed that little alert. And all it was that it's just printing an alert onto the screen. That's what the XSS script does in this particular case. It's nothing crazy, but now you know that you can actually capture something and submit the XSS request or the XSS script, whatever it is, cross-site scripting, right? That's basically how you do it. as long as you know what the script is, as long as you know how to do cross-site scripting, if you know how to create JavaScript, then that's basically it. It's really that simple, right? So that was our successful exercise. Hopefully you were able to pull that off on your end. And you don't have access to this machine, unfortunately, because this is like a target machine that was designed just for this exercise for TryHackMe. So you can try to do it with your own domain name if you have one, or you can just sign up for TryHackMe. It's not very expensive. There's a discount link in the description below that makes it even cheaper. I think they give you $5 off, so it'll be like $7 a month or something like that. So that was basically it. Like, really easy to do, right? Pretty awesome little exercise. All right, so that was it. So in conclusion, congratulations on completing the Burp Suite basics. You now have a solid understanding of what it actually is. This is literally just scratching the surface, okay? So I don't want you to think, I mean, you already saw how many different things that there are that you can do. So this is not even remotely close to the total of what you can do with Burp Suite. But that was a nice little like introduction, I think. That was like a nice little introductory course to Burp Suite and just setting it up, and then getting just some of your basic settings, like for example your proxy and all of that, getting ready to go. So I hope you learned from this video. I think if you've never used Burp Suite before, I think this is a perfect way to see what it actually is and the potential of what you can do. And you just saw it with that practical exercise that we ran with that script, that JavaScript. So that was pretty cool, and I hope you got some really fun value out of it. If you did indeed get value out of this video, I will encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, especially in the CySec 101 playlist that we got going on. And I do have Network Plus that's going to be coming up in the next week or two. So that's going to be another really strong training series that's going to come in. We have Linux Plus that's already on here. I do have Security Plus that recently was just uploaded as well. So I do bring like really big training series that are available, and then we do a bunch of stuff on TryHackMe, and then there's going to be an AI course that's right around the corner as well. I just wanted to make sure that we got Network Plus for everybody, because networking is very, very important. As you just saw, like everything that we were just doing in those web requests, that's technically a part of networking. So all of that stuff is super, super important. So definitely make sure that you like, subscribe, and turn on notification bell. Drop a comment if you have any questions. If you want anything to be clarified, if you just want to say hi, if you just want to say thanks, definitely make sure you drop a comment. And you can also say thanks by supporting this channel and joining Hackaholics Anonymous, which is the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master, and each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord servers. If not, I hope at the very least I see you in the comment section, and that's it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video later. In episode 34 of the CySec 101 training series, we're going to go through OWASP Top 10, which is a very powerful list or a standard for web application testing. And this is a part of the web hacking module that is a part of the Cybersecurity 101 pathway of TryHackMe. And as a part of this video today, as a part of this training series, we're going to be going through the top 10 list as far as the description of the challenges themselves are concerned. And this is a little bit of an older room that is in TryHackMe, because this is actually the 2021 list, and they actually just created, or I think they're wrapping up the 2024 version of the OWASP Top 10. So we're going based on the most recent finalized published version, which is the 2021. And as a part of that list, we're going to look at them from the top. So for looking at the very first vulnerability, the open web application standard, we're going to be looking at the broken access control, and then we're going to do an exercise for it. Then we're going to do cryptographic failures and do a couple of exercises. Then we're going to do injection, insecure design, security misconfiguration, vulnerable and outdated components, and then identification, authentication, software and data integrity failures, security logging and monitoring failures, and then server-side request forgery. And for all of these things, there's going to be, or at least for most of them, there's going to be a practical exercise that we're going to run with the virtual machine that we've been assigned. And this is actually a free room that's available on TryHackMe. So anybody, as long as you have a free account with TryHackMe, you can go ahead and run the virtual machines, run the attack box, and then do all of the exercises that we're going to end up doing inside of this training video. So hopefully you have your membership of TryHackMe. If you don't, this would be the perfect time to go ahead and get it. And that way you can run across the rest of these exercises and the rest of this video with me. If you'd like to support this channel, consider joining Hackaholics Anonymous, the premier YouTube community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server and early access to content. The agent, guardian, and master levels, however, get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the OWASP Top 10 room. Okay, so the OWASP Top 10 is the Open Web Application Security Project, which is a nonprofit foundation focused on understanding web tech and exploitations, and provides resources and tools that are designed to improve the security of software applications. And they come out with a top 10 list for, I would say, maybe every 3 years, something like that. So the one before the 2021 version was 2017. So every 4 years, I guess, because now we have the finalized version that's coming out sometime in 2025, it seems, because as I'm recording this video, it is already 2025. So if we actually look at the OWASP Top 10 on their official website, it is giving us the OWASP Top 10 2025. The current status as of September 2024 is that they're planning on releasing it in 2025, in the first half of 2025. And then the version that we see on their website is still the 2021 version. So it does seem like it's going every 4 years, and the most recent version, which is the 2025 version, has not been released. I feel very confident that when it does get released, TryHackMe is actually going to put out a training room and a training series just for that. So as soon as that comes out, we'll just have an updated version of this video for you. But for now, for people who are studying cybersecurity and they're inside of the CySec 101 playlist and following along with this training series that we got, this is the most recent version, which is going to be broken access control, cryptographic failures, injection and secure design, security misconfiguration, vulnerable outdated components, identification, authentication failures, software and data integrity failures, security logging and monitoring, and server-side request forgery. I know I already announced that, but just in case, just wanted to go over it at least one more time with you. And that's basically what we're going to be doing. And it's been designed for beginners. So this room and this video is for beginners, but we're actually going to be doing some pretty cool exercises that even as a beginner, as a complete greenie, you're going to get a lot of value out of. So I'm actually really excited about this video. I've already launched the virtual machine, and all you have to do when you join this room, because again, this is a free room on TryHackMe, you click this button. This is originally a green button, this shade of green right here. You would click that and it would start your victim machine for you. And then you got to go up here, and there's a button up here for start attack box. So right now, so let me actually, if I exit split view, right here where it says show split view, this originally says start attack box. And then once you've started the attack box, it turns into show split view. And then when you click on that, it'll actually open up the attack box for you. Usually when you click start attack box, this split view automatically opens up anyway, so you don't have to worry about it. And I'm just going to give it a couple of seconds because I feel like it's taking a little bit of time for this thing to load right here. But for the most part, we have our victim machine that's up, and we have our attack box that's up. So let's talk about the first vulnerability inside of the OWASP Top 10, which is the broken access control. in order to understand broken access control, we need to first understand what access control is. And we can generalize it into two main categories. You have privileged users or administrators, and then we have regular users. And the visitor of a website could also be considered a regular user. And so for somebody to be able to access a website, they would need to have one of those two sets of credentials. Now, what happens is when somebody who is not an administrator, when somebody who's a regular user gets to access the privileged data, that would be considered broken access control, meaning the stuff that they should not be able to see, they are now getting to see, and it's because their access, the control that is assigned to their access level is broken. So that's what broken access control really means. So only the site admin user should be able to access a page to manage other users. As an example, if a visitor can access protected pages that they're not meant to see, then the access controls are broken. So a regular visitor being able to access protected pages can lead to being able to view sensitive information of other users, accessing unauthorized functionality, doing things that they shouldn't be able to do. So simply put, broken access control allows attackers to bypass authorization. And this is a part of authentication and authorization frameworks and modules, and then this falls under the IAM, Identity and Access Management. So there's a lot of stuff that essentially covers this specific vulnerability, but it's a really big one, which is why this was listed as the #1 vulnerability in 2021, because if people can get access to pages or to assets or to resources that they shouldn't have permission to access, that's a really, really big deal. So a vulnerability was found in 2019 where an attacker could get any single frame from a YouTube video that was marked as private, and the researcher who found the vulnerability showed that he could ask for several frames and somewhat reconstruct the video, since the expectation from a user when making a video as private would be that nobody has access to it. This was indeed accepted as a broken access control vulnerability, and this was as recent as 2019, which is, I guess it's not that recent. Time is kind of flying by, so it is technically 6 years ago, but it is against a company that's massive like YouTube. So it's not a small company. It's literally a company that's bordering, I mean, it's definitely in the tens of billions, if not hundreds of billions of dollars. So it's a massive, massive company, and it belongs to a massive company like Alphabet. So you would kind of expect that they would have their security in order, but they don't, right? So that was the example that we have for broken access control. Now let's look at the actual exercise here. We actually have a challenge called the EDOR challenge. Now, the EDOR challenge is, EDOR stands for Insecure Direct Object Reference, and we have a direct object that is, in this particular case, let's say ID number, 111111, right? That's technically the object that we are referencing inside of this specific website, or a direct object that we're referencing. So when you have an insecure reference, means that if I change this ID number to 11111112 or 111112 or whatever, any other ID number, and I get access to that ID, that means that I now have access control that I should not have, right? So if this is my bank account number, for example, and I'm able to if I'm able to access my own bank account information, that's great. But if I can access somebody else's bank account, that becomes a really big issue. And now I can transfer money out of that person's account into my own account, right? I could do a lot of things that I shouldn't be able to do with somebody else's bank account number. So this occurs when the programmer exposes a direct object reference, which is just an identifier that refers to specific objects within the server. By object, we could mean a file, a user, a bank account in a banking application, or anything really. So this is the example that I just gave you right here. So potentially a huge problem, because if I can change the ID parameter to like my own bank account number, or not even that, somebody else's bank account number, and then transfer from this account number to my own account number, then that is a big broken access control vulnerability. So the application exposes a direct object reference through the ID parameter in the URL, which points to a specific account. Since the application isn't checking if the logged in user owns the referenced account, an attacker can get sensitive information or transfer money, which is the big piece right there. So notice that the direct object references aren't the problem, but rather the application doesn't validate if the logged in user should have access to the requested account. So we are going going to read and understand how this works, and now we're going to deploy the machine and go to this specific website, log in with that username, and then do some other things that we shouldn't be able to do. That is the whole purpose of the eDoor. So let me just open my browser and I'll go to this website, and then we will look at all of the user notes to be able to find this flag that we have at the bottom right here. Okay, so this is our website, okay? And as soon as we log in, we get a note basically that is like it's a shopping list. It's actually a shopping list. It's not like a shopping list. So the vulnerability is up here, right? And the question is asking us to go through all the notes, and then what is the flag, right? So we're basically supposed to go through the rest of the user notes that are available here. So I can start from user 0, I want to say. So I can technically go to ID 0, and then from there see what we can get for ID 0. And this is very slow to respond right now. I think it's because it is a free room, that maybe there are a lot of people that are using it, or maybe they didn't give us the fastest virtual machines that they have, because technically it is a free room. So it could also be because I'm recording and I may be down to like fumes when it comes down to the battery on my computer. Oh, flag 0 actually is the flag, or ID 0 is the flag that we have over here. So that one was actually kind of quick, thankfully, because this thing really is slow. But technically I could actually, so I started as ID 1, I just looked at ID 0, I can go to ID 2, press enter, and I can also see the notes for ID 2, and then you can just keep going, right? And this is where the eDoor vulnerability typically exists, and it could be something like a ID parameter, or it could be any other parameter that you can modify that you shouldn't be able to modify, and then get access to notes that you shouldn't have access. So you're not supposed to see this node, which means you're on the right track, right? So this is what we were doing. So the answer was at ID 0. That's basically where the flag lies, and then when you get that flag, this would be the answer, 543. So that was the flag that we got for the exercise that we are running inside of the Broken Access Control Challenge. So now let's look at cryptographic failures. So we did a series of videos already on the CySec 101 playlist that has to do with cryptography and encryption in general. There was the cryptography 101 and everything else that came after that. I think there's like a total of 3 videos that we did on CySec 101 playlist that has to do with cryptographics, encryption, cryptography. And a cryptographic failure is basically any vulnerability that has a misuse or a lack of use of cryptographic algorithms for protecting sensitive information. So either it was a bad algorithm, like an old algorithm that is easily decrypted, or there was no algorithm. And that is probably like the biggest thing, right? So for example, if we have an email application and you're accessing your email account using the browser, you want to be sure that the communication between you and the server are encrypted. That way, any eavesdropper trying to capture your network packets won't be able to recover the content of your email addresses. When we encrypt the network traffic between the client and the server, we usually refer to this as encrypting data that is in transit. And then since emails are stored in some kind of server that's managed by a provider, it's also desirable that the email provider can read the client's emails, and encrypting that is called encrypting data that is at rest. So when data is being transferred back and forth, and it could literally be the email that's also flying through the ether to actually get to whoever the recipient is, that could be data in transit. It could be data that as you're logged into your email, you're looking at the data that's being passed back and forth. As soon as you receive an email, that's technically data that's being transferred to you live from the server to your client, which is your computer, your web browser. So when you're looking at data in that regard, that is data that's in transit. It's going back and forth. And then you're looking at data that's sitting on your computer, or it could be sitting on a server somewhere. Nobody's accessing it yet. But even though it's not being accessed, it doesn't mean that we don't want it to be secured, right? So that would be encrypting data that is at rest. Now, cryptographic failures often end up in web applications accidentally divulging sensitive data. And this often directly links to customers, like the names, date of birth, financial information, but it could also be more technical information like the usernames and passwords. And at more complex levels, taking advantage of some cryptographic failure often involves techniques like man-in-the-middle attacks, where somebody's literally sitting in the middle of the transit, the data that's going back and forth. They're just watching all that data that's transferring, and they're the one in the middle, and they can capture everything and either modify it or just steal the data. they would force user connections through a device that they control. Then they would take advantage of weak encryption on any transmitted data to access the intercepted communication or information if the data is even encrypted in the first place, assuming that it's not plain text. So of course, many examples are much simpler, like vulnerabilities that can be found in web applications that can be exploited without advanced networking knowledge. Indeed, in some cases, the sensitive data can be found directly on the web server itself, and the web application in this box contains such vulnerability, and we're about to exploit it, which is the cryptographic failure exercises that we are about to run through. Supporting material number 1 talks about the most common way to store a large amount of data that is in a format that is easily accessible from many locations and that's called a database. And it's perfect for something like a web application because there are a lot of users that interact with it, and they usually follow SQL, which is the structured query language syntax. And we also did a video on SQL in the CySec 101 series, and it's a good one. It's actually a strong one, and we do a lot of exercises that are very useful. So I would recommend you watch that if you haven't seen the SQL video. It is in the CySec 101 series, and you can find the title SQL Basics. So in a production environment, it is common to see databases set up on dedicated servers running a database service like MySQL or MariaDB. However, databases can also be stored as files, and they're referred to as a flat file database as they are stored in a single file on the computer. And this is much easier than setting up an entire database server and could potentially be seen in smaller web applications. Accessing a database server is out of the scope of today's task, but again, you can go ahead and go to the SQL Basics video in CySec 101 playlist, and you'll be able to go through all of those exercises. And it is a good in-depth exercise, even for beginners. I think it's really, really fun. As mentioned previously, flat file databases are stored as a file on a disk on a computer. This would not be a problem for a web app, but what happens if the database is stored underneath the root directory of the website, which means of the files that are accessible using connecting to the website, and we can download and query it on our own machine with full access to everything in the database, and that is definitely sensitive data exposure. So that is not good. And it's a big hint for the challenge that we're going through. So let's cover what the syntax would be to query a flat file database. The most common and simplest of the flat file database is the SQLite database, and it can be interacted with in most programming languages and have a dedicated client called the SQLite. And this one we're running SQLite 3. It's installed on many Linux distributions by default. So if you run ls, which is the list command, and I'm not going to go through the basics of the Linux command line, so we're just going to run ls as an L just to see what is available and what the permissions are, and that would be the example.db file. And if we look at the file of the file type of that, it's going to say that it's a SQLite 3 file. Now, if we actually do SQLite 3 and then do example DB, what's going to happen is that it's going to open up example DB using SQLite, and then we'll be able to actually pull the tables, for example, that are inside of the example DB. And then we see that we have a customers table, and then you can do pragma and then do the table info customers to actually get the columns of the table customers. And you'll see the column 0, which is the first one, is the customer ID, I believe. And then we have customer name, credit card information, and password. And then you want to select everything from that table, and you're going to get the ID of each customer. You're going to get their name, their freaking credit card information, and of course their password hash. So we're not getting the plain text version of the password, which is nice, I guess. But we are absolutely getting their freaking credit card, which is crazy. So the first one would be Joy Paulson, right? And this is what her data shows us. So in the next task, we're going to actually look at cracking the hash that's available for Joy Paulson, and there's a lot of really freakishly easy ways to crack a hash, which is it just goes out to the cryptographic issue right there. So this one is going to be done with CrackStation, which is my favorite tool for doing it because it's a free website and it's super easy to use, as you'll see. And we did also cover this when we went through the cryptography video. So when it comes to hash cracking, Kali Linux comes pre-installed with a lot of various tools, and it's because Kali Linux is designed for penetration testing. So there's John the Ripper, there's Hydra, there's a lot of different tools that are available on Kali Linux that you can use to crack password hashes. Now, let's say you don't have Kali Linux, but you found for whatever reason a list of password hashes. You can go to this little website right here, which is called CrackStation, and it is you literally just paste the hash in here, click I'm not a robot, and crack hashes. And as long as it's one of these hashing algorithms that we have down here, so it's the LM, NTLM, MD2, 4, 5 hex, MD half, or MD5 half, and then we have the SHA series, and it goes up to SHA 512. Now, the thing that we need to understand with password hashes is that you're not decrypting a hash. You can't dehash a hash. But what's going on is that there is something called a rainbow table. And a rainbow table, is a glorified spreadsheet, basically, that for each hash, okay, there's a plain text value that is stored on that row for that hash. And so when you pull these hashes up over here, it's not decrypting anything for you. It's just looking at this massive database that's stored on a spreadsheet, and it's saying, oh, we do have the value for this particular hash, and then it'll give us this hash. So this is where it comes down to, you want to have really secure passwords, because if you have a secure plain text password, like a really long, download CrackStation's word list, right? This could be the password file, or the password itself. And then if that's your actual plain text password, when the SHA-256 hash value is created, that won't be on anybody's password list because it's a complicated password. It's a long password. It doesn't count as an easy password. Therefore, it's not going to be stored inside of a password list like what CrackStation has over here. So again, we can't dehash or decrypt hash values, but we can check a massive database or use a dictionary or something like that. And from there, and I'm not referencing a regular dictionary, I'm talking about the dictionary that we would use with a tool like Hydra or John the Ripper to actually crack a password hash. And then when we do that, you're looking at just a massive database or a massive dictionary password list, and then comparing what you already have against that to see if you can hash it or dehash it, So if we look at this one, this would actually be something that does exist most likely inside of their database. And if we do it, it'll say, yep, we have it. And that is, of course, it's like a default password in a lot of systems, which is the word password, all in lowercase, no special characters. And this specific hash type is an MD5 hash type, which is one of the older hash types. And it's not, for example, comparing it to SHA-256, which is a 256-bit. This is, I believe, a 32-bit, meaning it's 32 characters long. And again, I'm not going to go deep into the explanation of hashes because you could literally just go and look at the cryptography videos that we have, and then you can do a deep dive into hashing. So we're not going to go too crazy with that right now. It's good to know that cryptographic failures is actually one of the OWASP top 10 list. And then from there, if you actually find a list of password hashes, you can write a very simple script that says, hey, I want you to run every single password hash in this thing against a database like CrackStation's word list. And then from there, just see which one you actually find the plain text value for me. So pretty insane. Now we can actually do the challenge of going to this website and then getting the password hashes. All right, so the first question or the premise, it says, have a look around the webpage. The developer has left themselves a note indicating that there is sensitive data in a specific directory. So if we look at the webpage, there's really nothing clickable on this webpage other than, I think, just the picture itself. And maybe it's not loading for me. I'm going to open this up in a full screen mode just so we can see what we can actually see here. And hopefully this will be a little bit easier for us to manage. So again, this is kind of slow. So I'm going to give it a second to load. And then, oh, there we go. It actually loaded, but it's not fully loaded. So let's see how quickly it'll respond if we are in full screen mode. Okay, so there were literally only two clickable elements on this web page. One of them is the contact us element, which is on the home page, and that just opens up the email application and has you try to email whatever their contact email is, and then which is right here. It's the please contact us here, and when you click on that, it opens up the email application. And then the other one is the login page that's in the corner right here. So when we click that, it actually just takes us to a login page. And then if we right click on the page and then look at the source code, right? So if I go and click on that view source code, it'll open up the actual source code of the website for me. And then right on the source code, there's a comment that's been left by the web developer right in the middle of the page where it says, must remember to do something better with the database, then store it in assets. So /assets is the path for where the database itself is stored. So now we can go look at what is inside of that directory. All right, so when we go to the assets page, so it's basically the IP address. I had to refresh, so it's a different IP address, but it's still on port 81 and then /assets. When we go to that, we get this little gem right here. And then so we have the webapp.db, which is our database file. We have the JS, images, fonts, CSS, and of course the parent directory. And the parent directory brings us here. And then the assets page, CSS, will take us to the CSS style sheets. The fonts will bring us to the fonts, of course. Images will bring us to the images, the 2 images that are there. And JavaScript will take us to the JavaScripts, the console script, and the jQuery mini. And then of course we have the web app database, which is a file that downloads. So I just downloaded that file. So we have taken care of the top 2 questions, which is what is the name of the mentioned directory, and navigate to the directory, and which file stands out, which is the web app database. So it says use the supporting material to access the sensitive data. What is the password hash of the admin user? So let's go ahead and actually access that downloaded file. I'm just gonna go click on that downloads button, and then when I click on this little folder, it opens up the downloads, and then we have that. So let's go and we will do this. So we're going to use the terminal, and then we're going to go to the downloads folder here. And essentially what's going to happen is we're going to use SQLite. I want to say it's SQLite 3. SQLite 3 maybe. And then let me actually go to the downloads folder first, so we are not there right now. Oh no, it's actually in the desktop. So we'll do SQLite 3, and then we will do webapp.db. And there we go. And if we do, I think it was .tables, sessions, and users. So we want to get the data for the users, and it was pragma. Let me make sure I get into caps lock. So it was pragma, and then it was, what was the command? So let me get the command one more time here. Table info customers, that's what it is. So pragma table info, and then we want users, and then we would do you got to do a semicolon at the end of every SQL query, essentially. So we have, all right, so we have the user ID, username, password, so on and so forth. And then so what we're going to do is we're going to select everything from users, and then we'll do a semicolon, and then press enter. And then so this is what we got. So we got the user ID, which is going to be, what is it? It's this thing, I guess. That's their user ID, which is insane if you think about it. And then we have the password. No, so user ID, yeah, user ID, username right here, and then password, and then admin. So whether or not they are an admin, I would assume that's what this last piece is. So if it's a 1, that means it's true. If it's a 0, that means it's false. So you know, these guys are both admin, and then the actual admin user, their password hash is in position 2, or technically position 3, because position 0 would be the first one, which is everything here, and then we have the actual username, and then we have admin's password hash. So that is admin's password hash. So we would copy that, and then we would go to our question right there. So that's the password hash. And then what is the admin's plain text password? So we would then take that hash, and we would go to crack station, crack the hash, and then it is QWERTY UIOP. So if you have your fingers on your home buttons on your keyboard, so your left index would be on F. So if you just go to the top row and you put your pinky on Q, you would just do QUERTY and then UIOP. Literally every letter that's in the top row, that's his password. That's the admin's password. Goodness gracious. Okay, so there we go. And then we got the crack the hash of the admin, which is QWERTY. So login as admin, what is the flag? So now we have the admin's password. So what we're going to do is we're just going to go to the home page. And let me actually just do that. I'll just do this. We'll go to assets and then we'll just go to login. Or is it not login? I thought it was login. So if I press enter and actually go to the login page. All right, let's just go to the full screen, click login. Oh, it's login.php. That's what it is. So we're going to do admin and then we'll do QUERTYUIOP, enter. And there we go. We are officially logged in as the admin and there is the flag on the home page, baby. You just highlight that, copy paste, and you are good. So we got the answers for our section for cryptographic failures challenge. Very good. So now let's go to injection. So injection flaws happen when there is a form that you can fill out on a page. So for example, a login form or a support form, anything like that. And it happens because the application interprets the user's input as a command or a parameter, and they depend on what technologies are used and how they interpret the input. And if you don't sanitize the input, which means somebody inputs it, and there's two ways to do it, to actually not even let them do the input. And so we did one on the I want to say it was the SQL injection room that we did. Let me see, it's inside the path for web hacking. I think it was in JavaScript. It was JavaScript Essentials, I believe. It was JavaScript Essentials where we did some pen testing with doing the SQL scripts. Not SQL, sorry. We did JavaScript scripts and we put them inside of a support form on a website. And then when you do it, it automatically removes, or it wasn't even, I think it was actually the Burp Suite room. It was definitely the Burp Suite room, because then we used Burp Suite to manipulate the input of that form, because the form wasn't allowing us to actually put scripts inside of the form. It was automatically deleting anything I would type that would be interpreted as a potential script. So because of that, we had to capture it in Burp Suite proxy, and then we changed it inside of the back end of it, and then we forwarded it. So that's what we did. So that's one way of sanitization, where it automatically, as you type it into the form, it just deletes everything. The other sanitization is when you type it and then you press enter, as the server is processing it, it doesn't allow you to submit that information. It just it cleans the input and then it says the incorrect input or whatever. So injection happens when you put malicious input inside of a form, essentially, or inside of the link at the top of the browser. So SQL injection occurs when the user controlled input is passed to SQL queries. As a result, an attacker can pass in queries to manipulate the outcome of such queries, and this could potentially allow the attacker to access, modify, and delete information in a database when the input is passed into database queries. This would mean that an attacker could steal sensitive information like personal details and credentials, which what we did with the file that we just downloaded, right? The database file. But we would do it through using actual SQL commands, which is basically what we did on our terminal. So it would be these types of commands where you pass in the, things like select everything from users. This piece right here, that's basically an SQL command. So if you were able to do an SQL injection attack, you're essentially passing that request or passing that query into the form or into the URL, and then it would process it for you. The other one would be command injection, and this occurs when the user passes system commands into the system and it actually processes it. As a result, an attacker can execute arbitrary system commands on application servers, potentially allowing them to access user systems. The main defense for preventing injection attacks would be to ensure that user-controlled input is not interpreted as queries or commands, otherwise known as sanitization. And using an allow list is very important. So when input is sent to the server, this input is compared to a list of safe inputs or characters. And if the input is marked safe, then it's processed. Otherwise, it's rejected. And then you have stripping input. If the input contains dangerous characters, these are removed before processing. And that's what happened when we were doing the exercise with Burp Suite. When I would try to enter it into the form, it would just strip it before it would even process it. And then I had to capture the session using Burp Proxy and then modify the input on Burp Proxy before I forwarded it, and that was the way that we were able to submit the injection attack. So dangerous characters or input is classified as any input that can change how the underlying data is processed. Instead of manually constructing allowed lists or stripping input, various libraries exist that can perform these actions for you. So let's talk about command injection part 2 technically. So as a continuation of injection, when we go into actual command injection, this is when we send server-side code like PHP in a web application, and then it makes a call to a function that interacts with the server's console directly. An injection web vulnerability allows an attacker to take advantage of that call to execute operating system commands arbitrarily on the server, and the possibilities for the attacker are endless. So they could list files, they could read contents of those files, they could run basic commands to do some recon on the server, or if you wanted to upload a shell file, for example, you could do like a PHP shell file that you can get a reverse shell to that server. And it's as if you're literally sitting in front of the server and issuing commands directly to the command line. Once you have a foothold on the web server, on the web server, we can start usual enumeration of the system and look for ways to pivot around and escalate our privileges or download exfiltrate files, do a number of things that could be very, very harmful to the website, to the company. So let's consider this scenario. We have MooCorp that has developed a web-based application for cow ASCII art with customizable text. While searching for ways to implement their app, they've come across the cow say command in Linux, which does exactly that. Instead of coding a whole web application and the logic required to make cows talk in ASCII, they decide to write some simple code that calls the cow say command from the operating system's console and then sends it back to the content. So if we look at the code, this is what the code that they used for their application. So let's see if we can determine why the implementation is vulnerable to command injection. So this is the code, okay? So if the mooing is set and it actually gives us the get of the mooing variable will get mooing, and then cow is set to default. So we have two variables here essentially. We have the mooing variable and then we have the cow variable. And if it is set, if the mooing variable is set, then it will execute the various commands. So I feel like I'm butchering this because I'm not masterful at PHP. So what I'm going to do is I'm going to feed this because I really do want to give you an explanation. Or actually, no, we have the explanation down here. I don't even need to go ahead and do that. So it will explain it to us in plain terms way better than I did. So if the parameter mooing is set, so first thing, that's what it does. This piece right here, if it's set, if the parameter mooing is set, if it is, the variable mooing gets what was passed into the input field, okay? So pass through, and then we're going to pass the two variables that we have, the cow and mooing variables. Checking if the parameter cow is set. If it is, the variable cow gets what was passed through the parameter, and then the program then executes the function pass through, and then the pass-through function simply executes a command in the operating system's console and sends the output back to the user's browser. You can see that the command is formed by concatenating the cow and mooing variables at the end of it. Since we can manipulate those variables, we can try injecting additional commands by using simple tricks. If you want to, you can read the docs on pass-through on PHP's website for more information on the function itself. So this is what it looks like. So if you have your default that is set, so this is what the full command would be, right? So if we have the Perl user bin cow say, which is the binary that's for cow say, that's going to execute this command, right? And the default cow, which would be the cow variable, is going to be the first part of the variable that we see right here, right? So that would be this variable. And then we have the mooing command, which is what we actually type over here. And then when you click submit, the cow is going to say TryHackMe because the default cow is going to say whatever we type over here. So if that's the case, then we can try to feed another command into it to see if we can get any other data. So for example, if we echo my username is who am I, then it would say my username is John Doe, right? So that's what the who am I command essentially does. It gives you the username of the actual person. So let me zoom in here a little bit. So on this attack box, right, the John Doe, the J Doe user is the person that's here. So if you actually put in the who am I command without putting it inside of this echo command or inside of this string, if you just do who am I, it's just going to give you the actual username, right? So that's how echo works. So if we execute who am I, it gives us John Doe. If we parse the result back in the outer command, then it would say execute echo. So instead of executing just who am I by itself, it's going to execute echo and it's going to say my name is John Doe, right? So that's basically what this command is doing for us. So coming back to the cow say, if we actually use the default cow again, and then we just put the variable in here, we say $, and then inside the parentheses, we would say who am I, it would actually execute the command. And then it would say, hey, you are Apache. That's basically what it would give as a response, right? It just gives us the output of whatever this command is right here, which is the basic who am I command. So that's how we can enumerate data from a system that is using the cowsay binary. So since the application accepts any input from us, we can inject an inline command which will get executed and used as a parameter, and this can make whatever we want returned by the cow, basically. So we can run a bunch of other commands that are very useful. So who am I, the ID of the user, ifconfig or IP address, that would actually give you the IP address of the machine that you're logged in on, uname, which would give you your host name, and then ps, which would give you all of the processes that are running. So now what we're going to do is we're actually going to run these things, and we're going to do it on port 82 of the web server that we have over here. So we're just going to go literally right there and just change that to 82, press enter, and it will take us to cowsay online. And then I have these various cows that we got over here, which is very, very interesting. And I want to try to see if we can use like other cows or other, instead of default, we could use the other ones. So let's see. What strange text file is in the website's root directory? So we will go here. First and foremost, we need to get our actual current directory. So we're going to say print working directory, and then we're going to submit it. And then the cow is going to say that you are inside of the htdocs directory. So what I want is to list what is inside of the root directory, essentially. So we need to go up one level. So what we're going to do, we could do it a couple of ways. So we could actually do, I'm going to try this one first. So we're going to do the ... and then we're going to do ls. I want to say it's ... /ls. I think that might be the command. Let me see if I don't know if I did it right. I did not do it right. So first let's do this then. So we will just do ... and press enter. Let's see if that works. And it just prints ... So I need to get the, or maybe I can actually, instead of doing that, I can just do change directory, and then I will do ... like that, and it will run it, and then hopefully it will change the directory. And then if I run pwd now, it should give me the root directory. No, I'm still in htdocs. Okay, so let's see here. Let's see what we can do here. Okay, there we go. So the command itself was actually, we were going to put it inside the variable, and I did I did ls, and then I did /, which represents the root directory, and then I closed it off in a parentheses. So that's going to list everything inside of the root directory, and now we have everything. So we have the binaries, we have cows, dev, docker entry point, shell, all these different things that are inside of it. So what was the question? It says, what's the strange text file inside of this? So do we have a strange text file inside of this? Okay, so I mean, I don't see the text file over here. Maybe this is the root directory that they're referring to. So let's change this to root, and let's see if we can get that. It doesn't show me. So what is the root directory they're referring to? That's so annoying. Okay, well, that's pretty annoying, because I know for a fact that when you do something like this, right, if I run print working directory, this is not the root directory. This is the root directory. Okay, so that is what is very, very annoying for me, because now I literally, all we have to do is just do ls in our current directory, which is the hdoc or hsdoc, whatever it was, and that's the text file that they're talking about, the Dr. Pepper text file. That's very annoying, and that's literally not the website's root directory, but whatever. Okay, so the strange text file is inside of the current directory as we're in it, which can be established by just running ls on the current, like literally as you go into it, this is what shows up, and that would be the text file. Okay, so fine. How many non-root or non-service, non-daemon users are there? So we need to find the list of all of the users that we can find that are non-root, non-daemon, or non-service users. So we need to list all of the non-root, non-daemon service users. Okay, so basically all of the users are listed inside of the etc password file. So what we need to do is we need to run the command that would concatenate the contents of the etc password file for us, and then press enter, and then we're going to get a list of all the users. And so we want the non-root, non-daemon. So basically, if you look at, let me see if I'm at the bottom of this thing. If we look at the very bottom of the users list, is when any other users that are non-root, non-daemon, non-system users would be created. So these are all either system or root or daemon. So we have, like, at the very, very top, we actually have root, and then we have binary, daemon, like all of these users are actually root or daemon or system. And it's basically the very first entry right before the :x:. So that would be the user, and then new line, and then user. So the answer would be 0, right? So if we look at the contents of the etc password file, the answer is 0. What user is this app running as? And to find that, we would just run our who am I. So that's what it was. So we'll just go right here. We'll do who am I, run that. And then it says we are running as Apache. So that one's pretty easy. What is the user's shell set as? So if we go, there's a few ways that you can find that. The entry that we were looking for, again, it's inside of the etc password file. So if we do cat etc password, it would give us all of that information. So we're just looking for the Apache user, so we can see what our shell is set as. There's also a way that I know that you can, like, pull the so all the way down here, you can pull the entry for Apache. I forget how to do it. I don't want to digress. My shell, it's not over here. So let me actually, so yeah, I need to find out and how to do it anyway. So let's find out what our shell is. Okay, so upon further research, this is actually the shell. And I had no idea that that was the name for a shell, the S system binary no login. Usually it's like binary shell or something along those lines, or binary ZSH, binary bash, something like that. So I've never actually seen something like this, and I did not realize that this was actually the entry for our shell. And the way that we can, at least I learned this part, that we can do this. So we can do cat of the etc password file. Come on, etc password. And then we can pipe that into a grep command and search for Apache like that. And I just got to make sure that I put that $sign at the beginning, and then run that. And then this will just give me the Apache entry. And so it is in the etc password file. And that's what I thought it was. And so this is I believe this would be like the directory that's assigned to this user. And then the actual last segment of it is the location of the bash. So sbin no login is actually the location of our bash. Now we want to know what version of Alpine Linux it is running, and we do that with uname a, and it'll give us everything that there is to know about our system. So if we do uname -a and then press enter, and of course it has to be inside the $sign. So let me show you the command. It didn't save it. Uname a, like that. So that's the full command. So this is the full thing right here. And so we have Linux 5.4.0, AWS, Ubuntu, da 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 da. So what we're looking for is what version of Alpine Linux is running. And so that would be the, do we have it? It's not here. So it's not uname. That's interesting. I thought this was the command. Now I'm just losing my mind here. So what's the command that would pull up our version? I think it's like sysinfo. There's a few different things that we can run to see what the version of our Alpine Linux is, but I've literally always thought that it was the uname. So let's see what hint gives us. It can be found in etc Alpine release. So we could just do this then. I can just copy this and I can go here and I can do this. So let's try this out. There you go. That's it. All we needed to do was concatenate the contents of that, which is cat, so $. Just assume that everything is inside the parentheses and a preceding $. And then so we have cat, and then we have etc Alpine release, and I just press enter, and then it gives us the version 3.16.0. So that was it. All right, moving on to insecure design. This refers to vulnerabilities which are inherent in the application's architecture. They're not vulnerabilities regarding bad implementations or configurations, but the idea behind the whole application or part of it is flawed from the start, as the name implies. It's insecure design. Most of the time, they occur when an improper threat modeling is made during the planning phase of the application and propagate all the way to the final app. Some of the times, insecure design vulnerabilities may also be introduced by developers while adding some shortcuts around the code to make their testing easier. A developer could, for example, disable one-time password validation in the development phase to quickly test the rest of the app without manually inputting a code, but then they forget to re-enable it. And then insecure password resets, which is a really good example of this. And this happened on Instagram. So Instagram allowed users to reset their forgotten passwords by sending them a 6-digit code to their mobile number via SMS. If an attacker wanted to access a victim's account, he could try to brute force the 6-digit code. As expected, this was not directly possible, and Instagram had a rate limiting after 250 attempts, and then the person would be blocked after 250 attempts. So they found out that it only applied to the same IP address. So now they can go ahead and change their IP address, and then now they get another 250 attempts and 250 attempts. So all they needed was 4,000 IPs to cover all the possible codes. And it could sound like an insane amount, but cloud services make it easy to get them at a relatively small cost, making this attack feasible. And if you really want to reset somebody's password, then you can go through this whole thing and just do that. And now you can reset their entire password. So the vulnerability is related to the idea that no user would be capable of using thousands of IP addresses to make concurrent requests to try to brute force a numeric code. The problem is in the design rather than the implementation of the application itself. Since insecure design vulnerabilities are introduced at such an early stage, resolving them often requires rebuilding the vulnerable part of the application from the ground up, and is usually a pain in the freaking butt. So the best approach to avoid such vulnerabilities is to perform threat modeling at an early stage. We call this the move left phenomenon, where if you're looking at the software development lifecycle, the secure software development lifecycle room, and this is actually, there was a video that I did on this as well. And when you look at the software development lifecycle, you just want to move left. So if we were to look at this, let me actually show you this. So this is the software development lifecycle. Okay, so analysis and design are at the very, very beginning of this thing. And as it moves forward, it becomes tougher and tougher to make changes, because if you're already at deployment or maintenance, that means the app is already running. And if you notice something over here, now you have to go all the way back to designing source code and all of that to try to fix everything. So when they say move left, that means instead of doing it here, instead of thinking about security at maintenance, you need to be thinking about security at analysis and design and development, where you're actually developing the source code and all of that. These are the best phases to look at the design security elements and the source code security elements. So when we say move left, we mean instead of doing it over here at the very end, do it at the beginning, and it makes your life so much easier. All right, now practical example, we're going to go to port 85 on our IP address to get into Joseph's account. It also has a design flaw in the password reset mechanism. Can you figure out the weakness in the proposed design and how to abuse it? So let's try to reset his password. Keep in mind the method used by the site to validate if you are indeed Joseph. So let's go to, what is it? It was port 85. So we're going to go to port 85, and then we're going to try to reset my guy's password. We're going to try to reset Joseph's password. So port 85 is just basically a login screen. At the very bottom right, we have a I forgot my password. And it says, what's your username? My username is indeed Joseph. So we're going to do Joseph, press enter. And it says, what is your mother, assistant, son, nephew's friend's name? What is your favorite color? What is your first pet's current address? So favorite color would probably be the easiest one. And so favorite color. So let's see, blue. That is incorrect. Try again. We will do green. That is incorrect. Try again. We'll do red. Incorrect. Try again. Let's do yellow. Incorrect. Oh, whoops. I keep doing the same question. My bad. Dang it. So favorite color one more time. We're going to do green. Oh, that is his favorite color. Okay. So his favorite color is green. The password for Joseph has been reset to this. So now we have his password. So let me see. Do they want us to give him the password? Okay, so we don't want to use that. We just want to log in as Joseph. So we're now going to Joseph ourselves in. And voila, the note is there. Remember, move private files out of the server. Private files, flag. Let's go. All right, cool. We got it. Let's go to security misconfiguration. Security misconfigurations are different from everything we've talked about so far, and I think different from everything else as well, because it's basically security that could have been appropriately configured, but then it wasn't. So even if you download the latest up-to-date software, poor configurations could actually make the installation vulnerable. Poorly configured permissions on cloud services like S3 buckets. So making a S3 bucket, which is just basically a storage bucket on a cloud service, making the access to that public, for example, that's like stupid, but it happened before and it happened to like a big enough company that it was like, okay, well, that's noticeable. So that's very, very simple and stupid security misconfiguration that could have just been avoided. Having unnecessary features enabled like services, pages, accounts, or privileges, default accounts with unchanged passwords, error messages that are overly detailed and allow attackers to find out more about the system, not using HTTP security headers, so on and so forth. So this vulnerability can often lead to more vulnerabilities like the default credentials giving you access to sensitive data, XML external entities, or command injection on admin pages. For more info, we can look at the top 10 entry for security misconfiguration on OWASP's website. Debugging interfaces is another one. So the exposure of debugging features in production software is one of the big deals. Debugging features are often available in programming frameworks to allow the developers to access advanced functionality that is used for debugging an application while it's being developed. Attackers could abuse some of these debug functionalities if somehow the developers forgot to disable them before publishing the application. One of them actually happened to Patreon in 2015. 5 days before Patreon was hacked, a security researcher reported to Patreon that he had found an open debug interface for Workzerg console. Workzerg is a vital component in Python-based web applications as it provides an interface for web servers to execute Python code. Workzerg includes a debug console that can be accessed via a URL on console, or it will be presented if the user to the user if the application is raised by the application, or if the exception is raised by the application. Dyslexia is mad strong right now. In both cases, the console provides a Python console that you can run any code to send to it. For an attacker, this means that they can execute commands arbitrarily. So this is the console, and then you can start typing code. So now we can actually go and do this on port 86 and try to exploit some stuff going on. 86/console is where we're trying to go to. So we are now going to change this IP address here. And we're going to go to 86/console. And console is ready to go. Okay, here we go. So let's see what commands they want us to run. In the console, run the following Python code to run the ls command. So first you have to import OS if you want to run OS commands. And then once you do, you can essentially just run the command. And in this particular case, we are doing OS popen, and then we're going to do ls-l and then .read. So this is a much more complex version of running the ls command, but we're using Python to do it. And then we're using the print function to actually print the output of that onto the screen. So this is the full command that we're going to copy, and we're just going to go over here and we're going to paste it and then press enter. And then now it's going to list the contents of where we're at. So we have Docker file, app.y, requirements, templates, todo.db. So todo.db is a big one. So what is the database file name? And of course it is todo.db. And so modify the code to read the contents of the app file, which contains the application source code. What is the secret flag? So app.py file is what we're trying to run. And the command to be able to run it, it looks like okay, well, we got that. All right, fine. So what we want to do is we want to read the contents of one of these things. So let's see how we could do this. All right, nice. Okay, so we got it. This is the command that actually worked. So this is a basic with open command, and then you just read the contents of any given file. So we know that the name of the file is app.py, and so with open, we're going to open the app.py file in read mode, and then we want to save it as some kind of a variable. So we're going to open this in read mode and save it as file. And then you have to put a colon at the end of a command like this. And usually we would press enter and then put this on a new line, this portion on a new line. But since we're writing everything all in one line, you basically just press space and it's just going to execute it as such in next in order. And then after this, you have to put the semicolon so that you can put this other print function, because this is the body of this. So it's very kind of, I have to show you what it actually looks like in normal format, so it kind of makes sense. So this is basically what it looks like when you're inside of a Python editor and you have the first line that goes like this, and we save it as file, the variable. And then inside of the body of that, we have this other command where we have file contents being saved. So this is another variable. We have file contents being saved as file.read. So when inside of this module, or inside of this header, I guess, because we're using the open function, we can then use the read function. So we'll actually read this file basically because it's in read mode. I'm not here to explain the depths of Python to you, but essentially that's what this looks like. And then the reason why we had to put a semicolon at the end of this is because this one is now outside of the body of this. And so if we're going to put this command outside of the body, we have to put a semicolon at the end of it. So the first time that I actually ran this, I put the semicolon right after the colon because I thought, oh, okay, maybe it's for like every new line, but it's not for every new line. So this entire batch right here, ultimately, it needs to be one full line. And then because you're creating a print function at the end of this whole thing as its own little segment, then you put the semicolon right here. And then the command actually works, and then it opens this in read mode, and then you can actually print the contents of it onto the screen. So essentially, this is what the contents of this is, and then we have the secret flag at the very top, which is THM, just a tiny misconfiguration, and this is the piece that we want to copy so that we can take it for our answer over here. So hopefully I explained that well. If you don't have an understanding of Python, it's going to be a little bit confusing. If that was like the very first time you've ever been exposed to Python, that's going to be a little bit confusing. But if you understand Python, then you should know exactly what we just talked about. And there's multiple videos on this channel about Python. And there are like introductory videos, and then I always point people to the Python for cybersecurity video because it starts from the very, very basics of how to download Python, how to set it up, how to run your first program ever, and then it gets more and more advanced until by the end of the video we create algorithms. So if you've never used Python before, that would be a really strong Python video. If you've used Python before, it's still a really great video because again, it just takes you from the very basics as refreshers, and then you actually learn how to create algorithms by the end of it. So let's move to vulnerable and outdated components. This one's pretty easy to wrap your head around. So there are vulnerable components or outdated components that if they have not been updated or if they haven't been patched, you're kind of SOL. So when you may find that the company entity your pen testing is using a program with a well-known vulnerability. So let's say that they have not updated their version of WordPress for a few years, and using a tool like WP Scan, you find that it's version 4.6. Some quick research will reveal that WordPress 4.6 is vulnerable to an unauthenticated remote code execution exploit. And even better, you can find an exploit already made on exploit database, which is crazy. As you can see, this would be quite devastating because it requires very little work on your part as the attacker. Since the vulnerability is already well known, someone else likely has made an exploit for the vulnerability already, and this makes it is even worse when you realize that it's really easy for this to actually happen, and it happens regularly. I do use WordPress websites for myself, and it's constantly being updated because there's bugs that people find and they exploit. And then as soon as those things are distributed, if you don't patch or update your WordPress site, you're just asking for it. At that point, you're literally asking for people to hack you. So thankfully, I don't have like any sensitive information on any of my websites because cybersecurity has made me super paranoid. But for the most part, I mean, it's still vulnerable. Like if you don't patch it, and you store a database or like you collect customer information because you have a shop that you're selling stuff on, it's like all of that stuff is super vulnerable if you just don't patch your WordPress site. So it's kind of crazy when you think about it. And that's basically it. So now we're going to talk about the exploits for vulnerable outdated components. Since the whole purpose of vulnerable and outdated components is to exploit something that is known as a vulnerability, most of the work, for the most part, has been done for us in sites like ExploitDB or something like that. There's usually something that pre-exists, and you can run it to try to get what you want to do. So in this particular example, we have this web application that's using Nostromo 1.9.6, 2037 ready for inquiry. What's the story, mother? Whatever. So it's powered by Nostromo 1.9.6. So if we look this up on ExploitDB, we can see that there's multiple exploits for Nostromo 1.9.6, and one of them is a remote code execution, and then there's directory traversal, so on and so forth. So we have at least 3 different exploits in this particular case, or actually we just have 3 different exploits. So that's available, readily available. So the top result happens to be exploit script. Let's download it, try to get the code execution. Running this on its own teaches us a very important lesson. So if we just run this by itself, it says that, what does it say? It says name CV is not defined. So there's a name error for the Python vulnerability here. So the exploits you download from the internet might not work the first time. It helps to understand the programming language the script is on, if needed, so you can fix any bugs or modifications. The error was caused by a line that should have been commented out, so it's an easy fix. So we have this piece right here. This line needs to be commented, as the comment right here says, and basically you just put a hashtag in front of it and this becomes commented, and that's it. So once you do that and then you run it, and then you run it obviously against, let's say, an IP address that you're trying to get. So in this particular case, it is being run on the loopback IP address on port 80, and then they just run the ID command, so it actually feeds back the ID of whatever it is that they're trying to do. And lo and behold, it works. So we have the remote code execution. Now it's time to note that the most important scripts, or most scripts, will require will tell you the arguments that you need to provide. Exploit developers will rarely make you read potentially hundreds of lines of code just to figure out how to use this. So it's also worth noting that it may not always be this easy. Sometimes you just you may just be given a version number, like in this case, but in other times you may need to dig through the HTML source code or even take a lucky guess on an exploit script. But realistically, if it's a known vulnerability, there's probably a way to discover what the application is running. And that's basically it. That's all we got. So we're going to actually run a lab now on this IP, on this port number, and see what we can get. Yes, so I remember this, the bookstore exercise. So let's see, we need to find the version of this thing. So if we click on this link at the bottom, this is a admin login. So if we click on that, it does not give us anything. So let's go back one more time, and we're going to click on, let's say, contact, and this will also not give us anything. If we click on publisher, it gives us nothing. Let's click on project worlds. Okay, so I didn't really even need to do any research on the actual thing. Basically, on the website itself, it says CSC bookstore. So all I did was I went to exploit database and just searched for bookstore. And on exploit database, we have multiple exploits here. And what is it? Multiple SQL injection, quantity persistent authentication bypass, multiple vulnerabilities. And these are what's available here. So let's see if any of these actually work. Okay, so this is the one right here. So online bookstore, unauthenticated remote code execution. The ID is 47887. And so if we look at this list that I have right here, I got it because I searched for book space store. If you do bookstore together, you're only limited to, I want to say, like 4 results. And then the one that we're interested in is the one that's actually been verified down here. And it's online bookstore, 1.0 unauthenticated remote code execution. And this is basically it. So this is the entire script that we want. Now I'm just going to copy the script, and then I'm going to go to my attack box, and I'm going to just paste it inside of a Python file. So I'm just going to open up my terminal here. We will quit SQLite. So the easy way would be to just do nano, and then I'll do bookstore.py, and then I'm just going to paste everything that I have. So this is going to be the full script that we just copied essentially from that place. And then we're going to do Control O, press enter, Control X to exit it out. And then I should be able to run it. So let me see if there's anything else that I need to do here. So I know that we need to have an argument that's supposed to be fed to this, and it seems like the argument needs to be a URL. I don't know why this is not zooming in here, but essentially they have the argument library, the argparse library, and then they also have a URL variable. There's no real instructions here. It just, I guess it, oh, there is a help, the URL of the article or the URL of the target. So yeah, that's like the closest thing that we get to instructions over here. So what we're going to do is we're going to just run the script, and then we're going to add the URL of the website that we are going to be scanning or running this against, which is right up here. So we're going to do Python 3 and then bookstore.py, and then I'm going to do 10.10.231.160, and then I'm going to do 84, press enter. And so let's see. Okay, so the proper way to run it actually is you need to put the http:// before the IP address, and then I just put a / at the end of it as well, just for the hell of it, and it actually ran. And so now it says, do you want to launch a shell here? I'm going to say, yes, I do. And oh, we have it. We got the shell. There we go. That is officially a shell. Okay, so ls. Okay, there we go. We literally have the shell. Okay, so what is the question again? It says, what are the contents of the opt.flag file? So we're just going to do cat opt flag.txt, and there it is. Okay. It was, I mean, that was not bad. Like, the hardest part about this was sifting and sorting through these exploits that we have on exploit database to try to find the one. And even that wasn't that hard, because honestly, you just, like, if you want to shortcut the process, you look for the one that's actually been verified, and that's it. That was it. That was the whole thing that we just did for this one. And just like that, there was an exploit that it existed, and we just ran the exploit and it worked, and we had a remote code execution. So yeah, moving on to Section 7, Identification and Authentication Failures. Authentication allows users to gain access to web applications or websites by verifying their identities, and the most common version of this is the username and password, which everybody has. A user would enter their credentials, the server verifies them, and then the server would then provide the user's browser with a session cookie if they are actually correct, so if their credentials are correct. A session cookie is needed because the web server uses the HTTPS to communicate, which is stateless, and attaching session cookies means the server will know who is sending what data for that specific session, and then the session can expire essentially when the user steps away or a certain amount of time passes. The server can then keep track of the user's actions during that entire session. If an attacker is able to find flaws in the authentication mechanism, they might successfully gain access to other users' accounts, and this would allow the attacker to access sensitive data depending on the purpose of the application. And some common flaws in authentication include the brute force attack. So if a web app uses usernames and passwords, and then we can try to launch a brute force attack that allows us to guess the username and password using a multiple amount of entries, and if there's no rate limiting and they don't lock us out, we can basically use as like millions of variations to try to get in there. And then we have the use of weak credentials, which there's usually some kind of a password policy. Ideally, there would be some kind of a password policy in place. So it's like at least use one capital letter, one lowercase letter. It needs to be at least 12 characters long. You need to have at least one number in there and a special character, something like that. And then some web applications even tell you that this is a weak password. When you try to set up the account or when you try to change your password, they actually say this is a weak password, try a different password, because they're comparing it against the database like the RockU dictionary, password dictionary, and against that list, which is like something like it's tens of millions of passwords. There's a lot of passwords inside just the RockU list. And so it's comparing it against that list, and it's going to say, yeah, okay, your password, which is password 1, is a really common weak password, and you should not use that because it's in this dictionary. And then anybody that knows how to use John the Ripper or CrackStation, even anybody that knows how to use these tools, they'll be able to crack your password. So we can easily guess them or access the user accounts because they have really weak passwords. And then there's a weak session cookie, and the session cookie is how the server keeps track of the user. So if session cookies contain predictable values, the attacker can set their own session cookie and then use that to access the user's account. So the mitigation for all of these things would be to avoid password guessing attacks, ensure the application enforces a strong password policy, to avoid brute force attacks, ensure that it has an automatic lockout, which is basically rate limiting. So after a certain number of bad attempts or incorrect attempts, it should be locked out. And then the person should be notified that, hey, you've been locked out of your account because of too many incorrect attempts. Then we have the implementing of the multi-factor authentication. So if somebody wants to log in, they should get a secret code texted to them, or a code texted to their email, or some kind of a face scan or a fingerprint, or a Google Authenticator app, or a variety of different multi-factor authentication mechanisms to make sure that it's not just the username and password that they're using to log in to their account. So this is just the theoretic part of identification and authentication failures. And so now we actually get to try a exercise here. We can try an exercise for identification and authentication failures. For this particular example, we're going to look at a logic flaw within the authentication mechanism, and something that happens, and I referred to this earlier in the video, and it's an exercise that we did in the Burp Suite video, is that when somebody has like a form on their website, the developer forgets to sanitize the username and password that's given by the user in the application, which makes it vulnerable to an attack like SQL injection. And then we can focus on a vulnerability that happens because the developer's mistake, but it's actually very exploit, which is the easy to exploit, which is the re-registration of an existing user. So let's say that there's a user with the name admin and we want to access their account. So we try to re-register that username with a small modification. So we will say admin without the actual quotes, obviously. Notice the space at the start of it. So you see there's this little space right here. So it's actually space admin, and then obviously there's no quotes around it. And this is just admin, no space before or after it. So when you enter when we enter this in the username field and enter other required information like the email ID or password or something like that, it'll register a new user, but that user will have the same right as the admin account, and it'll also be able to see all the content that's presented to the admin. So to do this, we're going to register with Darren, and then we'll see that it already exists. So we'll try to register with Darren with the space instead, and then we'll be able to register as Darren and then get access to the flag that's in his account, and then do a variety of other things that are required by these questions. So this is the web application already. This time I was actually a little bit ahead of the game and I loaded it in advance. So if I click on register and I do Darren without the space in the beginning, and then we'll just do Darren@thm.com as the email, and then let's see if we can actually get a password here, and we'll just do password like a super weak password, and then we'll register. And it says you can't do that because this user already is registered. So I'm going to go again, try it again, and this time I'll do space and I'll do Darren. So there's a space in front of that, and then it'll still be Darren@thm.com, and then the password will be password again. And then from here, we're just going to press register. And now it says user registered successfully. So now I can do this. I can do Darren, and then I'll do password, and then let's sign in and see if that works. And it says invalid username. So now I'll do space Darren, and then I'll do password, and then sign in, and it'll actually log me in. And then there we go. So this is the first, I guess that's the first flag, right? What's the flag that we found in his account? And it's right there, right on the homepage. So now it says, now try to do the same trick and see if you can log in as Arthur. What's the flag that you find in Arthur's account? So we're going to log out again, and we're going to go through the same thing, except this time I'm actually just going to put a space in front of Arthur, Arthur, like that, right? That's what we want. Yeah, Arthur. So there we go, Arthur, and then we'll do Arthur@thm.com, and then super weak password, and then we will register, and then it says user has been created, so space Arthur, and then password, and then sign in. And now we are logged in as Arthur. And there we go. We have the flag on Arthur's account. So super basic, right? Like it's not this one is not a complicated hack at all, but this is one of the identification authentication failures that exist on a web application. And this was on the most recent OWASP list. So we can actually consider that this was technically a big deal because it's number 7. It's not even last in line. So this was a big enough deal that it even made it to the list. And something as simple as the exercise that we just ran, where you just put a space in front of the username, that's like, it's crazy to think that something like that could even exist. So you could potentially try to, I mean, legally, obviously you don't want to do this without people's permission because it's a felony or whatever, but this is a simple exercise to run when you're doing a pen test, just to see if you can do this against a website or a web application. So very, very simple exercise, but extremely powerful. As you can see, we can literally get access to essentially anybody's account by just putting a space in front of their name. That's pretty crazy to think about. Okay, so let's go to the software and data integrity failures. When we think about the word integrity, so there's also something in cybersecurity called the CIA triad, where we're talking about confidentiality, integrity, and availability. So integrity is a really big concept in cybersecurity in general. And when we talk about integrity, we're looking at something that has been unmodified, or it's unaltered and nobody changed it in any way. It still maintains its originality. It maintains its original integrity. The integrity hasn't been changed or altered, modified in any way. This is an essential in cybersecurity, as we care about maintaining important data free from unwanted or malicious modifications. For example, let's say you download the latest installer for an application. How can you be sure that when you're downloading it, it wasn't modified in transit or somehow got damaged by a transmission error? So to overcome this, we will look at the hash of these things, right? So a hash or digest is simply a number that results from applying a specific algorithm over a piece of data. When reading about hashing algorithms, you'll often read about the MD5, SHA-1, SHA-256, or any other one. And these are just the variations of this. So if we looked at the WinSCP secure copy setup executable file, right? So if we look at that, we have these various hash values, and these were pre-calculated by the creators of WinSCP so that when you check the file's integrity after downloading it, you can be sure that if you compare it against the actual value that's on their website, you can be like, oh, okay, so this is actually an unaltered file because this is what the hash value should be, because if this file has been changed even in the slightest, then the hash value will be completely different. Therefore, you know that the file has been altered. So to calculate the different hashes, we can use any of these commands: MD5 sum, SHA-1 sum, SHA-256 sum, and then you just give it the name of the file, and then you can give it an executable file, you can give it a Word document, an image, anything. So since we get the same hashes, we can make sure we can safely conclude that the file that we downloaded is the exactly copy that it is on their website. So software and data integrity failures arises from the code or infrastructure that uses software or data without using any kind of integrity check. And since no integrity verification is being done, an attacker might modify the software or data that's passed to the application, and that results in unexpected consequences, mainly two types of vulnerabilities, which is the integrity failure and the data integrity failure. So a version of this is, I always share this when we talk about hashes and where we're talking about the comparisons of these things, is I'll go to this website right here. So the KaliLinux.org website. If we go to KaliLinux.org, we can download the ISO images, or Kali.org, excuse me, Kali.org. We can download the ISO images of Kali Linux, right? The variety of versions that they have for different operating systems, or for different installer images, or different types of ISO images. For example, the one that you can install on a USB drive, and then now in your pocket, you can take a full copy of Kali Linux that you can boot from any computer, for example, right? So let's say we go to the installer images and we want to look at these images that we have right here, and the net installer. When you click the sum button, they give you the SHA-256 sum of this specific file. So you know that when you download it, in case if anything happened during the download in transit, or I don't know, maybe you downloaded this from somebody's website or something and you want to make sure that it's exactly what it's supposed to be, this is the SHA-256 sum for this specific download file for this version of Kali Linux, which is the net installer version. All packages are downloaded during the installation, so on and so forth. And that's basically it, the installer version here. This is the SHA-256 sum for this file, so on and so forth. So they have this on here because Kali Linux is literally designed for penetration testing. And so it would be silly if they didn't have the MD5 sum, or not the MD5 sum, excuse me, the hash sum value of it. And it would be the SHA-256 sum. So we can just compare that against the download once we've downloaded it by running any of these things right here, any of these algorithms, SHA-256 sum or SHA whatever, and then from there you'll be like, oh, okay, this is actually the download file, or this is not the download file. So when you look at anything that you've downloaded, you can actually compare it against the hash value from their website to make sure that you've downloaded exactly the file that you think you're downloading without the integrity being changed in any way. So that was what we had for the software and data integrity failures. So let's look at software integrity failures more closely. In the video that we did for the introduction to JavaScript, we talk about the fact that we can actually pull a JavaScript script from an external source. So from an external library, a third-party library, for example, and you would just use it by doing script source and then give it the link to the script file. And you could actually do this fairly easily, and it's actually pretty common. It's just that what happens here is that if this particular website has not verified their code, or if that particular website gets hacked and somebody goes and modifies this JavaScript file, when you reference it in your website, when you try to use that code, that means you're now using the hacked version of that code. So what happens is that when somebody navigates to your website, the browser will read the HTML code and then download the jQuery from the specified external source. So somebody requests this, right? And then their request from the website goes to the jQuery.js file, and then jQuery will actually send that file and it'll get processed on the HTML, and then the viewer gets to see whatever that is on the website as they view it. So if somebody hacks into jQuery official repository, they can change this and then inject malicious code in it, and anyone visiting your site would pull that malicious code and execute it into their browser unknowingly, and a lot of things could happen. So this is an integrity failure, as your website makes no checks against the third-party library to check to see if it's changed. And modern browsers allow you to specify a hash along the library's URL so that the library code is executed only if the hash of the downloaded file matches the expected value, and this mechanism is called the sub-resource integrity, and you can read more about it on this particular link, which is, I believe, from the SRI hash generator, and then we have it right in the middle of the page where we see the sub-resource integrity and what it is and how it actually works. So this is the srihash.org website that we have over here. So if you wanted to read more about that, you could go ahead and do that. So the correct way to insert this into the HTML code would be to use SRI and include an integrity hash, so that if somebody like an attacker is able to modify the library, any client that's navigating through the website won't execute the modified version, and this is what that will look like. So we have the original script right here that's being referenced as a source. We have the modified version right here. So we have the actual script, right? Source, and still inside of this block, we have another variable that has integrity, which is the SHA-256 sum, and then the cross origin, which is anonymous, and then it just closes out with the script block right here, or the script tag, excuse me. So you have the full thing that's being referenced, and then it just closes out normally as it would, and then right after this source right here, so you see right here we have the source, and then it closes out with the tag. So right after this segment, we would use the second variable, which is the integrity variable that includes the SHA-256 hash value, and then the cross origin, which is anonymous, and that's it. And then you just close out the tag, and then we can go to this should generate hashes for any library if we need to. So if we go to that website again, now we say what's the hash of this particular thing right here. So we would copy this and then go here and then go right there and then paste it. And then we say SHA, what do they want? They want the SHA-256 hash. So I will go over here and I will select SHA-256, and then I'll say hash it. And then it gives me the integrity, and this is the full hash. So ZO yada yada yada, and it ends with that equal sign at the end of it. And so that's what we have exactly over here. So there we go. We were able to verify the integrity of a piece of code by just taking the link of that code file, that JavaScript file, and then using it inside the SRI hash website, and then it generated the proper version of it for us. So it even gave us the full link if we wanted to go ahead and drop this script code, this block of code, into our HTML for our website, including the SHA-256 hash value. And that is quite useful, believe it or not. I don't know if you're big into web development, but something like that is very, very useful. So that was it for the software integrity failure exercise. Now we can look at the data integrity failure. So let's think about how web applications maintain their sessions. Usually when a user logs into an application, they'll be assigned some sort of session token that'll need to be saved on the browser for as long as the session lasts. And sometimes when you say remember me on this browser, it ends up being like a permanent session token, and that doesn't get erased unless you actually clear your browsing history and include all of your cookies and your caches and everything to be deleted. And when you do that, then the session is wiped. So this token will be repeated on each subsequent request so that the web application knows who we are. These session tokens can come in many forms, but are usually assigned via cookies, and cookies are key value pairs that a web application will store store on the user's browser, and that will be automatically repeated on each request to the website that issued them. For example, this is the key, which is the user, and the value is Susan. So if you were creating a webmail application, you could assign a cookie to each user after logging in that contains their username. In all the other requests after that, your browser would always send your username in the cookie so that your web application knows that what user is actually connecting. And this will be a terrible idea security-wise, because as we mentioned, cookies are stored on the user's browser. So if the user tampers with the cookie and changes the username, they could potentially impersonate somebody else and then read their emails. This application would suffer from a data integrity failure, as it trusts data that the attacker can tamper with. One solution is to use some integrity mechanism to guarantee that the cookie has not been altered by the user. To avoid reinventing the wheel, we could use some token implementations that allow you to do this and deal with all of the cryptography to provide proof of integrity without you having to bother with it. One implementation of this would be the JSON web token, also known as the JWT. JWTs are very simple tokens that allow you to store key value pairs on a token that provides integrity as part of the token. The idea is that you can generate tokens that you can give to your users with the certainty that they won't be able to alter the key value pair and then pass that integrity check. The structure of the token is in 3 parts. So the header would be this. So there's a dot right here. I don't know if we can actually see this. So there's a dot that separates each one of these things. So this is the header, and then there's a dot, and then this is the payload itself, and then there's a dot, and then there's the signature. So the header would be the type JWT, the algorithm would be HS256, and that's all in this specific value right here. And then the payload is now the username guessed, and then the expiration would be, I guess, I don't know if that's the number of seconds or a time and date kind of a thing. But that would be the payload. And then from there, we have the signature, which is a bunch of, it looks like, I think it's ASCII. I believe that's ASCII encoding. I'm not really great at recognizing encoding, like just with my naked eye, but it kind of, I feel like it's ASCII. Let's see if it gives us any more information about this. So the header contains metadata indicating that this JWT and the signing algorithm is HS256. The payload contains the key value pair with the data that the web application wants the client to use. The signature is similar to a hash taken to verify the payload's integrity. If you change the payload, the web application can verify that the signature won't match the payload, and it'll know that you tampered with the JWT. Unlike a simple hash, the signature involves the use of a secret key held by the server only, which means that if you change the payload, you won't be able to generate the matching signature unless you know the secret key. So each one of the 3 parts is simply plain text encoded with base 64. You can use this online tool to encode, decode base 64. Try decoding the header and payload of the following token. So I'm guessing it's going to take us to CyberChef because, oh no, this is a different tool. So okay, base 64 encoder or decoder. So CyberChef is another really, really popular one. You can just Google CyberChef and you'll be able to use its various recipes to be able to do that. So it's very, very powerful tool. So we want to decode the header and payload of this. So I'm just going to take that, paste it in here. I'm going to click decode, or actually, I guess I should click decode first and then paste it. And then now we see right here is JWT algorithm HS256. So that was the header. And then now we have the payload itself, which is this whole chunk right here. So we'll take that, put this over here, and then paste that as our payload. And now we have username, guest, expiration. Oh, so this is literally the same thing that we actually just saw over here above us. So that's fine. Signature contains binary data. So even if you decode it, you won't be able to make much sense of it. So it was binary. It was not ASCII. My bad. JWT and the non-algorithm. So a data integrity failure vulnerability was present on some libraries implementing JWTs a while ago. As we have seen, JWT implements a signature to validate the integrity of the payload data. The vulnerable libraries allowed attackers to bypass the signature validation by changing the 2 following things in a JWT: to modify the header section of the token so that the algorithm header would contain the value none, and remove the signature part. So taking the JWT from before as an example, if we wanted to change the payload so that the username becomes admin and no signature check is done, we would have to decode the header and the payload, then modify them, and then encode them back, and then encode them back. So notice how we removed the signature part. So now you have just 2 blocks of text, and then the algorithm has been changed to none, and the username was changed to admin, and then it now created a new coding for us. So it's pretty simple. So let's walk through the process that an attacker would have to go through on this particular IP address, and then follow the instructions below. So I'm going to now go on this IP address and follow those instructions. So this is it: cookies for all, username, password, etc. So let's see the first portion here. It says try logging into the application as guest. What is the guest account password? If the login was successful, you should now have a JWT stored as a cookie in your browser. Press F12 to bring out the developer tools. Depending on the browser, you'll be able to edit the cookies from the following tabs, which is on storage and then cookies, and then we have the cookie right down here. Or depending on if it's on Chrome, it's going to be under application, and it will be able to see the cookie. So if we try to log into the application, what is the guest account password? I guess that would be guest as well. So if I try to log in, it says you can also log in. I mean, that's literally on the screen. So it says invalid credentials. You can also log in as guest with password guest. So I literally just typed in guest as the username and pressed entered with no password, and it just gave it to me on the screen. So that was it. So now that's unbelievable. Okay, so we'll do guest, and then the password will also be guest, and then we will now log in. So if the login is successful, hello guest, only the admin is allowed to get the flag. That's all good. So let's open this up in a wide screen here. And what we're going to do is we're going to look at the source of this page. So we'll go here, we'll inspect it. And then once we click inspect, we can actually go down here and then click on the storage tab. And in the storage tab, we will actually see our cookies. And so we have this cookie right here, which is the full massive thing right here. So let me see if I can double click this. Yeah. So we can actually double click this, and let me see if I can drag it out to display the full thing. And so we can now double click it. I have this full thing. I'm going to copy the full thing. I'm going to go to this website here. And what we want to do is to go ahead and what is the name of the website's cookie containing a JWT token, and it is JWT session. So that's the name of the cookie is JWT session, and it has that token. So that's that. So now use the knowledge gained in this task to modify the token so that the application thinks that you are the user admin. And then so what we're going to do is we're going to remove the signature, right? So let me go here. I'll go ahead and paste the full thing that I just got here. So this is the full thing that I got. And so I'm going to remove the signature first, okay? And then I'm going to remove, I will actually, let me highlight this full thing so I can keep that. And then I'll just save it on a little note document real quick. And then what we will do first is we're going to modify the first portion of this, which is going to read here. So it's going to be type JWT algorithm HS256. And what we want to do is we want to change the algorithm to read none, as it says over here. So we will go here. We will change this to none, like so. Let me see if I can, maybe I guess I can't copy that. So I'll go to encode, I'll paste this, and then I'll do none. So there we go. This is going to be our modified algorithm, or our base 64 portion. So I will now paste this on the piece of code that I had saved. So that's going to be my modified version. And then from here, I'm going to go take the other portion that we had here. And so let's get that chunk of text, and then we're going to go ahead here. We're going to decode this piece. So it'll say username guest, and then so on and so forth. And then so we're going to take that over here. We're going to paste that here, and we're going to change this to admin. And then now we get to take this full piece and then go and paste that with our last piece. So now we have this full chunk of text, which I have right here. So now I will go ahead and take that, bring it here. So, I mean, for literally all I did was, so I'll show you the full thing just so you can see what the full thing looks like. So it is this right here. So this is the modified version that we just created. So this initial one is me changing the algorithm to none, and then there's that dot that separates it, and then this last piece is the one where I changed the username to admin, and then we just encoded it. So that's basically it. Now we piece all of these things together, and now we have this. So we're going to go inside of the browser down here, and we're just going to go for this section, and we're going to paste it here, and that'll be that. And then so now I guess I press enter and refresh the page. Either the token or signature is invalid, no flag for you. So let's see. I see. So there's literally a dot that's also supposed to go at the very end of that second portion. And so I did not include my dot in my cookie. I just had the full piece right here. So I'm going to go here. I'm going to delete that one more time. I'm going to paste the cookie that I got, and then add the, nope, that's not the cookie that I got. So let me go ahead and actually make sure that I have the right cookie. That's the first important part. So we just want to make sure that we have the right cookie. So let's copy this bad boy here and then bring it back over here. And then we're going to take this whole thing and then we're going to paste it. There we go. That is the right cookie. And now I'm just going to put a dot at the end of this, press enter, and that will say, okay, so that's saved. So I think now I can just refresh the page, and there we go. All right, so there it goes. It worked. So all I was missing was basically just the dot at the end of this whole thing. So everything that we did was correct up until the point that I was just missing that last dot at the very, very end of it like that. And now this is the full thing, and then you just submit that. And you press enter. So I modified the cookie right here. So I double clicked that. I erased it. I pasted the value. I did the dot, pressed enter, and then I refreshed the page. And then boom, we have our flag. So very good. That worked like a charm. Excellent. All right. So let's talk about security logging and monitoring failures. All right, when web applications are set up, every action that's performed by the user should be logged, okay? This is a concept that is, I mean, it's literally as old as IT and cybersecurity itself. So logging is important because in the event of an incident, the attacker's activity can be traced. We call this incident response or digital forensics. So once their actions are traced, their risk and impact can be determined. Without logging, there would be no way to tell what just happened. We have regulatory damage that we need to take care of, which is an impact that is a really big piece of an attack that takes place. So without logging, there would be no way to tell what actually happened. And then the more significant of those impacts could actually be the regulatory damage, meaning that you can, by the regulatory environment, so HIPAA or GDPR or something like this, right? So if an attacker has gained access to personally identifiable user information and there is no record of this, final users are affected and the application owners may be subject to fines or more severe actions depending on the regulations of their industry. And then there's a risk of a further attack. So the attacker presence may be undetected without logging, and then you don't know who it was or what they did. And they could just do it again, right? Or they could do even worse stuff the second time around. So the information that's stored in logs should include the status codes inside of it, the timestamps, usernames, API endpoints or page locations, and the IP addresses, for example, the source IP and the destination IP of that transaction or that communication that happened. These logs have some sensitive information, so it's important to ensure that they are stored securely and multiple copies are stored at different locations for backups. As you may have noticed, logging is more important after a breach or incident has occurred. The ideal case is to have monitoring in place to detect anything in a live environment. The aim of detecting this suspicious activity is to either stop the attacker completely or reduce the impact that they've made if their presence has been detected much later. And common examples of this activity could be multiple unauthorized attempts for a particular action. So trying to log in, for example, you get multiple login attempts, unauthorized login attempts to an admin page, or requests from an anomalous IP address or location. This can indicate that someone else is trying to access a particular user's account. It could also have a false positive rate. Use of automated tools, so scanning tools, for example, or the value of user agent headers and the speed of the request. That could be one of the things that will be like, oh, okay, somebody's using Nmap, for example. That would be the user agent header. It's like somebody's using Nmap to scan us. or if there are a lot of ping requests or something that are happening, it's like, okay, well, what is going on? We just got a million ping requests or pings in the last like 10 seconds or something from this IP address. It's like, okay, that's definitely not right. So this can indicate that the attacker is using an automated tool. And common payloads. So in web applications, it's common for attackers to use known payloads like what we did with the exploit database payload. That's a pre-existing payload. And we were a script kiddie in that situation where we're using somebody else's script, somebody else's exploit to attack. So detecting the use of these payloads can indicate the presence of someone conducting unauthorized malicious testing on applications, and detecting suspicious activity just by itself isn't helpful. So this needs to be rated according to the impact level. So certain actions will have a higher impact than others, meaning there's low criticality or critical criticality, or I guess severity. We can have low severity or critical severity. The higher impact actions need to be responded to sooner. Thus, they should raise alarms to get the relevant party's attention. Putting this to use by analyzing the provided example log file, we can download it by clicking the download task files button at the top of the task. So let's go ahead and do that so that we can try to access this specific log file here. All right, so this is the log file. We have several items at the top right here that got a response code of 200, meaning that they were processed, and then we have unauthorized requests right here, trying to log in as admin, administrator, anonymous, or root, and they were all trying to go to the login page. And this, I am guessing, is the source IP address that was trying to do the whole thing. So 49.99.13.16 is the source IP address. So the first question here is telling us what is the IP address that the attacker is using, which is at 49.99, and what kind of attack is being carried out. And if we just look at it, they're literally trying to log in as any user that they can possibly do, and they're trying to access the login page by these various users, and every one of them is unauthorized responses, which means that they're trying to just brute force the login on our login page. They're trying to access by brute force, which is the type of attack that is being carried out. So that's the value of a log file. You just need to know what you're looking for. And then thankfully, there's a lot of tools like intrusion detection systems or SIMs that will make this a lot easier for you. There's endpoint detection and response systems, endpoint security. There's so many different automated tools that as long as you have your log files loaded or you have your web pages being monitored in a live environment, you'll get notifications as it's happening, and then you'll know what's going on. You don't have to know how to read these things. The alerts will just pop up to the screen. Obviously, it's really good to know how to read a log file, and this isn't complicated, right? This is the timestamp that happened. This is the page that was being attempted. This is the usernames that were being attempted, or the data that was being posted to it. We can think about it like that. The response codes were 401 unauthorized, and then these were the IP addresses that were trying to access it. It's not complicated, right? So it's very, very simple to read that log file at the very least. Some other log files are a little bit more complicated, but usually, as long as you have like an understanding of the general type of log that you're looking at, you'll know what kind of data is being presented to you, and then everything's all good after that. You can decipher the information fairly easily. So let's move on to our last OpenWASP top 10, OWASP top 10, OpenWASP. I don't know why I said that. OWASP top 10 items, so which is the server-side request forgery. This vulnerability occurs when the attacker can coerce a web application into sending requests on their behalf to arbitrary destinations while having control of the contents of the request itself. That's kind of complicated, so let's talk about it a little bit deeper. These vulnerabilities often arise from implementations where the web application needs to use a third-party service. So for example, a web application that uses an external API to send SMS notifications to its clients. For each email, the website needs to make a web request to the SMS provider server to send the content of the message to be sent. And since the SMS provider charges per message, they require you to add a secret key, which they pre-assign to you to each request you make to their API. The API key serves as an authentication token and allows the provider to know to whom to bill each message. And this application works like this. So this is the API at the top right here, and then you have that API call that's happening inside of the URL, and then it's sending the SMS, and then it's getting the SMS server right here, and then the message itself is hello, right? So the request that we're getting is my site. We want to get SMS, and then we want to access this server, and the message is going to be hello. So what's going to happen is that through the power of the internet, our website is going to forward the SMS provider using that key, which is the API send message, and then it actually gives it the secret API key as well. And it's going to go to this server, which is our SMS sending server, and then it's going to submit that submit that request, excuse me. And I skipped this step, so my apologies. So the request is what we are seeing right here. The query is going to be build, so it's going to be turning this whole thing into, all right, we're going to query this specific website, which is the service or srv3sms.thm, which is this piece right here. So we want to get the SMS server for this and then send that message. And then so this is what we're accessing, that actual domain name. And then the API send the message hello. And then this is going to be the query that's going to be built. And then that query is going to be sent to the actual service for the SMS, the server. And then it's actually going to send the message that we want, as long as we have our secret API key that goes along with our query that came from our website. And you usually get a secret API key anytime that you create some kind of an API connection or integration. You get your own API key so that you can actually use that API. So this is something that's easily accessible as long as you have an account with whatever the application or the service is, which is in this case the sms.thm server. So by looking at that diagram, it's easy to see where the vulnerability is. The application exposes the server parameter to the user, which defines the server name of the SMS provider. If the attacker wanted, they could simply change that to a machine that they control. So instead of it sending to the srv3.sms.thm, which is this website right here, which is inside of the URL. So instead of sending it over there, then we can just send it to the attacker.thm. And then that would be the server, and that would be a domain that we would control, and then we could essentially manipulate this any way that we want. So as part of the forwarded message, the attacker would obtain the API key, allowing us, or allowing them, to use the SMS service to send the messages at our expense. So this would only need to make the following request or the following modification, which is this piece right here in the overall URL. And then it would make the vulnerable web application make that request to the attacker.thm, and then everything else will still be the same. So you could then capture the contents of it using Netcat, as long as you're doing it against your specific domain, which is in this case attacker.thm, and then you will listen on port 80 because that's the web port, and then hopefully it'll actually connect, and then you'll be able to get that session and do whatever you want on that web application. So this is a very basic case. Obviously, if it doesn't look that scary, it can actually be used to do much more in general. Depending on the specifics of the scenario, you can enumerate internal networks, including IP addresses and ports, abuse trust relationships between servers, and gain access to otherwise restricted services, interact with non-HTTP services to get remote code execution. So we can do this in a lot of different ways. You could do a lot of crazy things. So we're actually going to try this. So we're going to go to port 8087 on our IP address for our victim machine over here, and then this is the website right here. So I will look at it in the full screen mode so that you can see what's going on. So it says explore the website. What is the only host that's allowed to access the admin area? Check the download resume button. Where does the server point to? And then using the SSRF, make the application send the request to your attack box instead of the secure file storage. Are there any keys in the intercepted request? And then go the extra mile. There's a way to get the SSRF to gain access to the site's admin area. Can you find it? You won't need this flag to progress in this room, but it would be cool if we were able to find it. So first, let's go ahead and close this right here. And the first question was, who's the only host allowed to access the admin area? So if I click on this menu right here, we can go to our admin area. And it says admin interface only available from local host, which would be 127.0.0.1. Technically, that could be our local host, or it could be local host by itself. So from here, localhost is the answer to the first question. Now it says check the download resume button. Where does the server point to? So we're going to go back one, and then we're going to click on portfolio, I think, or is that what this is? Let's see, download resume. Boom, there it is. So it would be on the portfolio. Click on the download resume, and it actually points to this is literally on our local website. It's file root download PDF. So this is literally pointing to the oh no, it's not. So it says check to download. Where does the server parameter point to? So I don't even see the server parameter. So this is my download resume. It says file download PDF, so it doesn't show me what the server is in this particular case. So let's actually look at this link. So I'm going to copy the link, and then I'm going to paste it because I think it just opened the file itself. So this is where it points to. There we go. That's the actual link of the download resume, and it points to the securefilestorage.com. That's where it's pointing to. So there we go. Securefilestorage.com is indeed the answer. I should have looked at that a little bit more carefully. So now, using SSRF, make the application send the request to your attack box instead of the secure file storage. Are there any API keys in the intercepted request? So let's see. If I send it to my attack box, now I got to modify this a little bit and mess around with this. So that's the IP address of my attack box. So I'm going to modify this and see what we can get. Okay, so when I modify the link to actually point to my attack box, this is basically what it looks like right here. You could either use HTTP or no HTTP, but basically this is the IP address of my attack box. Okay, when I press enter on this, this is the response that I get, and at the top it says it's failed to connect to that IP on port 887, which means I actually need to establish that netcat listener. So I'm going to create a netcat listener real quick, and let's just use the same flags that they used in there. So LVP, and then they did it on port 80, but we're doing it on port 8087. That's the port that this is trying to connect to. So what we're going to do, let me get my terminal back up. So we're just going to do the netcat, and then we're going to do LVP, and then we're going to do 8087, press enter, and now we're listening on port 8087. So I'm going to go ahead one more time, press enter, and let's see if we get any kind. Oh, it's actually still processing, so it didn't automatically give me any kind of an error message. And on the background, we actually got that connection. So it says connection received on this specific IP. And then what do we get? We got the API key too. So there we go. That's our API key. And that would be the answer, the final answer to actually be able to process this. And so now it says there's a way to use SSRF to gain access to the site's admin area. Can you find it? So this is not required. So I'm going to just try. I'm going to try to see if we can actually do this. Okay, so in order for this to work, we need a few pieces of data. So number one, it says it can only be available from localhost. And then this is on the /admin domain. So if we go back over here, and I'm going to just stop my netcat listener real quick so we can just close this out. And just if we need to do that again, we'll just do it again. In this particular case, we need to change the server to this specific thing, which is going to be our HTTP and then /localhost dot and then I think admin, localhost admin, I believe that's what it is. I don't know if there needs to be a .com here. We can try it. We can try multiple variations, but we can only access it from the localhost /admin. And then, so let me see what happens if we do this. Still, we get an error. Okay, so let's do some, testing. We're going to do some trial and error here. Oh, interesting. Okay, so that worked. This is actually the flag that is available for the admin, and it's a PDF document that downloads, and the link that got us here is this. So we did the HTTP localhost. Admin is actually supposed to come after the port number, and then this right here is a URL encoded hashtag. So the way that I just went to a URL encode, and this is mostly because this is a way that we just created these links. Oh, interesting. So this actually worked, and basically it's just another PDF file that gives us the flag right here. this is the final URL that made it work. And originally, so if you're going to include a URL inside another URL, you need to make this whole thing be treated as if it's one entry. And in order to do that, you would put a hashtag at the end of it. And then the ID and everything still needs to be here. Now, if you put an actual hashtag at the end of it, it treats it as that it's like a fragment kind of a thing where it'll go to the part of the web page. So when you have a hashtag inside the URL, it'll try to find something in the web page that is, for example, ID equals whatever, and then it'll try to go to that portion of the web page. But we don't want it to do that. We want it to actually treat it as a literal hashtag so that it can treat this whole piece as one item instead of treating it as, okay, this is the link, and then this is the port number, and then this is the path that we were trying to go to. So to do that, we would actually turn this into an %23, which is a URL encoded hashtag. So that's the way that the server will treat that hashtag as instead of treating it as trying to find something on the page, it'll actually treat it as a literal hashtag, and then it will turn this whole segment into one item, and then it'll turn the full URL that you see here as one full item instead of having a URL that's inside of this URL. So the way that I did that, it was literally just go to I did URL encoder on Google, and then it brought me to this web page, and then from here I had that hashtag in here, and if you just put a hashtag or literally any character and then do encode, it'll just give you the URL encoded version, which is %23, and then we put that in the URL, and so the full URL ends up being the localhost on the port 8087/admin. So the /admin actually comes after the port, and then from there you would do the %23 so that it's a literal hashtag, and that the ID also still needs to be here in order for this whole thing to work. And then so when you press enter on this, you would end up with this document being presented on your page. It also downloads the document on the machine as well. And this is it. This is how we get our last flag. So this was actually a learning curve for me. I had to go and get some education on server-side request forgery and how to create a URL like this, because I'm not very experienced on it. So we both got to learn something interesting together, and we got the extra credit that was available on this particular task for this exercise. All right, so that was it for this entire room and this entire video that we did on OWASP Top 10. This was a really good way to conclude the web hacking module that is inside of the CySec 101 pathway of TryHackMe, and I really hope that you learned a lot when we went through this. This was a great refresher for me personally, and I actually got a lot out of it as well. So I really hope that you also got a lot out of this particular exercise and this video that we went through. And to get more stuff like this, I would encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out, especially in the CySec 101 playlist and this training series. And there's a lot of videos that are already on the channel that you can definitely go check out. There's a lot of playlists, and there's more playlists coming out. There's Network Plus that's going to be coming out in the next week or so, and then after that there's the AI integration with cybersecurity tools, which is a very, very big deal. So learning how to train AI is going to be one of the ultimate skills in the next 5, 10, 15, 20 years, because everything, as you can already see, is turning into AI. So all of that stuff is coming out. So again, I encourage you to like, subscribe, and turn on the notification bell so that you get notified when those things come out. But then also, I just want you to check out the comment section, because we really do have a lot of comments that come in from the community, and I'm very responsive in the comment section, and I will answer anything that comes in. If it's like a quick little response, then I'll respond to you in the comment section directly. If it requires a longer response, I'll create a video in response to your question, or even a playlist. So this entire CySec 101 playlist is something that is in response to Darnell Knight. I give him a shout out whenever I can. And so I am active in the comment section. I do respond to everybody in the comment section. So on top of liking, subscribing, and turning on the notification bell so that you get notified the next time that a video comes out. I do encourage that you drop a comment to ask a question if you just want to say hi, or if you want to say thanks. You can also say thanks by supporting this channel and joining the Hackaholics Anonymous community, which is the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master, and each tier gets their own Discord server and early access to content. The agent, guardian, and master levels, however, get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, and so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord servers and the Discord chats. If not, I hope I see you in the comment section on the channel, and that's it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I'll see you in the next video. Peace.